Hello and welcome everyone. In this series of chapters, we are going to learn a very famous tool or software that is called Terraform. In this course, we will integrate our Terraform with Azure. We will try to deploy all the infrastructure on Azure using our Terraform. Whether you are a working professional or even you are in college and preparing something, you definitely need Terraform nowadays. Integration with cloud of Terraform makes it also more powerful and gives us more flexibility to create infrastructure for us. In this series of chapters and in this course that is mainly depend on Terraform with Azure, we will try to create one more course which will be Terraform with AWS, and we will try to deploy AWS resources using Terraform. Now, you might ask one question, that is, if we have Azure, then why do you need Terraform? So, you might say the reason that automation, you may create deploying infrastructure from Azure to Azure from Terraform, but still for Azure, you have ARM, Azure Resource Manager template that you can use to deploy infrastructure. But why do you need Terraform? So, for deploying infrastructure on Azure, even using ARM templates, you need to understand their language, specifics, and modules. So, first you need to learn about them, and then you need to figure out how modules interact with each other. Similarly, if you want to learn about AWS and if you want to deploy infrastructure using AWS, you can definitely do that. And you can use CloudFormation to start deploying your infrastructure. But still, if you want to deploy using only AWS, you need to learn about their specific, their modules, and various options and parameters supported by these platforms. So you cannot rely on one cloud. Now, the Terraform, on the other hand, uses HCL, HashiCorp configuration language that can be integrated with your AWS, Azure, or Google Cloud, and you can deploy your infrastructure just by learning one configuration file. You just need to remember the commands and the configuration that you want to deploy, and it's done. You don't need to learn about a specific related to only AWS or only Azure or even only Google Cloud. So that is the reason behind using Terraform if you want to deploy infrastructure, whether you want to deploy it in AWS, Azure, or Google Cloud. So I'm hoping you are now aware of some basics and how Terraform is enlarging itself in the background nowadays. So let's learn about some key contents that we are going to cover in this course. So first we will learn about what is infrastructure as code and what is Terraform and how they are related to each other. Then we will come to the next chapter, and in the next chapter we'll learn about key concepts of Terraform. We'll see what are the concepts that you got with Terraform. After this, we will see what is the workflow of Terraform and then whether it align with the software development principle life cycles also or not, such as idempotent, immutability, and bunch of other options and principles. Okay, so we'll see that. We'll have a look on them. So after this, we will start our journey with hands-on demo, and we will start setting up our environment on Windows and Linux. And for this course, similar like my other courses, I will be performing all these things on my Linux VM. But if you haven't set up Linux VM, you can also use Windows VM or your Windows laptop. Okay. But as you are learning these things, I would suggest you to create and set up a VM on it because making changes on the VM won't affect your infrastructure or the underlying hardware. So if you are trying to practice anything directly on your laptop, so it might change some configuration. So it would be better to create a VM inside your laptop using your hypervisor and then try to practice all these things on that. For all my courses, I recommend to practice every time instead of just watching lecture because watching lecture won't help you. Also, if you are going to dive into DevOps world, I also recommend my friends to use Linux VM instead of Windows or Mac. So after setting up our environment with Terraform, we will move and we will set up our Azure and we will integrate our Azure with Terraform and then we will try to deploy some basic stuff using that. After this, we will come to the advanced topics and we will mainly deploy Azure Compute, means VMs, networking with help of Terraform. After this, we will deploy Azure IAM EntraID. Then we will also explore Azure API Terraform, which is helpful for triggering our ARM REST API that we can also use. And at the last chapter, we will discuss from this one, after covering all these topics and all these chapter, where should you head next? So all these things are coming one by one in the way. So no need to worry about this. If you feel that something is getting very confusing, take rest and come back, have a coffee and then come back. Also, whatever I will be doing on my VMs. I would also suggest you to please practice them side by side. Let me know if you face any issue while practicing them on your VM. With it, let's start our chapter 1. In this chapter, we will discuss about what is infrastructure as code and what is Terraform and how they are linked to each other. So traditionally, when developers has done their work, they used to package their or bundle their application and they will hand it over to the operations team. And they will provide a guidance in a written file that it needs to be deployed on this configuration. Now operations team will head over to their on-prem data center and they will free up the resources or buy the resources and then they will test it. Now, this whole process is completely manually. You need to set up your servers, networks, and storage. Now, as it is a manual intervention, then definitely it can lead to inconsistencies and human errors. Also, it is slow and hard to scale, right? Now, to overcome this, the cloud came. In the cloud also, you need to go to your Azure portal or your AWS portal. Then you have a click procedure for deploying any infrastructure, right? You need to configure or create VM manually, then you configure the network, and then you install the software, and then you are trying to deploy your basic SAP or bundle application. So that was the traditional infrastructure management method. Now to overcome this, we have infrastructure as code. In here, you write your code for your infrastructure. It is a practice of defining and managing infrastructure using code rather than manual intervention. As you are writing code for your infrastructure, it is completely automated and also it will provide you consistency across the environment. You also get version controlling. So suppose if you got any issue on a current update, you can enable rollback and you can roll back to the previous version. Also, it gives you flexibility of scaling and repeatability so that based on the demands, you can scale up, scale down, or even repeat the resources. So, unlike your manual intervention, you just having a click procedure, even you are using the cloud. Now you write some code just like this. We will come to this code later. This is example of Terraform itself. And you write the code and it will deploy all the infrastructure and all the related resources in the background for you. So I'm hoping you have understood infrastructure as code. Now the benefits you can already see. It's having a good speed instead of manual intervention. It's fully automated. You can have a repeatability here. You can just copy paste the code and it will give you the same setup for dev, test or prod environment. You can rely on this method because it is fully automated and it has reduced manual errors as it does not have any human intervention. Also, you can integrate it with your version control system such as Git so that if anything goes down, you can trace what are the recent changes were made and then you can roll it back to the previous version or the known version. Also, you can track it for who changes what. So that was about infrastructure as code, and you can see how it is very helpful as compared to the traditional method. Now with it, let's understand Terraform. Terraform works behind the concept of infrastructure as code. If you want to achieve infrastructure as code, so Terraform is a tool for that. It is developed by HashiCorp. It is an organization, and Terraform is an open source tool. Open source means anyone can use it, anyone can modify it. As it's not an advanced course, so I will not show you how you can change the behavior of Terraform commands or the background working. But Terraform is an open source and you can even change the behavior of Terraform commands itself. Terraform allow us to define, provision and manage infrastructure across multiple cloud providers like Azure, AWS and GCP, etc. using declarative configuration file. Now, how Terraform works, we will see this in our chapter 3 and 4 when we will be discussing about workflows. But just as an overview, as we are just starting Terraform, you should be aware of its working also. So first you write some configuration file with an extension .tf, which stands for Terraform itself, and it will use a language which is called HCL, which is HashiCorp configuration language, which is very similar to the combination of JSON and YML. While writing this file, you define the resources along with their name and the module used, and you try to deploy it. Once you write your code, you plan it. It will tell you what are the changes it's going to make, whether it's going to be unchanged, maintaining the idempotency behind this concept, whether it's going to create a resource, whether it's going to delete a resource, or whether if it is going to update a resource. So it will tell you all these things in the plan phase itself, and then after you apply it, it will automatically provision infrastructure as defined in this configuration file. Now Terraform will not authenticate to this cloud provider automatically. You need to set it up first, and then you can deploy the resources in the clouds itself. So that's it for chapter 1, in which we have discussed about infrastructure as code and what is Terraform and how they are linked to each other. Now let's move to the next chapter and let's learn about some key concept of Terraform, and let's start our Terraform journey. Hey guys, and welcome to chapter 2. In this chapter, we will learn about some key concepts of Terraform, some keyword that is used in Terraform while writing the configuration file. I am also hoping that you are now aware of infrastructure as code and how it is very helpful as compared to the traditional method. And also we have Terraform as a infrastructure as code tool, which is very helpful for multi-cloud deployment scenarios. So to continue this, let's discuss some key concept of Terraform. Terraform uses few fundamental concepts that makes it very powerful and easy to automate infrastructure. Now these concepts or these keywords are the base pillar of Terraform and you need to be aware of that. For all these concepts, for all these terminology and these terms, we will understand them each one by one in our demos. So no need to worry about that if you didn't follow these theoretically. We will try to cover them practically also. Okay. So with it, let's discuss about the very first concept of Terraform that is called the providers. Now, while writing the configuration file, you will use these keywords generally, all these concepts generally. So providers are like a plugin that let Terraform communicate with different platforms. So whenever you will specify provider, you need to specify what is the provider that you going to define. So if you are going to use Azure and if you want to define anything in Azure, you will write here Azure RM. So in here you will define provider, then Azure RM, then you will start your braces and you will define features. After this, you are ready to set up and the Terraform knows that you are going to use Azure to deploy your infrastructure in Azure. After this, you can specify bunch of stuff that is coming upcoming next. Similarly, for AWS, we have different thing, and for Google, we have different thing. Okay. Then next come resources. After you specify the provider, you need to define the resources. For example, the resources is a single piece of infrastructure that Terraform is going to manage for you. In here, you are going to create a single instance of your infrastructure, like your virtual machine, your network, storage account, your disk, or even your IAM instance. Here is the example of it. You define a resource keyword, then you need to specify Azure RM underscore resource underscore group. Now, these are completely defined by in the collaboration of Azure and Terraform. You cannot change them. It should be the same like this, but this is the name of the resource that it will get created. So you can change this one, but you cannot change this first value because it will define that what kind of resource it is. So it is resource group. Now after this, you will have some mandatory field that you need to mention. So for creating a resource group in Azure portal, you have to define name and location for sure. Similarly, if you are defining anything in AWS, you also have the same name and location as a parameter as mandatory. As I am a more like a Azure guy, so I know more about Azure. Now, once if you will deploy this, we will see all these things in upcoming chapters, how you can write this code and deploy or apply in the Terraform. But whenever you will deploy this piece of code, it will create a resource group in Azure with name RG. Okay. Now it will not work with just these 4 lines of code. It will work with these lines also. If you are not providing this providers Azure RM, it is not going to detect this one. Okay. So some keywords, some plugins are linked to each other. They needed some of each other to work perfectly. The next key concept is variables. So as the name suggests, you are already aware of this. So these are used to make configuration dynamically and reusable. If you have a location and suppose you have a long location name, so you can define it in a variable structure. Also, you can define in a variable file or folder itself. We will see this when we will be on our demo. Just for the concept understanding purpose, I am defining the code in here. So if you want to change the location in 7, 8 lines of structure, you are going to change just here, not in each offline of the code. Okay. So you are not going to change anything in the resources, which can lead to an human error itself. So you just come to the variable section and you just change from East US to West US and it's done. Now all the locations are ready to take West US as a default location. Okay. Terraform will store the current state of our infrastructure in a file called terraform.tf state, which will automatically create it. Now it will keep changes of all the track, whatever the Terraform had updated, destroyed, or even and added new ones. So basically, it works like a Terraform memory or a brain, which stores or keep track of all the changes of your Terraform infrastructure. The next concept is plan. So basically, whatever you are writing, you just write command terraform plan when and you need to write this command from the current directory where the .tf configuration file resides. So it will show you the execution plan, what will be created, updated, destroyed, or even unchanged. So this feature helps you to review all the changes before they actually apply to the infrastructure so that you can validate or if any change is needed, you can change it. The next concept is apply. Once you verify your infrastructure is good and it's ready to be committed, you can execute this plan and provision resources in the defined cloud infrastructure. For applying it, we have command called terraform apply and you need to make sure that you should be in the same directory in where your .tf file resides. In the background, Terraform will be reacting to your cloud provider's API to create your infrastructure whenever it will be triggering Terraform apply command. Next one is modules. So you have definitely worked on C, C++, or even Java or Python, and you have used functions, right? The functions are like reusable pieces in your code. Similarly, here we have modules. These are also the reusable pieces of your Terraform code, which you can use to directly deploy your infrastructure or a single entity of your infrastructure directly by specifying your module. You can provide a path or even a file and it will deploy it for you. You can also even use community modules from the Terraform registry, or even you can create your own. In the Terraform registry, there are millions of modules already there that you can use. You can go and check their description. If they suits for your environment, you can definitely use it. While using the modules, you need to make sure that you use only authorized modules and not the third party, as it may lead to any data protection issue in your organization. So you need to make sure that you are using official registry or the believed registry that you want to deploy it. The next one is outputs. Suppose if you have deployed any IP, such as a public IP for your VM, and if you want to access it, but whenever you are going to deploy your VM, even in Azure, once it's getting deployed, it will not show you the IP, right? It will just show you the deployment has been done. Then you used to go to your virtual machine overview page, then look for the public IP, and then you used to connect to the VM, correct? Now, to overcome this, we have features in Terraform that is called outputs. It will display the useful information after deployment. Just after creating the VM, you need to connect to your VM. Then, using output, you can have Terraform will show you the IP of that VM so that you can directly note it down and try to connect just after creating the VM. Instead of going to Azure portal, checking what resources it has created, or even you can go to the TF state file, the Terraform state file, and you can read the contents of the file that it has created. So output is very helpful if you want to display the useful information just after creating the resources. So these are the basic concept which relates to Terraform, and you should be aware of these concepts for sure if you are going to master Terraform. So that's it for this chapter. Let's meet in the next chapter. In the next chapter, we will understand Terraform workflows, and we will also understand some software development principle that is being followed by Terraform. So till then, take care everyone. Hello and welcome again everyone. In this chapter, we will understand Terraform workflows, how it works, what is the track of it, and also we will understand its principle that is similar to your software development lifecycle principles. Terraform workflow is very simpler. It goes from write to initialize, then plan, then apply, and then reapply if needed, and then destroy. Basically, here everything revolves around describing your infrastructure as code and keeping it consistent with the real world. With it, let's understand the very first step of this workflow, that is write phase. In here, you define your infrastructure as code. You write a .tf file. Basically, if you are going to rely on only one file, you will write main.tf file using HCL, which is HashiCorp configuration language. You define all the infrastructure resources in here itself. Here is the very first example of it, in which you are using Azure RM resource group. You are giving the resource group name and then the required parameter of your Azure resource group. That is the name and location. Now in here, you use a declarative specific. It is not an imperative way. Imperative means you are writing and providing the commands from the CLI itself. Those are the one line commands that is being sent to any cloud provider. But Terraform follows a declarative way in which we define what we want, not how to do it. In this very first stage, nothing is created it. It's just like drafting or writing your blueprint of your cloud infrastructure. Then next, we have an initialize phase in which Terraform initializes our working directory. If we have defined any provider, we have learned about provider in our second chapter, right? That was the very first concept when it comes to Terraform. So if we have specified any providers and if you are using cloud, then you might have definitely included provider. So Terraform in it will download necessary providers specifics. Then it will set up the backend where Terraform state will be stored also. The command for initializing a phase is Terraform init. You can think of init as setting up the tools Terraform needs to talk to your cloud provider. In the background, it will download all the configuration and the needed info to communicate with your Azure, AWS, or GCP. The third step is plan. Here, Terraform compares the code. It will fetch the details from what is presently at your infrastructure and then what is whatever if you have defined in your current code, that is the desired state. And then it will show you what action will be taken next, whether it's going to be create, update, deploy, or it's going to be unchanged. If you will type command terraform plan, it will give you output similar like this: 2 to add, 0 to change, and 0 to destroy. You can think your terraform plan as preview mode. Still, there are no changes made. You just see or you just running a dry run to validate your code before final deployment. Next, you have apply phase. In here, you execute the plan and provision infrastructure on your chosen cloud, whatever you have defined in the providers. Once it's done, Terraform also updates its state file, which is exact as same like this terraform.tf state with the new infrastructure details or the updated infrastructure detail. The command for it is terraform apply. You can think apply phase as Terraform now calls Cloud API in the background and builds exactly what you have declared. The next phase is state management. Using your terraform.tf state file, Terraform will store info about all the created resources in this state file. This state file is an actual snapshot that will help Terraform to track what exists so that it knows how to make future updates or deletion. Here is the very good and simple example for it. So if you will open this state file and if you have only deploy the resource group using our previous slide, so it will show you the contents like this. So you can think of your state file as a Terraform memory. It knows what's deployed and ensure the consistency across your infrastructure. The next phase is change management cycle. Suppose if you want to reapply anything or plan anything, so this also comes into a phase. Suppose if you change any code, you are going to rename a resources, or if you are going to change configuration of your resources, update any size, then you again need to terraform plan and then you again need to run terraform apply. So Terraform again compares new code with the existing state using your terraform.state file and applies only when it differences. If there is no change, it will not waste its time to redeploying that infrastructure. It will keep it unchanged. So here, Terraform does not recreate everything. It applies only the necessary changes thanks to its state tracking method. Then at the last phase, you have a destroy phase using command terraform destroy. Here, after verifying the resources that you don't need, you removes all the resources defined in your code from the cloud provider. So you need to run terraform destroy command. And again, whatever command you are running, you need to make sure that Your .tf extension file, your main.tf extension file, configuration file is in the same directory from where you are trying to run this command. So destroy helps us to tear down the infrastructure cleanly, useful for test setup or cost control, so that unused resources are going to delete. Now, once we are done with our Terraform workflows, let's understand Terraform principle, which principle it follows in the background while performing all this workflow and doing or deploying infrastructure. The first principle is idempotence. Idempotence means running the same code multiple times should always result in the same infrastructure state. So suppose if you haven't changed anything and you try to run Terraform apply command, so it is not going to redeploy those infrastructure again. If it detects that it's already done, it will give you the pop-up that no changes were made and your infrastructure was unmodified. So Terraform is idempotent indeed. Whether you apply once or 10 times, your infrastructure remain consistent with your code. The next principle is immutability. Instead of modifying existing infrastructure, Terraform often destroys and recreates it with the new configuration file. Suppose if you have created the resources, a virtual machine, so when you change the size, this Terraform recreates the VM instead of modifying it directly because it is going to change it, right? So it will first delete this resource, then it will it will keep the name of the VM same, but it will first delete it and then it will create again with the new resource or the new size. So Terraform prefers immutable infrastructure. It replaces resources instead of tweaking the live ones, ensuring clean and predictable environments. It has disadvantages also because it might take time to delete it and then recreate it, but more than disadvantage it has advantage so that it can be cleaner environment and error free. The next principle is encapsulation. It's all about hiding complexity inside reusable modules. So Terraform module is an example of encapsulation. In here, suppose if you define a module and if you define all these parameters inside it, you can use those modules combinedly to another infrastructure already. Inside the network module, you may define multiple resources here, same like we are doing here, your subnets, route table, etc. But user only need to call the module. They don't need to mention internal details or call the internal details. So we can say that encapsulation in Terraform is achieved using modules. They hide the internal details and expose only input or output variables. The next principle is cohesion. Each module or resource should do one specific job well. Suppose if we have a separate module, example network which handles VNet and subnet, compute which handles VMs, and the storage which handles storage account. So if you are going to specify Azure RM underscore virtual machine, so it's going to manage only virtual machine aspect while creating the resources. If you are going to mention the resources like network, then it's going to only manage the resources aspect related to network. It is not going to change anything in storage or compute. Each Terraform module should have high cohesion, means focusing on one function, making maintenance and reuse easier. The next principle is declarative versus imperative that we have discussed few slides back. Terraform follows the declarative way in which we describe the desired end state and Terraform decides how to achieve it. Deploying your infrastructure using imperative way, you can also do that. You can either use PowerShell or Bash if you are using Azure. Here is the example of imperative way using PowerShell in which you are creating a VM here. And here is a Terraform way for creating a VM using declarative way. So Terraform is declarative. You describe what you want and it figures out how to create it. The next important principle that Terraform follows is DRY. You must have heard in your software development practice. That is, don't repeat yourself.
The idea behind DRY is overcome using your array or list principles. You can use your arrays or list whenever you are trying to achieve DRY. It's DRY basically stands if you want to avoid writing the same code multiple times in your code. Here is the example of Terraform without dry and with dry. Without dry, you are defining the resources, and suppose if you are trying to create subnet, you are going to write each of these code one by one. Within this block, you might have 3 or 4 lines of code, and you are writing them again and again, and you are creating them. Using dry, we have used variable section using subnet, and we are going with the for loop for each loop, and it will take one by one each of these value, and it will assign these parameters for each of these subnet, so that we don't need to write 6 lines of code. And in here we got the same results using just 4 lines of code. So Terraform supports try principle using variables, loops, and modules, so that you can define once and reuse everywhere. So these were the basic principles and the workflows that Terraform follows. I am hoping you were clear with that. These are just a screenshot, but in the upcoming demo, we will be performing these actual things on our VMs, so that we will be seeing in the actual environments. Okay, so let's meet in the next chapter while setting up our Terraform in the different environment like our Linux VM or our Windows VM. Why I am saying VMs? Because in all of my courses, I only suggest to perform and to practice or to learn all these things on your VM itself instead of your laptop, which can change your underlying hardware if something goes wrong. So I would also suggest you to create a VM. If you want to create a Linux VM, then please go ahead and navigate to my Linux course, in which I have discussed about Linux in 10 hours of the course, and also you will see how I have set up Linux VM there. Okay, so let's meet in the next chapter. We will set up our Terraform in the next chapter, and then after that chapter, we will start our actual lab or hands-on in Terraform. So till then, take care everyone.
Hey again, let's start with chapter 4. In this chapter, we will set up our environment for Terraform and Azure. As I already mentioned while starting this course that we are going to be specific to Azure, let me know in the comment section if you want to have a course on Terraform with AWS also. But as this is an Azure based, so I will be focusing on Azure related resources while deploying using Terraform. So here we will be setting up our environment for Windows and Linux. Linux means Ubuntu based. As I don't have Mac OS, so I won't be able to illustrate you, but I will definitely go and tell you the steps while sharing my screen. Here we will try to set up and install our Terraform and Azure CLI that is needed, and also VS Code with the Terraform extension. I am hoping that if you are working along with me, you have already installed VS Code with you, but if you haven't yet, we will try to install VS Code also. Okay, so let's move on first on our Windows VM, and let's try to install all these things for working with Terraform. So I am on my Windows VM. Again, I am not going to do this directly on my main host, on my main laptop, because whatever I do for my learning or illustration purpose, I do it on a VM. Also, illustration of all Terraform examples I will be performing on my Ubuntu VM just for illustration purpose, and mainly students and folks are nowadays using Windows, so I am illustrating Windows. So let's go to the Google Chrome and let's search for Terraform install.
So here we will go to the very first link, or let's go to this one. Then we will come back. If you want, you can accept the privacy. Once you land on this page, you have two options to install on each operating system. The first one is either using a third party package manager or using manual installation. For me, I will be using package manager for installing on either of these hosts. So in here for Windows you have Chocolatey. You can install Chocolatey very easily. And for Mac OS you have package manager called Homebrew. If you have Homebrew installed, then you just need to type two commands and that's it. It will install the Terraform for you. If you have Windows, you need to install first Chocolatey. If you haven't installed Chocolatey yet, you can right click on it and you can go to here. Then I will click on install in here. Then we need to follow these along. Then I will copy these commands and I will use PowerShell admin to open this administrative PowerShell window. And I will paste this and I will hit enter. Now it will take some time and it will install Chocolatey on my Windows host. So let's wait for it to install. And looks like my Chocolatey was installed. I can verify the version, Choco version. Okay, so I have the version of 2.5.1. So now the Chocolatey package manager, which is a third party package manager, is installed. If you don't want to use any third party, then you can go ahead and follow the manual installation steps for, of course, Windows if you are on Windows. Now, Chocolatey was installed. Similarly, if you are on Mac OS, you can install Homebrew and then you can follow along. Once the installation was done, there is just one command that you need to run, which is choco install Terraform. So let's install this choco install Terraform. Now I need to type Y to accept all these things. Now you need to keep in mind that this is not the latest version that it is picking from Terraform. The Chocolatey developer are fetching first the latest and stable version for Terraform website and they are placing it on the Chocolatey. Suppose if you want to use a latest version, then you need to go ahead and follow the manual installation step for installing the latest step. But most probably the recent version would be on the Chocolatey. But just in case if it is not, then you can go ahead and follow the manual process. Now once our Terraform is done, we can type Terraform hyphen hyphen help to verify whether Terraform is installed or not. So once you have typed this, we have our Terraform installed and it's giving the options for it. Once the Terraform is installed, we need to also install AzCLI so that we can communicate with our resources. So I will type AzCLI install for Windows. For installing AzCLI on Windows, you can go ahead and follow these things. If you are on different OS, you can just navigate here. For example, for Mac OS, you can navigate and you can use Homebrew Package Manager. Here, I am on Windows, so not sure if it will tell you the status or installation from Chocolatey Package Manager because it's a third party and Microsoft will not suggest to install from third party. So you can go ahead and follow these things, or you can use third party managers such as Chocolatey Package Manager that we just installed. So we can type choco install azure-cli. So now it will install AzCLI for you using package manager. So you can see how it is easier for us to install AzCLI using our Chocolatey package manager. By the time it's installing, I will open my VS Code. If you haven't set up or if you haven't installed VS Code, it's pretty easy. You can type VS Code install. Then you can go to the official page and you can just download the exe and run it. That's it. So installation of VS Code is pretty easy. Now once it's been running, now in here on desktop, what I will do for all my lectures, as I will be doing all my demo on my Linux or Ubuntu VM, but if you are going to perform on it on your Windows OS, then you can create a folder on the desktop and follow me along and create all these things in your folder itself. So here let's give the name Terraform. I will open it. Now in here I will right click on it and I will click on open in terminal. Once it's open, I will type code dot so that it will open this folder in my VS Code. I can click and I can click on yes, I trust the authors. And in here, let's click on new file and let's give the name as main.tf. We will come to these things later, but once if I will click on this tf, it will give us a suggestion to install the recommendation extension for tf. In your case, it might not have detected once you written .tf configuration, so it will automatically give you here the pop-up for Terraform. So go ahead and install it because writing configuration and make it syntax error free, it will give you flexibility of it. Also, if you want to go and manually search for it, you can go ahead. You can go to the install section or you can search for Terraform. So here it is. I will go ahead and I will click on this. So you can go ahead, search for the Terraform extension and try to install it. So you need to install the official one, which is from HashiCorp, HashiCorp Terraform. Okay. If you want, you can also install this one. That one will also provide you functionality. But the owner of Terraform is HashiCorp, so you should install this one. Once it is done, you are ready to move ahead. Looks like our AZ was also installed. If I will type AZ hyphen hyphen version, I will type PowerShell, and if I will type AZ, so we can see now it is giving various option and it is supported. Okay, so your Azure CLI is installed. So in our Windows, we have installed first Terraform using our package manager Chocolatey. Then in my case, VS Code was already installed, so I just open it and we install Azure CLI, and we have also installed its extension, Terraform extension for VS Code, so that it will make our life easier for writing our Terraform configuration file. So I'm hoping we are ready with it using Windows. Let's see all these things on our Linux also, because moving forward I will be doing all this stuff on my Ubuntu VM. But if you haven't set up any Ubuntu VM yet, feel free to use Windows VM itself. Make sure to create one folder for your all the practice either on desktop and then open that folder in your VS Code. Now let's move ahead on our Linux VM. Now I am hoping your environment is set up in Windows VM or Windows OS. Now let's move ahead and let's set up our environment for Terraform and Azure in our Ubuntu VM. So I will open my browser and I will type Terraform install again, and I will go to the tutorials one. I will go to the very end. I will click on accept all, and again, okay, I have got some status for my security updates, so I will click on remind me later. As I am on Linux, I will click on Linux, and using Ubuntu or Debian, I need to use these commands. Okay, now let's try to install or run all these commands one by one. So I will copy this command. I will open my terminal. I will right click on it and I will paste it. It will ask for my password. Now I will wait for it and so that it will get updated. So it's done. There are some packages also which needs to be upgraded, so I can check it later. Now the next step is to add our HashiCorp GPG key. So I will copy this command again and I will right click on it and I will paste it. So it's also done. We didn't get any error. Now we can verify the added GPG key and it should give the output like this one. So it's done. Now we need to add the official HashiCorp repository to our system so that whenever we will run sudo apt-get update, it will check for that repository and it will fetch the latest Terraform version from that repository. So I will click on copy and I will paste these things again. Looks like it's done. We need to again run sudo apt update so that it will fetch the updated package from HashiCorp of Terraform. So looks like it's done. And if you will see in here, there should be a repository. Okay, so you can see that here it checked from HashiCorp and now we are able to access to the latest one. So now our last step is to install Terraform. So I will go ahead and I will try to install it. And looks like we are done. We can verify using Terraform --help. So we can see that now Terraform is installed on our system. Once the Terraform is installed, we can verify the installation using this command. We can also enable our tab completion whenever we are typing any Terraform command. So we can do that, but I will skip this and I will close this one. The next step is to install AzCLI on Linux. So I can type AzCLI on Linux. In my case, I think I have already installed it while illustrating in my earlier lecture. So if I will type only AZ, it should give me prompt. So yes, looks like I have already installed it. But in case if you haven't, you can go to the Ubuntu or Debian based in case you are using Debian or if you are using any other one. Okay. If you are not sure which OS flavor you are using, you can go to the install script any section. Once you are on Ubuntu or Debian page, you can go ahead. You need to be sure that you are either on these versions. Now either you can install with one command or you can follow along with the step-by-step installation instruction. In my case, I installed it with one command, which was this one. So you can also install it with this command and it will just install azCLI on your Linux one. Now that was the installation process of azCLI. Now we will install VS Code for my Linux. You can already see on my desktop, I also have VS Code installed on my Linux VM. But in case if you haven't, you can go ahead and you can install or download the Debian package from here. Now it will download the Debian package, and once the Debian package is downloaded, you can in the terminal you can navigate to your download page. If you will list the file, so you have your VS Code Debian package. Once you are in here, you can type sudo dpkg, okay, then -i for interaction, and then the if you will type code and put tab, it will automatically complete it, and you just need to hit enter. It will start installing VS Code for you. In my case, I already have it, so I will not go ahead. Now on your desktop, you can create one folder. So I will create one folder in here, new folder, and let's go give this name as Terraform so that I will install or store all of my Terraform practice stuff in this folder itself. I will open this one and I will right click on it and I will click on open in terminal. I will type code dot. Now this folder will be open in my VS Code. Again, You are right. You have guessed it right. I will click on one file and I will try to create a TF file in here. So once if I have typed main.tf, so I need to install the extension for it also. Now I will open my VS Code extension page from here, from these four blocks, and I will type Terraform. I will install the Terraform from HashiCorp and I will click on install. I will click on trust publisher and install, and the Terraform extension for VS Code will be also get installed for my VS Code. So now whatever syntax I will write, the Terraform extension will automatically get it correct. Okay. So in our Linux also we have installed Terraform, VS Code, AzCLI, and Terraform extension for VS Code. So now we are ready with all this configuration and all the setup. Let's move ahead and let's get started with working with Azure and Terraform together. Hey everyone and welcome back. Before starting our Terraform with the integration of Azure and before deploying our Azure infrastructure using Terraform, I would be discussing Terraform universal concept which will help you in gaining confidence in Terraform core concept. In this chapter, we will discuss some Terraform core building blocks, their examples, and also how they works in the backend. It will be very helpful in understanding Terraform from basics to advanced. Whether you are using AWS or Azure or even Google Cloud, you should be aware of this concept. So please do not miss this concept, because if you are going to start your Terraform journey, you should be aware of these. So let's start our this very important chapter. The very first thing I would like to talk about is creating our first resource. For that, I will move to my Ubuntu VM on which my Terraform is installed. I am on my Ubuntu VM on which I installed Terraform earlier, and also VS Code and Azure CLI were installed earlier. I will open this Terraform folder that was open earlier. I will right click on it and I will click on new folder. Let's give the folder name as basics 1, but you can give any name you like. And then in here, I will go inside this folder. I will right click on it and I will click on open in terminal. Now that folder was open in my terminal. I will type code and then dot, so that this folder will be open in the VS Code. Now I don't want to open my terminal window here, because I can use the feature of VS Code with the inbuilt terminal. So I can type either Control Shift and backslash, or I can just go in here and I can click on terminal and I can click on new terminal. So you can also use your terminal inside here itself. So the very first file we are going to create is, so I will click on the new file here and I will click on main.tf. For running any Terraform command, you will require this file name for sure. Whether you have other files, which we will discuss in future chapters, the file name is main with the extension of .tf means Terraform. The Terraform will always look for main.tf. For now, I will minimize the terminal a bit. Now, there is one more thing I would like you to tell you. Suppose if we are writing our Terraform configuration file in HashiCorp configuration language and we forget some syntax. Now, there is a setting in VS Code that you can enable, so that whenever you are writing this code or whenever you are writing this syntax, it will automatically do the HashiCorp syntaxing for you. So in here, I have opened the settings and I will search for format. Now in here, I will click on format on save. Okay, and it's done. Now I can write any configuration file, TF file or any file, and once if I will write any changes, it will automatically format depending on the file type. So the setting was done. I can close it. Now I am ready to move ahead. Now we will start writing our HashiCorp configuration language for deploying a very basic resource which is called a random string. Why I am taking random string, I will tell you in a bit. There are three building blocks for writing any piece or block of Terraform code. The first one is a type of block that you want to deploy or create. So in my case, I will be creating resource. And once I type resource, the extension of HashiCorp configuration language automatically given me this syntax. Now this one will be your provided based. That means suppose if you want to use your Azure provided based and if you want to create Azure based resources, then you need to specify those specific resources in here. And the name is whatever you can mention that's not to be specific. So you can put any name, but this one is the block type. What is the block type that you are going to create? So I am going to create a resource block. And what is the type of this block you are going to create? So I am going to create random underscore string. Now extension for my VS Code is smart enough to giving me suggestion that you should use this random underscore string. On the right hand side, you might be able to see that it is the official one, HashiCorp, and then it's a random 3 dot 2 dot something something. This is called a provider. In our case, the HashiCorp is provider itself for this random string resource. But suppose if you are using a Azure based thing, then it will give you suggestion for HashiCorp not. It will be like Azure forward slash their provider based resources. Alright. Now we have written the configuration file, but still there is some error. It means there is some needed parameters that is missing in here. To find out about any important parameter inside your block, you can always navigate to your web and you can search for the modules. So I will search for random provider Terraform. So if I will go in the very first link, which is of official documentation, if you want to also learn about various Terraform modules, so you can always navigate to registry.terraform.io and you can navigate to them. For example, if I will go to their very first link, registry.terraform.io, and if I will go to browse modules or let's go to browse providers, the upper one and leading one will be your cloud technologies like AWS, Azure, GCP, Kubernetes, Alibaba, and Oracle Cloud Infrastructure. If I will go to Azure, it will give you the list of all the resources that you can deploy using this one. If I will go to the documentation page, in the documentation page of Azure RM, in Terraform, our random provider name was only random. It is coming from the random provider that is officially uploaded by HashiCorp itself. But if we want to use Azure based resources to create here, so we will be using Azure RM providers here, which is by HashiCorp, but in the backend, it is deployed by Azure developer itself. Now on the documentation page of Azure RM, I can search for virtual machine. And if I will select the Azure RM underscore virtual machine, here will be all the use cases of these things. Now you can see that it is giving the example of deploying our Azure virtual machine, for example. Okay, so we'll come to these things later on, but for now, let's go ahead and check what are the needed parameters for our random provider. So I will go to the documentation section for my random. In here, I will go there and I was using random string for deploying a type of a basic resource. So I will click on this random string. It is giving us a use cases, but whenever we didn't write anything, it is still giving an error. It means it needed something for sure. So if I will go in the schema section of this documentation, you will see the required thing is the length, which is the number of length of the desired string, while the optional are lower, whether you want to have a lower characters, min lower, min numeric, min special, min upper, number, numeric, and many more stuff. So we'll be using all this for our example. For now, I am hoping now you are aware of this link, how you can use it. You can go to their provider section again and you can explore millions of providers and modules that you can use to deploy infrastructure using Terraform. So I will go to VS Code and I will provide length equal to 6. Okay, now whenever we have typed the recommendation thing, so it has removed the error lines. Now I will save it. Once it is saved, if it is still not formatted, if you haven't enabled the formatting option, you can type Terraform format. So it will also format your code if it is not being formatted. Okay. Now the very first command that you should run after writing your configuration file for the very first time is Terraform init. Basically, this command will connect to the backend of this provider and it will check its provider and it will download its necessary plugins and modules that is needed to run this or to create these resources. Okay, so once if I will hit enter, so we can see the details here. If I can maximize the window of it, initializing the backend, initializing the provider's plugin so that you can use this provider's plugin in your resource code. Also, whenever we type this command, we can see that it's giving out some files here. The very first folder structure we got was .terraform. It is a hidden file. If you want to enable it, you can enable it from the setting page. I can expand it. In here, we got a licensing, which is a public license that was initialized by my HashiCorp. And then there is a log.hcl file, which is also needed whenever we type Terraform in it. So whenever we will write some command, there will be also one file that will be coming here, which we will discuss soon. Now, once we have applied Terraform init, now the next thing we need to run is plan. Terraform plan. So once if I will type Terraform plan, it will tell you what is the plan, what it is going to add, change or destroy. So in our case, we are going to add one thing. We are going to deploy one type of a very basic resource. So it's telling the plan is to one to add. There is nothing to change and there is nothing to destroy. Now you can ignore this wording or kind of a message which we will overcome whenever you will type Terraform apply. Once you are done with Terraform plan and once you have verified that yeah, this one is you need, so I can type Terraform apply. Once if I will hit enter, it will ask for the confirmation here whether do you really want to execute this. So you need to type yes. Once if I will type yes, so it will tell you the apply was completed, resource 1 was added, 0 change and 0 destroyed. Alright. Now, if you will look on the file structure, in the file structure, you would be able to see the terraform.tfstate file that was created. Now, we didn't discuss it whenever we were discussing about the Terraform workflow, but this is the very important file that you have got there. Now, this file is like a snapshot of whatever infrastructure that you will be deploying here. If you will look on this tfstate file, it will give you the details about the current snapshot of your infrastructure. So if you will go here, it has created one resource here. If I will click on, it has created one resource. There were no outputs. We will expand our output also. Once, if I will expand the resources, it will give you the deployed resources details in this block. Now, if you will come inside the instance variant, you can see the attributes that it got. The ID of my random string was this one, and it given us the 6 character random string. The length was 6. As we haven't configured anything else, so the by default configured value will be here showing. The result of the string and the ID would be the same that it has deployed. Okay. By default, the upper is true, but what we can do, we can go to our main.tf file and we can again type upper equal to false. Okay, we can also type a special equal to false so that it will not take any special character. And let's also take lower equal to true so that it will only false. Okay, and I will save it. Once I have saved it, it has automatically applied my syntax for my Terraform. If I will again try Terraform plan, because I have already initialized my plugins for my provider, I don't need to run Terraform in it again. If I will type Terraform plan, so it will tell you that it has one thing to add, 0 to change, and 1 to destroy. As I discussed earlier, whenever you will change anything in your configuration file, it is not going to modify it. First, it is going to destroy it, and then it is going to recreate your infrastructure. Similarly, in the case of Azure VM, once if you will deploy your VM, and once if you will come back and modify anything, suppose if you want to modify the name of your NIC event, so what it will do, it will first delete the VM and then it will try to redeploy it. So once we are done with it, what we can do, we can type Terraform apply. I need to again type the confirmation, so I will type yes. And you can see the resources, one was added and one was destroyed. Now there is one more folder that we have in here, which is terraform.tfstate.backup, which is the earlier version of the snapshot of your infrastructure that was created. You can store them in a state backend file so that you can use or to roll back your infrastructure again, which we might discuss earlier because this is a very advanced topic. Now, if I will go to the recent version of tfstate file, not the backup file, so I can see that in here the lower was true. So all these characters are in lower case and also there are no special case. I am hoping you have also successfully deployed your very first resource type using Terraform. Now once we are done with it, what we can do, we can type Terraform destroy. This is the command that you won't be using much. This is a very rare use cases of this command in Terraform. It is rarely used in Terraform, but as we have discussed a very basic resource that we don't want to keep it, so we destroy it for our illustration purpose. So I will type Terraform destroy. Now I need to type, do you really want to destroy our all the resources? So I will give the confirmation as yes. It is also giving us the plan that it is going to nothing add, nothing change, but it is going to destroy. I will provide confirmation and I will type enter. Now you can see my demonstration was completed and there was no resource currently. If I will go to the terraform.tfstate file, so you can see that it has only basic thing, basic block in the JSON format, but the resources block is now empty. The terraform.tfstate.backup would be replaced with the just previous created infrastructure, which is 9E9M96. Before that, this folder was containing the earlier infrastructure. Okay, so I'm hoping you were able to understand the core workflow and the core concept of this Terraform. Let's discuss about some more concept, the core concept or the core building blocks of Terraform. Now, let's understand how you can pass input parameters also whenever you are writing your Terraform configuration file. For that, I will again move to my Ubuntu VM, and in here, for passing the parameters, you need to create one file called variables.tf. Obviously, you can integrate and you can add your variables in the main.tf file itself. But suppose if you have tons of resources that you are going to create. So do you want to keep your variables in the same file where the resources are also there? Or would you prefer another file or another configuration file in which only variables are stored? If you are also techie like me, you will prefer that you should store all variables in the file called variables.tf. Now the name is strictly variables.tf what it will do whenever you will define any variable in here, so you can take the reference of your variable from variables.file using var dot. Whenever you will type var dot, so it will take the reference from the variables.tf file. We are many things related to variables and input variables upcoming. So stay with me. We will discuss all these things in the detail with example. For now, I am not going to make any changes in my main.tf, so I will keep it as it is and I will move to variables.tf file. Now the block type in the variables you would like to mention is variable. Okay, so this one is the variable type. Now what is the variable name that you would like to give? So let's give it as app underscore name. Okay, you can definitely provide a default value, but I would not do that. I will keep it as it is, and you can see we haven't written anything in this block of code, and also it is not giving any error. That means it can be written with it also. I will save it. Once if I will go in here and once if I will type Terraform plan, so here it is asking for a var.app name that you haven't provided. So you need to provide before moving forward. So let's give the app name as DevOps channel 23. So once if I will hit enter, so it is giving that it is a numeric. The result will be known after the apply. The special is false and the upper is false. We can also provide Terraform plan, and we can also provide variable while writing the Terraform commands in the CLI itself. So I can type Terraform plan hyphen var, and then I can provide app underscore name would be, let's give only DevOps. So once if I will hit enter, it will tell you that it's also going want to add 0 to change and 0 to destroy, because earlier we didn't create it. The Terraform plan was only executed before that. So it didn't deploy your infrastructure, it was giving you the plan. Similarly, whenever we type Terraform plan where, so it's also it didn't execute. It giving the plan that hey, it's going to deploy one resource. Okay, now let's see how we can define local variables. The local variables means if you want to deploy or if you want to call any variable directly from main.tf file instead of variables.tf file. So let's see this also. I will go to main.tf file. I will go to the very first line, and in here you can mention locals. Now once you have mentioned locals, what it will do, it will set the value of what is the variable name that you will mention here. In my case, I can mention app underscore name, and let's give the name as DevOps channel 23. And as it's a string, so I need to put it in the double quotes. We'll see the use cases soon, but for now, let's mention this one. So once if I will save it, we have mentioned the value of our variable in our main.tf file itself. So you can define the locals variable name in here itself. Now this is kind of a variable name that you are going to create here. Now instead of app name, let's change it to the environment name. Environment underscore name, and let's give the environment name as prod. Alright, I will save it. So now it has created a local variable called env underscore name, and we have assigned the string of value which is prod. So that's how you can define your local variable and also how you can define your variables. Now let's see how you can display the value of variables or input variables or the local variables that you have set. So you might be thinking that for main.tf we have one main.tf file which is a main file. Then for variable we have variables.tf file. So for output displaying our output also we have outputs.tf file. But again, if you want to display your file inside from the main.tf file again, you can definitely do that. but I like to keep the things separate and not look messy. So I will create another file in here which called output.tf. The block name of variables was variable, right? So you need to be sure that it's a singular version while the file name was plural. Similarly, for outputs.tf, we have the block type name of output. Whenever we typed enter, so it's giving our format. Now here it's a red cross. That means it definitely needs some parameter. So yes, it will need. The need is what is the name that you are going to display here. Now the name here I would like to create is app underscore name. Okay, so that is the output name that you would like to create. So I want to display app underscore name. Now in here from where you want to show the value. So for this one, I want to show the value from where dot. It will take the reference from this one and the name was app underscore name. Okay, so whatever value if we will set here, for now we were setting these variables, value of these variables using our CLI. So we'll do that and it will show the value to this outputs.tf file and it will pass it in here. Now what about the locals variable? How you can access them? So accessing the local variables also is pretty easier. You will use another block type of output. The name you would like to give is env underscore name. And how you will access the value? The value you will access as local dot env name. Okay, so it's not plural, it's not locals, it's local. So be very careful with it. Okay, so I will save it. Now what I will do, I will type Terraform apply. So as we haven't specified any variables, we haven't specified any app name, so it will ask for an app name for sure. So let's mention the app name as DevOps. I will hit enter. Now it will give you that this one is the plan. Plan is to add, which is app name would be DevOps and environment name would be set to prod. Do you want to apply this action? So we didn't type Terraform plan, we directly type Terraform apply. So I will give the confirmation as yes and I will hit enter. So now you can see if you haven't specified outputs.tf, it will not give you this block. So this block will be not there. But you have mentioned output.tf, so this block will be given. All right. Again, if you don't want to specify or if you directly want to give output of any outputs, in the CLI itself, you can use command called Terraform output and then the variable name. In our case is app underscore name. So it will give you the output in the CLI itself. So there are bunch of outputs that you are taking from there. So you can directly type this one with the variable name. So it will paste you the value. This will be very helpful whenever you are working with thousands of variables in your infrastructure or the configuration file. Here again, there is a way that you can use your string interpolation in your configuration file. You might have definitely used a JSON template or Jinja 2 templating for accessing your variables. Similarly, the hashing of configuration language also follows the same syntax. So let's see that. If I will go to main.tf file and if I will go to the locals, what I can do, I can create one more locals in here. And in here, I will give the name as env underscore prefix and I will assign it to the variable called DevOps, then prod. Okay, my app name and then my environment name, right? But I don't want to use it because whenever I will change my code, whenever I will change my variable, I need to go through all these thousand lines of code again and then I need to change it manually. So let's use string interpolation here and let's call our variable our vars in here. So DevOps was our variable name. So how I can call it? I can use dollar and then curly braces. Now in here you can mention the string. So where dot app underscore name. If you will not mention this string interpolation syntax here, it will give you an error. Similarly for prod, it's the environment name. So what I can do, I can type dollar, then curly braces, then I can type where, or it was set as a local, right? So what I can type local dot env underscore name. I will save it. I will go to the output section and I will again give one more block of environment underscore prefix, and I will take the value as what was the value? The value would be local dot environment prefix. I will save it and I will try to apply it again with the name of env underscore prefix. So it will tell you that it will not found because first you need to apply the configuration, then only it will be storing in your tf state file. The Terraform output command will look inside the terraform.tf state file, its configuration, and then it is outputting it. Do not underestimate this command, and you need to, so it will not work if you haven't applied that current configuration. So first I will type terraform apply. I need to type a app name, so let's give it DevOps, and I need to provide the confirmation whether you want to deploy a resource. The change that is going to happen is it's going to only add environment prefix. I will type yes and I will hit enter. Now you can see using string interpolation we have outputted our environment underscore prefix also. If I want to use now Terraform output env underscore prefix, so it will be also giving you the same output. Okay, now let's move ahead. I'm hoping you are clear till now. Let me know in the comment section if you are facing any issues. For now, we were using the latest version of random provider, which is by HashiCorp itself, to deploy our basic resources in the Terraform. But what if you want to specify more providers with a specific version of their provided version? Let's see how you can do that. In the earlier version of Terraform, you might be creating one file called providers.tf. But in the recent version of Terraform, they have changed and you need to create a file called versions.ef. For specifying any specific version or provider, you can always navigate to the Terraform registry, and then in here you can go to any registry and then you can click on use this provider. Whenever you will expand this one, you will get the block of code that you can use in your versions.tf file. So I can copy this file and I can paste it inside my versions.tf. Now once if I will save it and once if I will apply Terraform in it, so now you can see that the version might be changed because earlier I might be using another version, but now this time I'm using version 3.7.2. So that's how you can navigate to the Terraform registry. You can explore thousands and millions of providers here, and then you can see how you can use them. For example, if I want to use the providers of Azure, I can go to the Azure, then I can click on use provider, and the Azure, for using the Azure RM provider, you can copy this block of code and then you can mention it. Okay. Although if you don't want to mention it, you might directly specify in the resource block of Azure RM underscore virtual underscore machine. So it will also try to fetch the Azure RM providers from the HashiCorp registry itself. But it is a best practice. You should specify the version so that it is not going to take a random version from the HashiCorp. It is always recommended to use the stable and patched version for your providers. Alright,
Now, let's discuss all about input variables, how you can play with them, how you can pass default input variables and their values in your Terraform configurations. For that, I will again move to my Ubuntu VM. Now, in here, I will close the unnecessary tabs in here. To define the values of your variable, you can create one file called terraform.tf vars. Now, either you can create this one or default.auto.tfvar file. Anything will work fine. But I use terraform.tfvar files. Now in here I can use app
underscore name, and the app store name, let's give it as DevOps 1.
Now I have only taken terraform.tf var file to use this in here. I will save it. Now what I can do, I can type terraform apply. So once if I will hit enter, it will provide me the confirmation. Once if I will type yes, so you can see the app name was replaced with DevOps 1. But if I will go to main.tf file, so that means I have replaced my value of app underscore name variable to DevOps 1 value. Okay. And it is also expanding in by environment underscore prefix. Now my question is, suppose you have different environments like prod environment or test environment. So how you can keep the value of these things in the different file? So for that, you can use your random tfvar files also. For example, dev.tfvars, dev.tfvars, or even prod.tfvars. Now, what you can do, you can specify the app name. You can use it from the here. And suppose in the dev environment, you want to change the app name as DevOps 1 hyphen env or DevOps name under hyphen dev. Okay. And in the prod environment, you want to paste the name as DevOps 1 hyphen prod. Now, how you will apply this configuration file specific to this tfvars? You don't want to apply this terraform.tfvars, which is a default file. So for that, you can again go and you can again type terraform apply. Now in here, there is a special option that you can specify, which is where hyphen file and the where hyphen file, and then you can specify the name of your file that you want to take. For example, if you are currently working in the dev environment, you can take the variable file name as dev.tfvars. So I will type dev and I will type tab. It will automatically complete it. So once if I will hit enter, it will give me the option. I will type yes. Now you can see my DevOps 1 dev was changed. In my dev environment, the app name was changed. Similarly, if I want to change the name in my prod environment, I can just remove it and I can type prod. I can hit enter. I can provide confirmation yes, and I will hit enter. So now in my prod environment, the application name was also changed. Similarly, we haven't changed environment name, but you can also change it. All right. Now suppose there is one sensitive data in your file. Now how you are going to play with it? How you are going to mention in the configuration file? For example, I will go to variables.tf file and in here I will use variables and then API key because API keys are sensitive, right? So I don't want to mention variables, it will be variable and then I can mention it here. Now in here, if I will leave it as it is, so whatever I will type, you will be able to see it, right? So let's see that once if I will save it and once if I will type terraform apply any configuration file, let's not mention these. I will go with the default terraform.tfr files. Once if I will hit enter, it is asking for a API key value, right? So once if I will mention like FGHN, so you are able to see that. And also the Terraform is storing that value in the front end itself, right? Now, what if this value is very sensitive? So for that, you can mention sensitive equal to true. After deploying, if you will go to the tf.state file, it will be showing you the value. But in the front end, it has hide your API key. Again, if I will go to outputs.tf file and if I want to display my API key also, so output and let's give the name as API underscore key and the value I want to take it as var dot API key. So do you think it will display because we have set our variables API key as true? So let's try that. I will apply Terraform apply. I will mention a API key. Now believe me, I am going to type number. I have typed but because of the sensitive parameter, it is not going to show you. Once if I will hit enter, now what you will get, you will get that it is error. It is not going to show you anything in the output block, and you should be able to, you should also mention sensitive equal to true in your output block, right? So you can also see this pop up here. So in the output also we will mark it as sensitive equal to true. Now I will save it and I will try to apply it again. I will enter my API key as numbers this time and I will hit enter. I will provide confirmation as yes and I will hit enter. Now you can see it is not giving my API key in here because it's sensitive. But still, if you will go to the TF state file and if you will go to the output section, in my case, I have some outputs. The API key is here and it's sensitive, but the value is true. So in the backend, in the TF state file, it's actually storing its value because it's needed, of course, for restoring purpose. But in the front end, it's not going to show you at all. So that's how you can play and mention the sensitive data in your Terraform configurations file, right? Now, there is one more thing I would like to discuss here. Suppose if you do not want to mention these things here or outputs.tf or prod.tf.fars file or even terraform.tf far files, and if you want that your system, your main host should be take care of this variable value. So you can use environment variable in this case. If you are using PowerShell, you will use env, then colon, then the value name of your environment variable. The environment variable name is tf underscore var, and then your variable name, in my case, app underscore name. And then you will set it to, let's give the app name as DevOps 2. So this is for your PowerShell, but I am using Bash, and in Bash you might be already know I can use my export command to store any variable's value in my environment variable. Now the environment variable always start with tf underscore var, which will be showing that whatever you are going to write after it, it will be storing as a Terraform variable. Now the variable name that I am going to use is API underscore key because I don't want to mention API key again and again while writing my code. And then I'm going to mention API key as numbers 1, 2, 3. Once if I will hit enter, my variable was set. If I want to recall it, I can also type dollar and this value and it will be showing you. Now the variable of this value was set. So now if I will type Terraform apply again, so this time it didn't ask me for my API key because it was already passed using environment variable. I'll provide confirmation yes and I will hit enter. Now the API key is sensitive again, even we have provided using environment variable. If I will go to terraform.tf state file, now you can see that it was changed from numbers 1 to numbers 1 to 3. Same like we did and we passed from our environment variable. Okay, so I'm hoping you are now confident in how we can play with input variables. Let's move ahead. Now you have seen the various way of passing, selecting and displaying data from the input variables. Now let's see what is the precedence of it. Because the value of same variable I can call from prod.tfrs, dev.tfrs, terraform.tfrs, even from my environment variable or even from a custom variable like var.file or even from -var parameters. Now what do you think? How Terraform will take precedence of any of these? The uppermost priority of this precedence is using your environment variable. For example, we have defined API key as numbers 1 to 3 in here using our environment variable. If you will define this API key value inside any of these files, even in dev.tfrs or prod.tfrs or the terraform.tfrs, it is not going to overwrite it because we have mentioned it as an environment variable. So the highest priority is from the environment variables. The next priority is from the command line argument, which is -var that we have provided earlier. So whenever we will type Terraform apply -var, so after that, first the Terraform will look for the environment variable. So I will write in here the first priority. The first priority will be your environment variable. The second priority will be your command line argument using -var option. Third order priority would be your command line argument var file, means taking the variable's value from your var file. The fourth precedence would be terraform.tfvar files or terraform.tfvars.json file. The fifth priority will be your auto files, means anything like xyz.auto.tfvar files. The sixth priority will be your values inside variables block. What I am saying here, if you will go to the variable section and if you will mention the default, here default value would be, let's say it as, let's take it as DevOps 23. So what it will be do, if you are going to mention app name, if you are going to mention app name in terraform.tfvars, and if you have mentioned in here also, so this one will be taking priority. So please take a screenshot. I was not able to mention this in my PPT, but you can take the screenshot from here. So this one is the highest priority and this one is the lowest priority. Okay, so let's see the use cases of it. So for now I will comment it. For commenting it, you can use terraform then star forward slash then star, and then in here also you can end the comment. So this is how you will do the multi-line comment. For single line comment, you can mention hash or double forward slash. So it will do the comments also. Now in here we have mentioned API key as numbers 1 to 3, but let's not use that. I will go to dev.tfvars and you can see I have mentioned DevOps 1. So let's close this. In terraform.tfs, we have mentioned DevOps, so I will save it. DevOps.tfvar contains, so in terraform.tfvars, the app name is DevOps. In dev.tfvars, the app name is DevOps1, right? Now, in the main block, if I will go to the variables block, if I will go to the app name, so it has DevOps23. So let's try to apply all these things together. Okay, and let's see what is the precedent. Does it follows our precedence or not? So I will go in here and I will type Terraform apply and I will apply -var -file, and we need to specify dev.tfvars because this one will be taken by default. This one will be taken by default, but for providing this one, we need to specify var-file. So once if I will hit enter, so you can see my app name was changed to DevOps1. Now the DevOps1 was, what was it? It was from our file. Okay. So we have gone here. So you can see the var.file here taking the precedence of terraform.tfvar files, the values inside or the auto.tfvars. Now let's try to mention -var and let's see the order precedence. So if I will again type this one and now in here, if I will type var app underscore name equal to DevOps 4. So once if I will type yes, so now you can see the -var has taken more precedence than -var -file also. So now DevOps 4 were replaced because we have specified -var also. Now what if you change the order of this var.tf1? So let's see that. I will take this one and I will copy it and I will also close this one. I will go to the very end and I will paste it. Now once if I will hit enter, I'll provide confirmation. So now you can see the app name was changed to DevOps 1. So do you think it's why? Because this time it didn't follow this precedent. It followed the order of execution that we have provided in the command. So first it tried to fetch all these things from var. So it tried to take DevOps 4. But after this, once it went to this one, so the Terraform has changed its state and it replaced from dev.tf vars. Okay, so I'm hoping you have understood about the order of execution, how it's execute, and also the order precedence of our variables. So I'm hoping you are clear with it. Now let's move ahead.
Now, let's see different type of input variables that you can use to pass in your configuration HashiCorp configuration file. I will move to my Ubuntu VM where I have bunch of folder that I have created, folder and files. Now in here, I can go to my variables.tf file, and by default, we were checking that the variables app name, it was string. So now how do you know that? Because we are mentioning in the double quotes and we are mentioning any value in here. If you will also hover over it, so it will give you the type of string. But it is best practice to mention type as string here. Similarly, you have different type of input variables like boolean, numbers, list, map. So let's see them also. So I will add one more variable in here, and let's call it as an replicas, and the type of the replicas would be number, right? So I am taking the related example related to your Azure, because suppose if we will be deploying, yeah, our infrastructure on Azure, so these things will be relatable. Okay. And I will not take the default of any replicas. I will keep them as it is. So that's how you can mention the replicas. Now I'm not going to mention the dev.tf vars or prod.tf vars files. I will use terraform.tf vars, our default terraform.tf vars values instead. Now in here, the value of variables I can take this, of course. So the replicas count that I can take is, let's take it as 4. Now if you will pass string here like goat, whenever you will type to run or apply this, it will throw you an error. So let's also pass this in your output variable. I don't need this, so I can remove this one. I can keep the API key, or I can remove them also. I can mention output, and the output name would be your replicas, and I can take value as var.replicas, right? So I will save it, and I will save the variables.tf files also. Now I will apply, and this time I don't need to specify hyphen var or var file because I'm going to pass my default terraform.tf var files. Right? Once if I will hit enter, so I will get an error because it was needed an integer but it got string, so that's an error. So I will change it back to integer. And now if I will try, I will not going to apply the infrastructure right now. I will type Terraform plan and it will validate for me. So you can see that we have deleted all these things. We have deleted this also because we have removed default. We have also removed these two from our variables dot or outputs dot tfrs, but we have added this one. So it's good. The next variable type, input variable types that I want to discuss is a type of boolean. So I can type variable and we will check whether it is enabled or not, right? And then I will give the type as bool. Okay, so I will save it. Now in here I need to go ahead and pass the enabled equal to false or to whatever it is. So currently it's false, so the value of my enabled is type of bool. But if I will assign it to any integer or any string, so it will give me the error. Similarly, I can try to apply it also. I can just try to plan it and it will give me the things. Okay, so I didn't mention in the output, so I can take this output enabled. And how I can take the value? The value I can take it from where dot enabled. I can save it and I can try to again apply Terraform plan. So now you can see, now it will give you enable also, enabled value also as false, right? Now the next important stuff that we are going to cover, the input variable type, these are important of course. First one is the list of string. So I will give also commenting also. So this will be list of string. Of course, you can give list of anything you want. So I will give the block name as variable and I will give regions because in your cloud infrastructure, you will be deploying your infrastructure in the region based, right? So you can define regions here. Now in here, you can define type and type you can define as list. Now in here you can define any as any list of variable, but I want a string because region will contain the name of my countries or zones. So I need to provide the strings here. I will save it. So now it's done. Now how I will pass the values of it in my terraform.tf parts. So it would be very simple. You might have already done it in your Java or C Sharp languaging. You just need to provide the values in the arrays of a list. Okay. So let's give it as East US and then comma, then space, and then West US. I will save it and how you will access the values. So for accessing the values, I can type outputs and let's give the values as regions and I can access the value region equal to where dot regions, right? I will save it. So now I have saved it and I will try to apply Terraform, apply. I provide yes. Now if I will go in here, so you can see it's giving the regions to list East US, West US. But what if you want to access East US or West US? How you can provide that? As you have provided a list of strings, so you can access those data or those indexes using your indexes. So the very first one will be your zeroth index and the second one will be your at first index. So in here I can mention 1. Now I have saved it and once if I will try to apply it again, so I will type yes. So now we can see that we are getting regions at West US. All right. Similarly, we can add our map input types. So these are just like your key value pair that you can specify instead of just values similar like your string. So in here you just need to specify map and let's specify region replicas and in here I will mention type as map of. I can again mention any but I will again go ahead and mention string. Okay. Now how you will assign the values of this environment variable. So for that, what you need to do, you need to specify a code of block. So if I will go to region replicas, you can see as we have mentioned as map, the syntaxing of HashiCorp language for my VS Code extension is already giving me the syntax how you can input the values. So it's like key value pairs. So let's enter them quickly. So West US replicas will be 4, East US and the replicas will be 3. Okay. Now I will save it. Now how you will access those values. So let's see this output region replicas and I will access the values by again using where dot. I can use region replicas where dot region replicas. So it will provide me the list again of this kind, right? This kind. But I don't want that. Suppose if I want to get the instance count of my West US. So instead of providing index similar like your list, we are going to provide the key of that map. So if I want the instance count of East US, so I need to provide East US as an index for accessing my value. So I will provide East US and I will save it. Now, if I will again try to apply Terraform apply, okay, so looks like we are getting some error. Looks like we need to specify double quotes because this is a string. I will save it and let's try to apply it again. I'll provide yes. And now you can see that using your replicas, you are getting those values. Now you might be wondering that here it's saying West US, but here it's saying replicas. So now how you can get these things here? So for that, how you can get, suppose it's a region. So in here you can pass regions here itself. Means you can embed your this output to this output, so that if it is residing in the region replicas, so it will get its data and it will directly paste it here. So in here I will provide where dot regions and then my index name, so suppose 1. So now if I will try to apply my things again, yes, so now you will get the regions as West US and its relevant replica. Okay, so that's how you are getting the West US and its replicas as 2. So now let's move ahead. I will also remove some unnecessary stuff in here and I will save it because I don't need. Now let's discuss about one more type of input variable that is called set. So the set is like similar like your list. Instead, it's just a combination of your list and map. The list was of ordered set, but in here it's an not ordered. So if I want to use the set, so I can again use variables and let's see the use of region underscore set. And then I in the type, of course, I can take it the set as any, but in here I will use string, the set of string, and I will save it. Now I can go to my terraform.tf files and instead of and I can again go to my variables dot my terraform.tf files file and I can specify region set and I can specify values like West US and East US. Now you might be wondering that what is the difference between the list and set here, because they are providing the similar cases, right? Now, the very big difference between a list and your set is the list allows duplication, means in here in regions you can specify one more regions and you can specify again East US. But in set of regions you won't be able to specify West US or East US again. So set does not allow for duplication. Also, the list is like your order, means it will you will be able to access the resource here using the indexes. But in case of set, these are completely unordered, means they are not limited that they are going to be in the same order. Okay, indexing is not allowed. For accessing using index, you need to first convert them to the list. Okay, so let's go ahead and let's access the set also. For accessing the set, you can go to your output.txt and you can mention output and let me give the name as replicas underscore count, and in here you will give the value of your set. So you cannot access using where, so first you need to convert it to list, right? And then you need to specify its value. So what is the value? The value would be where dot. Now what is the value of it? The value of it would be region set, right? Where dot region set and what its index? So index will be 0. Okay. So let me save it and let me try to apply it again. I will provide yes. Now you can see the region replicas count of my set 0. So I have given replica set, but it's a region set. So region set will be East US. All right. Now with it, let's move ahead. I will clear the terminal in my VS Code itself and let's move ahead. Now we have gone through and discussed various type of input variables like your list, map, and your boolean, map, and set type also. Now let's see how you can validate your inputs and you are not going to allow user to deploy the infrastructure if they are not going under this validation. Okay. So for that also I will again go here. Now I will go to my variable section and instead in my app name section, I will go ahead and I will add a block of code for validation. For adding a validation, I just need to type validation here. You need to specify two things. The first one is condition and the second one is error message. The condition could be anything using your and or operator. So in here, I will go ahead and I will use length. So it will check for the length of if the length of where dot application or app name is less than or equal to 6, then it should give the value error message as application name should be, so here I will specify less than 6 character. Okay, so here is 8, so I think it should throw an error. So let's try to apply it again. Terraform apply. So okay, now looks like we didn't get any error because the app name is taking DevOps itself. So let me go to my terraform.tfr files and let me remove, or let me give here itself y23, and I will save it. And let me try to apply it again. So now once if I have make it to the 8 character DevOps 23, so now it is of 8 characters. So it will trigger my validation and it will tell you that application name should be less than 6 characters. So here is my the very first validation here. Then I can again roll it back to my 6 character and it will remove the error, right? Now you can also again make your AND operator or operator to check with the other things. For example, if the replicas, so in here I can, instead of moving here, I can go in here and I can mention the validation for my replicas. So validation, I can give condition, and I can give the condition as where dot replicas should be greater than 2, and at the same time where dot replicas, not region replicas, it will be replicas, should be less than 6. So it should define the error message as your replicas should be greater than 2 but less than 6, right? So let's see what is our replicas here. So if I will go to my terraform.tf and replicas, so I have 2, but it's checking for it should be greater than 2. So once if I will try to apply it again, as I have replicas as 2, so it's giving the validation here. Now if I will change it to 3, so it's within my validation because it's between 2 to 6. The 3 is between 2 to 6. So if I will try to apply Terraform apply, so it will give me that hey, the validation was also successful and it is going to change this output that was earlier 2 to 3. Okay. So yes, if you want, you can go ahead and type yes. And now let's move ahead. So hooray, you have made it and you have also successfully validated your inputs, and you can validate depending on based on the condition that you will define. Of course, you can modify your validation parameters or conditions using AND or operators. Now let's learn about one very important aspect in Terraform, which is called Terraform workspaces. In here, suppose in your prod environment, if you want different type of replica, suppose in your prod environment you don't need 3 replicas, or in your disaster recovery environment you just need 1 replica because they used very often. So how you will specify that? So for that you can use something called Terraform workspaces. Of course, unlike we learned earlier, we can define dev.tf vars, we can specify replicas here, and while running our terraform command we can specify -var -file, right? So if I will go in here, and if I will go in here replicas, so I can copy it in here and I can mention 2 or I can mention 4 just in case for illustration. And if I will go in here, I can type terraform apply and then var -file, and then for different environment, for example for my dev I am specifying 4 count, so dev.tfr. Okay, I need to change it to, okay, I need to close this one because it has already taken. So now I will specify here. So now you can see my replicas was changed because now dev.tf vars file was triggered. Now what if you want all these same scenario for the different environment? You are not going to take all these things and create for your own separate dev environment file. So for that you can create workspaces. So if I will, so I will cancel this window. I will clear the terminal. So if I will type Terraform workspace list. Currently, I am in my default workspace. The asterisk says that this is your current workspace. Now, for creating a workspace and switching to it, you have a command called Terraform workspace new, and let's give the environment as dev. So once if I will hit enter, I am in my new workspace called dev, and whatever configuration I will apply, it will not get applied to my dev default environment. This will be completely different. Now once I hit entered, Terraform also create .tfstate.d file, and inside it I have my dev file. The default file is tfstate, in which if I will go in here, so you can see the replicas is 3. But once if I will go to the dev environment, I am in my dev environment. I can check this. So I am in my dev environment. Now what I can do, I can make any changes in the replicas or anything like that. So let me go to the dev.tfvar files and let's me make it to the 5 itself, and let me try to apply it. Okay, and I will type yes. So now you can see my app name, DevOps, enabled, and replicas is 5. If I will go to the dev environment, so now you can see it has created a separate snapshot of my infrastructure. I have created separate infrastructure for my dev environment. So you can see the TF state is different for this one, and for default workspace, it's a different. If I will go to the TF state file, you can see that my replicas is 5 in my this workspace. If I will switch back, Terraform workspace select default, I have mistakenly typed. So I am now switched to the default workspace. I am no longer able to access this state file. I will be access to this state file. Now if I will try to make the changes again, like Terraform apply var file before deploying our infrastructure. So once if I will try, so it will tell you that, hey, you are going to deploy your infrastructure and change your replica from 3 to 5, right? But we already did this because earlier we were in the different workspace. Okay, so that's how you can use workspace to isolate your environment and to create different replica in your different environment. So it will be very useful in your cloud infrastructure. For now, I can cancel this and I will clear the terminal and I will move ahead. Now you have seen how you can use Terraform workspaces and the Terraform workspaces command. Now let's move ahead and let's see how you can use iteration in your Terraform HCL files. For using iteration, I will navigate to my main.tfr file, and then in here I will create another block resource, and let's take it as random string itself, and the name I will take it as list because I want to iterate it using list, and after this I will iterate it using maps. How you can iterate the element in the maps, but first let's see how you can iterate in list, and I will give the needed parameter as 6, right? And I will save it. Now, if I want to iterate through the list in here, so I will give one more special field called count, and I will give the count as 2. I will save it. Now, what I can do, I can either take the output and print it, of course, but I don't want that. I can just type Terraform apply. So if I will go in here, you can see that it is going to create two list of string. The first one will be your random string list 0. You can see it's list 0, and the second one will be list 1. You can also embed your count to access your whatever region or replica count you have. For example, if you will take var.replicas in here, so you can use also that. For example, in here you can type var.replicas. So it will also replace this 3 value in the here itself. Okay, so it will create the list of 3 strings. So using count, that's how you can iterate through it. So that's how you can iterate through it, and now you can access the list of string using your indexes. Now, in case of map, so let's see the existing map here itself. So if I will go to my variables.string and let's take any of the type as map. So let's take this one. Variable equal to region replicas, type equal to map string. and my terraform.tfr file has this. So if I will go to my main.tfr, so I can use the same stuff in here, another block, and I can type or change it the map so that I can identify it. And in here, instead of count for my list, unlike list, I will type for underscore each. And then in here, I need to specify the string. So the string here is dot where dot my region replicas, because that is the name of my map region replicas, and then I need to specify underscore. Okay, so that's it. So if I will try to cancel it, and if I will try to apply it again, so now if I will go in here, so you can see that it is storing my string of map, means I am iterating through the elements of my map using my list. Okay, so you can see using my for each loop, I am first entering my east US as an index of this iteration, and then I'm going through the west US. Right? So I'm hoping we are clear how you can iterate using count, and so I have cancelled it. So I'm hoping you are clear how you can iterate using count or for each. Okay, let me know if you have any doubt. For now, let's move ahead and let's check how you can use conditions or boolean in your configurations file. For that, I will again move to my Ubuntu VM, and I will go to my variables, and I might already have a variable of enable type as bool, so I am good with it. So let's see how you can validate it. For using it, I will go to my main.tfr file, and I will use a resource block here again. The resource block would be random string, and the name will be, let's give the name as if. I will give the mandatory parameter, and let's give anything like that, like 6. Now in here, I will give the count as. Now how I will take count? So I will take the count as where dot enabled. Okay, and then after it I will take it as question mark, and then you might have already aware of it. It's a ternary operator in which you will first specify the definition here, so it will check for it whether it is a true or false. If it is a true, then it is going to pass the very first value. In my case it's 1. If it's a false, if this one will be returning false, then it is going to pass the second value, which is 0. Okay, so I will save it. As in my case this enabled is false, so I think it's going to pass 0 to this random string. Now let's see how you can use modules in your Terraform. Now, this will play a very important role whenever you are trying to use your own modules, or even the modules that is created by another developer. So we will try to use modules that was placed by another developer in our code, and after this we will also try to create our modules, and then we will try to use it locally. So let's see it. I will remove this bunch of code that I don't need. We will talk about modules. Modules are like predefined structure of your configuration file that you can use. Either it belongs to another developer, or you can also create your modules and provide it to other developer so that they can use the pre-built main.tf file, variables.tf files, and output.tf files. First, let's try to use any random module from Terraform registry itself, because all the providers or modules stored by another developer are being stored at Terraform registry only. For navigating through Terraform modules and for accessing a random module by HashiCorp itself, I will navigate to the link, and I will navigate to this link, registry.terraform.io modules HashiCorp module random latest. And once if I will go in there, so this is the module of my random provider that I've been using so far. To provision this, to use this bunch of module, I need to paste this one in my main.tf file. After this, I need to initialize it. Before initializing it, I won't be able to use this module.
Here are the input output details here. If you want to see what are the things inside this module, you can always navigate to the source code. Most probably they will be on the GitHub, and it's not limited to the random module. You can navigate to the another module in Terraform registry. So if I will navigate to registry.terraform.io, and if I will go to browse modules, so you will see the very most popular modules here. If I will see the Azure one, which we will cover and which we will use it whenever we will deploying our Azure resources for sure. And if I will go to the VNet, so you can see that this module VNet, I can use it in here. Now, what this module contains, again, for this one, you can navigate to their source code page that is stored on GitHub. And here are the main source code. If you want to see the main.tf file, you can definitely see that. And you can see that it's trying to deploy your virtual network and it's called VNet. And here are the mandatory field that requires. Okay, so that's how you can use modules. So let's try to use our random modules. So whenever I visited the source code of this random module, so I came here. Now you can see it has main.tf file, output.tf file. In the main.tf file, it has again random string and it is keeping its UID. The output is set up to show that application config output and it will tell you the random string, its ID, result. And we have also variables.tf. Now in this case, for this module, they have main.tf, outputs.tf, and variables.tf. But it does not need that you need all the configuration file for using that module. If it will only have main.tf, then it will also be called as a module and you would be able to use them. Alright, so let's go ahead and let's try to use this module in our configuration file. So I will copy this code and I will go to my VS Code and in my main.tf file, I will paste it. Now in here, we are using a module block because we are going to module of course, and then the module name. Now in the module name, I'm not going to use module. I'm going to give it as custom underscore module. Okay, and I will save it. Once I have mentioned module custom module and once if I have used it, I need to type Terraform in it at the first time. You don't need to run it again and again. So whenever if I will type Terraform in it, so what it will do, it will try to create the modules and it will try to create the module with the same name as this folder, but the contents of the files of this folder will be the same like that is stored on the GitHub. So we didn't use git clone or git pull. We just used Terraform init. So in my case, I already use it, but in your case, you are using it for the first time. So your output may differ whenever you were using Terraform init. So all the contents for main.tf, output.tf and variables.tf should be similar that is defined in the GitHub page. Okay. And now we are ready to use these modules in our page. So I will go ahead and close all this and I will go to outputs.tf and I will use it. So I will use output and then I will use a random module value and then I will specify value and value would be, so now how you will reference your value, how you will call the value. So this value is stored and I want to use it from my module, right? So you will access using module dot. So module dot, then your module name, which is custom module, and then what is the resource types? In my case, I have defined random string. So once if I will save it, and once if I will go ahead and type Terraform apply, so now you can see the random module value will be added. And if I will type yes, so you can see the random module value is giving like this one. So now you might be recalling that this output was coming from the outputs.pf from our custom module, right? Application config output. So yeah, that's how you can use module that is provided by any developer or even your cloud technologies like Azure, AWS, and you can use it in your configuration file, right? Now let's move ahead and let's see
how you can use your own custom module, how you can create your own custom module and you can use it or you can share it with your other colleagues. For creating a module, you can create a very simple folder structure in here, and the folder structure would be not in here. It should be outside, means at this structure, not inside the Terraform, and you will call it as the modules itself. Okay. Now inside this module, you will give the module name. So I will give the module name as custom2. Now inside this custom module, I will create a new file and let's give the file name as main.pf. Now, whether you are going to create your own module or whether if you are going to clone any module from Terraform registry, the main.tf file is necessary. Whether you do not provide variables.tf, vars.tf or outputs.tf, but main.tf is necessary. Okay. Now in here, I'm not going to do or write some bunch of code because we are going to cover in the Azure. We are going to cover in the next chapter whenever we are going to deploy resources on Azure using Terraform. So for now, I am going to use these things and let's go ahead and let's just copy these resources in here, and that's it. And let's give the random string name as custom. Let's give the name as also custom2. Okay, and I will save it. Now I am done. My local module is ready. We will see how you can push your custom module on the Terraform registry if possible in the next lecture. For now, let's see how we can use this output. Now for using our Terraform module, I will go ahead and I will type output and let's give the name as random custom. So now before using our output, we are directly trying to access it, but it will not work. First, you need to provide the reference of your modules in your main.tf file. So let's go ahead and let's type. So I will type module and I will give the module name. The module name would be, let's call as custom, custom2. Okay. And then I will provide here the source. The source will be dot, then whenever I have typed dot, so it's giving the options like first go to module and then the custom2. The Terraform extension is smart enough to giving me suggestion that hey, you should use this module. So I will select that one. Now for versioning, you don't need to mention because this is a local module. Now I will save it. So do you think anything will change if you will try to run Terraform init again? So if you will go here, it just initialized our custom module custom2. Okay, so yes, it needed. Whenever you will use your local modules also, you need to type Terraform in it for the first time. And now we are ready to use it. So I will go into output.tf and now in here I can use it. So I can type module and then you can see I have the custom2 as an option. Now, once if I will type Terraform apply and once if I will hit enter, so you can see that this will also give our random custom value to the empty string because we haven't specified any. Okay, so that's how you can use your custom modules, your own custom module in your code, and even you can share it with your colleague. Before sharing it, just tell your colleague to run Terraform in it, right? So yeah, that's it for the very core and important concept about Terraform. So these concepts will be needed whether you are using cloud technologies like Azure or AWS for deploying your infrastructure. Now let's meet in the next chapter and let's start deploying our infrastructure on Azure using Terraform and using these core concept and these important concept that we just learned. Okay, so till then, take care everyone.
Hey guys, and welcome back. In previous chapter, we learned about some Terraform basics and core concept that is needed for sure whenever if you want to learn Terraform for AWS, Terraform for Azure, or Terraform for Google. Okay, so you need those basic concepts to be clear before moving with Terraform integration with any other cloud technologies. So now let's move ahead with this chapter with Terraform for Azure, which is our main topic of discussion on this course. Now, in this section, we will set up our Azure provider. And before setting up Azure provider, we will give a quick overview of Azure
how you can set up your account and Azure resources. As this is not a Azure course, so I will be providing some most famous resources that you can create in Azure, and I will give the explanation of them so that you would be able to identify which type of object you should create whenever you are playing with Terraform. Now, to make sure that you practice on your Terraform environment, you should have an Azure subscription in place. If you don't have an Azure subscription, means you need to first set up your account. Now there is two way in which you can set up your account. First one is if you want to use a free credit from Azure itself. So Azure provide $200 of free credit so that you can use your resources. But you have very limited access to create the resources. But in case of pay as you go subscription, so that subscription is like whenever whatever resources you will be using, you will be get billed. So that is the pay as you go. For navigating to the portal, I already have the bookmark, but I will go with the link. And the link for Azure is portal.azure.com. Also, if you haven't set up any account, please go ahead and set up any account. If you want to learn about Azure free account or pay as you go, you can always navigate to Azure free account, search for it and go for it. Now in here, you can go ahead and click on try Azure for free or pay as you go. Now this option will give you $200 credit, which will provide you the limiting resources here. So you can see in the free product, of 200 credit, you will be able to use these services that they have mentioned here. Alright, they are limited and you can use only some sizes available in between. While the pay as you go, you can use any services you want. It will just bill you for whatever you will use. So I will recommend you, if you are not going to deploy your free account and if you are a student, then please go ahead and feel free to create an Azure free account. For creating an account, you would be needing your email ID, your password, so that you can authenticate via your Azure, and also you would be needing one debit or credit card. Similarly, for pay as you go, you would need a debit or credit card for creating or registering for Azure storage account. For now, I already have done this. It's very simple. So I will cancel it and I will go to my courses. Now, the very top level of your Azure is tenant. Now, that tenant is representing your whole company. In my case, I have only one directory, so it will be like only one tenant. Now, within those tenant, I will have management group. Now, these management group are differing like your environment. You are isolating your main environments in your company like your financial, your development, your technical, your IT. You are isolating each environment. So that is called management. Now, within those management, you will have subscription. So if I will go and search for management group, so I will have only one management group. That is my default. So in my case, as I don't have any management group, so my subscription resides in tenant root group itself. Now within this root tenant group, you have a subscription. Now this subscription is used to get you bill for whatever resources you will use. So you can see current bill for my subscription is 37 rupees and 78 cents. We can also download the invoice and I can also pay my bill. If you will come to the left, there are various options, but the main thing here I would like you to tell you that this one. So this subscription ID will be used to authenticate from a third party tool like Terraform to your Azure. So this needs to be mentioned. Here is the subscription name. So in my case, it's pay as you go. But while creating your subscription, you can definitely change it. Now there are hundred and thousand of options, but you do not need to worry about that. Then in here you have something called resource group. Now after a subscription group, you have something called a resource group. The resource group is like a logical grouping of your resources within a bundle. Also, if you want to see the resources not inside the resource group, means definitely the resources will be reside in the resource group itself. But if you want to see what all the subscription direct are in your resource group, you can directly create resources. You can click on resources and you can see all the resources created like virtual machine, network interfaces, storage account, your whatever resource you will create, you will be able to see all of them here. But whenever you will click on resource group, so it will give you a resource group, and whenever you will click on that resource group, your logical grouping, so you will be able to see that those resources that you were seeing here, they are logicked into resource group. You can create hundred and millions of resource group. There are no limits, but yeah, there are some higher amount restrictions. Now there is one more thing that I would like to talk about, which is uses plus quotas. In here you will be able to see what are the uses and quota that is being used for your pay as you go subscription, and what is the default region that you being provided. Now here is the total limit. Suppose if you have used your virtual machine and you are getting error like uses or quotas fail, that means your quota is almost full. So for that you can go ahead and click on pencil button to edit this. For my case it's not editable, so I need to create a support request and they will available for me from the backend. But for illustration purpose, these 25,000 SQ sets is enough for me. So this is the resource group. Now let's talk about some more resources that we will discuss. If you are an engineer or cloud enthusiast, you are definitely aware of virtual machines. Virtual machines are like your machine, your similar like your OS, but they are running differently on cloud. They provide different version of OS like Linux, Fedora, Windows Server, or more like this, with different type of sizes of OS disk and different size of configurations. You can also have GPU based sizes for your virtual machine. Virtual machine scale sets are like a grouping of virtual machine. Either they can range from one to many. Now you can define your virtual machine scale set based on the configuration or auto scaling. Then another type of important resource that I want to talk about is storage account. Now the storage account is like a logical grouping of storage related services in Azure. There are four types of storage that Azure provide. First one is blob, that is very important, and you will use your unstructured data of type files, music, videos to store in a blob. Then you have another type called file, in which you will use it for file shares related stuff. Third one is table, and the fourth one is queue. Queue is like your messaging services. If you want to use as messaging services for your application backend, that you can use it, and table is for your structured data that on which you can run your query. In our case, we will be using blob for most. So I'm hoping I was able to make you understand about Azure in brief. As this is a Terraform course and we are going to deploy infrastructure on Azure, so I thought to give you an overview of Azure resources quickly. But let me know if you want a course on Azure Fundamentals or Azure Administrator. I would be happy to assist you and I would be happy to create a very practical course for you. As I am Azure Fundamental Certified and Azure Administrator Certified, I would be able to create course for you. So now let's move ahead and let's start setting up our Azure provider. For setting up our Azure provider, I am not going to play all the things in my basics folder structure. I will create another folder and I will call it as Azure 1. I will move into it. I will right click on it and I will click on open in terminal and I will call it code dot so that it will open VS Code in this path. I can close my terminal because I already have inbuilt terminal in my VS Code. Now in here I can go to my terminal and I can open my new terminal from here itself. Now for creating your Azure resources from Terraform, you need to authenticate to Azure first. There are various ways to authenticate to Azure from your main PC or your from main laptop or server. First one is Azure CLI itself. In our case, we have already installed it. I can check it via Azure hyphen version. So if I will go in the top, so I have the version of Azure CLI of 2.75.0. So I'm good with it. And now in here, I can type Azure login, AZ login. It will open a browser in here and it already opened. I can click on my account and it will authenticate in the background. So now I have logged in the background as I already have one subscription that is called pay as you go. But if you have multiple subscription, you can select the subscription here so that it will select the default subscription for deploying your resources. In my case, I already have one, so I will type one and I will hit enter. The second type of authentication, so in here to verify the resources or to verify whether I have authenticated or not, I can type AZ account so it will show the details of my account if you have successfully logged in. If you are not logged in, it will tell you failed and go ahead and authenticate again. Now, there are also another way. The another way is called service principal. Service principal is like it will create a service principal and it will try to gather the data of your tenant ID, subscription ID, and secret ID from your tenant and it will try to store it on your VM itself. The third type of authentication is to store your some stuff and some properties in your credential file. That credential file will be stored at your home directory. If I will go to home and if I will go to .azure and if I will go to the credential folder, so this folder, if I will go in here, so it will have my these kind of data. In my case, this is not correct because these things I used earlier. So you can also type these data in here. After creating service principal, it will give you these things. So you can paste these things here and it will automatically authenticate your Azure account in the background. For now, I will go with the Azure login method because it is very easier and you can see I am already authenticated. Now I can clear my terminal by typing Ctrl plus L and I will minimize it for a while. Now in here I will create some basics file. So let's go ahead and create it. So the very first one that is main.t which is main.tf. The second one is versions.tf. So earlier it had the name of providers.tf in which you can provide the different type of provider that you can use in your Terraform. The third type is outputs.tf. The fourth type is variables.tf. For using your Azure resources, for using your Azure provider, you need to mention Azure provider in your versions file. Again, if you are using earlier version of Terraform, you need to mention version.tf as providers.tf. So if I want to use my Azure provider, what I can do, I can go to Chrome and in here I can just type registry.terraform.io. I can navigate to it. I can click on browse providers and the most popular it will be showing as cloud technologies itself. So I can go to the Azure. I am on my Azure. To use this provider, I can click on use provider and I can use it these things. To be very specific, this block of code is good. I am good with it. But if I will go inside here, I need to provide something called a features block here. So after this, in the configuration option, we need to provide various option and the mandatory field is feature option. So for that, basically it depends on how you have authenticated to Azure. So I will go to the documentation page and in the documentation, you can search for any Azure resources in here and you can use them. Now in here, as I have authenticated using Azure CLI, so I will click on this field. Whenever I have clicked on this field, there are also how you can authenticate using different various stuff that we have seen. So if I will go in the bottom, so we have done all these things. We have also verified it using AZ account show or AZ account list. And we have also have a subscription ID in our hand. Also, our Azure account was set for a subscription ID, right? We have typed one. Now we need to set up our Azure CLI authentication in Azure. For that, we need to copy this piece of code and then we need to paste it in the versions.tf file. Now, if you will see in here, we have 4.1.0, but that's okay. We will try to update it and we will see how you can update it because in the demo it's telling 4.1.0, but if you will go on the very top, it's saying 4.5.4.0. So we'll also see if there are some upgradation of your provider itself. then how you can upgrade it. Now, once you're done, so looks like we have done it. There is also, we need to mention subscription ID for our tenant. So let's go ahead and let's copy it and mention it in the provided Azure RM block because nowadays it's a mandatory field. Earlier it was not. Now, how you will get the subscription ID field? We have already seen it, right? You can go to your subscription. If it is not visible here, you can definitely go in here and search for subscription. So it will land to your page where all the subscription resides about the various details. I can click on this subscription page and here is my subscription ID which I can copy. I can go to my VS Code and I will paste it. And that's it. I can save it. Now keep in mind if you will go to the very on the home page of the Terraform Azure provider, so you will be able to see this option. But in here, features not mentioned, but you need to mention feature of course because this is a blank, but it's a mandatory one. If you will not mention it, it will throw you an error. For now, I can save it. Now, for using our provider, what we need to do, you are already aware of it. The first command we need to run is Terraform init. So once I will hit enter, it will gather the details of finding hashing of Azure RM version matching 4.1.0 and the block of this code was initialized and it has found one provider here which is officially signed by HashiCorp. So it successfully deployed and initialized our modules and plugins for Azure RM. Now I am good to use my Azure RM. Now in here, to avoid confusion in your code, you can also remove the subscription from here and you can set it as environment variable. How you can do that? I can close it, I can save it, and for setting up environment variable in Ubuntu or Linux like or macOS, you can type always export, then your environment variable name. The environment variable name is ARM underscore subscription underscore ID equal to, and then I will paste the code and I will paste the ID that I have copied earlier. So that thing will also work the same way that we have pasted our subscription ID in here. Now suppose after some time you are still using these things, but the Azure has updated its version. So how you will upgrade it? If I will go in here, you can see the latest version is 4.54.0. In here itself also it's telling 4.54.0. Let's go and change it 4.54.0. Now what do you think? Now what should be our next command so that it will fetch and pull all the modules and new plugins that was introduced in this version? So for that, you need to type Terraform init and hyphen hyphen upgrade option. So now this time it will fetch the details from my HashiCorp and it will upgrade the existing modules and plugins from 4.11 to 4.54. If you will just type Terraform init again, it will throw you an error because there is already one version present with the same name. But if you will use option hyphen hyphen upgrade, it will upgrade your existing provider. All right. So hooray, you have made it. You have successfully set up your Azure RM provider for deploying your Azure resources. Now, after setting up Azure provider for Terraform, let's go ahead and let's create our very first resource on Azure using Terraform that is called Azure Resource Group. As I said earlier, what is Azure Resource Group? Azure Resource Group is a logical grouping of your resources in your Azure cloud. So let's go ahead and create it. For creating your resource group, I can go to my main.tf file and I can write some block of code. Now suppose if you are missing any parameter that is needed parameter and if you are missing that which option you are forgetting, so you can always navigate to the documentation page. I am on my documentation for Azure RM. You can search for resource group and you can click on Azure RM resource group and it will give you all the needed field for this resource type. Now here you can see here is the example uses of it. If you will go in here, you can see that there are two mandatory fields that is needed for sure. The first one is the name of the resource group, and the second one is the location where you want to deploy the resource group. Now, creating of resource group and the mandatory field is completely dependent on the cloud on which you are trying to deploy. For suppose for your AWS, there might be some another thing that is needed, some other field. For all of them, you can always navigate to the Terraform documentation. For now, I can just copy this code. I can go to my VS Code and I can paste it. Now, the first one is the block type, means what is the block type that you are going to deploy. So I'm going to deploy resource, of course. Then what is the type? So always the type will start with the provider and then its relevant resource. In my case, I am going to use my Azure RM provider and then the what is the type of resource I'm going to use a resource group. Now, what is the name of resource group that you are going to give? Don't get confused between this or this name. This name will be the name that will be deployed on your cloud, on your Azure. Now, and this one will be the name that will be the unique identification within your Terraform. So don't get confused between this and this name, but you can always keep them similar to avoid confusion. In my case, I can go ahead and I can use it RG, right, for short name, and I can also give the name as RG DevOps. And let's give the same name of my in my Terraform it says RG DevOps. I can save it. Now for location, as I am in India, so I will be using Central India. Okay, and I will save it. Once it's done, I don't need to run Terraform init again and again. If I will try Terraform apply, so if there are any error, so it will also give you that hey, there are some error here, but if there are not, so it will fetch the details of what it is going to deploy in the background. So Terraform apply will take some time and it will give you the details about it. Now after doing this thing, I don't need to run Terraform plan or Terraform init again and again because I already have done this. So first of all, I will like to run Terraform plan so that it will give me the plan of execution, what it's going to create. So let's go ahead and let's see. So the plan is to 1 to add, 0 to change and 0 to destroy. And what is it going to create? It is going to create the ID which is known after apply of course, and the location will be the central India and the name will be RG DevOps. So I will go ahead and I will try to apply it again. So Terraform and then apply and I will hit enter. Now as it's totally going on the cloud to connect. So earlier you were doing all these things locally, so Terraform apply was very fast. In this case, as we are going to deploy on cloud, so it might take some time. I will type yes for confirmation and it will deploy our infrastructure. So I will wait for it and I will come back. Now you can see that it is giving Azure RM resource group dot RG DevOps is being created. It will give you all the elapsed time because it will give you the live data of creating timings if the resource is very big. Suppose if you are creating VM and it has bunch of resources associated with it, so it might take many time for creating the resources and it will give you the details in the logs here itself. Now looks like it was created. I can navigate to my Google Chrome. I can refresh my page, and if I will go to the home page and if I will go to my subscription and resource group, so you will be able to see that I have created my RG DevOps in the Central India field. So if I will go to the RG DevOps, so I don't have anything here itself because we haven't deployed anything. So hooray, you have made it. You have successfully deployed your very first resource on Azure using Terraform. So very good and hats off to you. Now let's modify our resource and let's try to give some naming convention here. Instead of giving the name directly, let's give any naming convention. So for that, I will go to variables.tf file and let's give some block of code here. The first block, so the blocks I want to create in the variables field would be variable of course. The variable name I want to give is app underscore name, and let's type is equal to string. Similarly, I can copy paste it. And the second string that I want to create is your environment name. And the third type of variable that I want to create is primary region. Because I don't want to mention my region again and again in all of my code. So whenever I type Control S, it has automatically corrected my syntax. Now you are already aware what we might be do. We might be setting one default terraform.tfr files and we can assign value to it. So I can go here and I can click on the new file, not in here, on the outer directory, and we can give it a name like terraform.tf file. And in here I can set all these things. For example, the app underscore name would be DevOps. Then the environment name, the default environment name that I want to use is prod. And the primary reason I want to use is Central India. And I can save it. Now to use these things, I can for now close this output.tfr. I can close this welcome and I can go to main.tfr file. I can use the name like rg hyphen dollar and then I can use my string interpolation here and I can use var dot app name and then I can again use an hyphen and then dollar and var dot environment name because my name of the resource group could be specific to my environment and app. All right. Now the location also I don't want to give it like this one. So how I can do it? I can do it and call my var dot primary region and that's it. I can save it. Now let's see the changes. I will clear the terminal and I will type Terraform plan. Just observe the changes here. What it's doing here in case you are going to rename, you are trying to change the name of course, but suppose if you are not going to change the name, you are just going to change its location or anything like that. So even if you are going to change its location, it's not going to resources keep it like that, or it is not going to move it. It will first destroy it. So whenever we type Terraform plan, so it is giving you all the changes that is going to happen. So first, as we discuss is in our Terraform basic concept, it is going to remove that resource group and then it is going to create a new one. So earlier I have the name of, if I will go to pay as you subscription resource group, I have rg.devops. So what it will do, it will delete it first and then it will try to create it with a name like this. So now let's move ahead. Let's run Terraform apply. So first it's going to delete it and then it's going to create it. I will come back once it's done. So now in the logs field or in the CLI itself, you can see that it's giving all the details like it's first destroying, it's still destroying because it's taking time. The default log period is 10 seconds. So it will give you the details of each 10 second within the next line. Now it's deleted after 20 seconds of approx and then now it started creating. So now in the next 10 second you will get the next log that hey it's still creating. You not need to worry about that. Again after 20 seconds still creating and I think after it should create. Yes, and it has successfully created after 26 seconds. Now if I will go on my Google Chrome and if I will refresh this page, so now you can see that was deleted and we have rg-devops-prod as our resource group. So you have successfully made changes using this also. I am hoping you are clear with it. Now let's move ahead. Now we have successfully created our very first resource that is Azure resource group using Terraform. Let me know in the comment section if you found any difficulty while creating or authenticating to Azure. Now let's move ahead and let's create our second resource that is Azure storage account. For creating an Azure storage account, I know that they have some mandatory field like name, location, on which resource group it's going to create, what is the account tier, what is account replication type, and what is the tags that it's going to attach. So I know about those mandatory fields. But suppose if you are forgetting and if you want to learn about them, you can always navigate to the documentation section of Azure RM and you can search for that particular resource. In my case, I can search for Azure Storage account and I can go in here. So if you will go to the land page, so you will see the very basic example of here. In here, you can also see if you want to add more network rules here. So you are seeing more examples here. Now there are some required field that is mentioned here. So account tier is mandatory, account replication type is mandatory. It has LRS means local redundant storage. GRS means geo redundant, then read access geo redundant, then zone redundant, then geo zone redundant, right? And these things are optional. Now let's go ahead and let's try to create our storage account. So for creating our storage account, you can always take example from Terraform documentation. For now, let's go ahead and let's create our storage account resource. So I'll provide the block of code of resource. Then what is the resource name? So as we have already enabled our providers and plugins, so it will give you the details here itself. So I will type Azure RM underscore storage account. So here you can see it. I can click on it here and it will auto complete it for you. Now the name that I want to give it as HTG DevOps. Alright, now I will move to the next field and it will give you this red cross unless and until you provide all the required field. You can see it in here. So let's give all these things one by one. The first one is the name and let's give the name as the same name as the ID in your Terraform itself. So HTG DevOps. The next one is you need to provide location. The location would be where dot primary region because you have already set it. The next mandatory field is resource group name because you need to provide in which resource group you need to provide here. Now here either you can provide your resource group name within the double quotes as an string or else you can provide a reference to your resource group using Azure RM resource group then dot operator, then what is the name of resource group that you have deployed. Now this name, don't get confused. This name would be the this name, means the ID in your Terraform. So I will click on this one. Now these three mandatory fields are done. I can click on next and I can type location. Okay, looks like location is done. Now I can type account tier. The account tier, I want to take it as a standard. Okay, the next mandatory field is account replication type. Here you will provide what is the replication that you want to give. As I am going to deploy it for a basic purpose, so I will type LRS. Okay, now we are done with name, location, resource group, account tier, and account replication type. Now the last thing we are left is with tags. For tags, I need to provide block of code because I may have various tag. I cannot have multiple tag and I need to provide key and value here. The key would be, let's give it as environment and the value of this key would be prod because I am deploying the infrastructure for my prod. I will save it. Now still I am getting some error. Okay, so in here we are still getting the error because we haven't specified account tier. We have given the access tier which is wrong. So we need to provide account tier. So it will not be access tier, it will be account tier. The account tier will be standard and I will save it. Once if I have saved it, so it has corrected my syntax. Now, after saving it, I can again go and I can type Terraform apply. I can type Terraform plan, but I am not going to use Terraform plan. I'm going to use Terraform apply directly. So I can type Terraform apply. Now, as it's a storage account, so it does take some time. The extension of your Azure RM provider and plugin will give you the details about the needed name and syntaxes and the naming convention that is taken from Azure. So it's giving that it cannot consist of this hyphen or any other things. So I need to remove this. So I can type STG DevOps and I can save it. Similarly, I can give the name of my ID itself and I can save it. Now I can again type Terraform apply and I will hit enter. Now, based on the type of resource that you are going to create, it is going to take much time. So I will wait. I will provide the confirmation of yes, and I will come back once it's created. Again, we got an error. So making error does not mean you are not learning something. You always learn from mistakes. Now in here, we are providing the reference of my whole resource group, the ID of my resource group that was created earlier. But it's needed the name of my resource. So for that, I can again provide the reference to it, which is name. Okay. Now I will save it and looks like my location is also done. And now I think I am done. Let's go ahead and try to apply Terraform apply again and let's see whether we got any error or not. I need to provide confirmation for yes and I can hit enter. Once I created it, so this name is like the identity in the storage account itself. So I need to change it here. So for changing the name, I can type 23 so that it will give me the name, the standard name, and it should not throw me an error because it's saying that this name of the account is already taken. Now let me again try to apply Terraform apply and looks like it took around 1 minute 17 seconds and it has created our storage account. For verifying it, I can go to my Azure portal. I can go to my resource group because I have selected this resource group here itself. And here you go. You have your storage account in place. And currently we haven't deployed anything and all the default thing are showing here, but you can always go ahead and mention these in your Terraform HCL file and it will be set it up. Now you can see here are these things, these four type of storage services that you can create inside your storage account, that is blob, file, queue and table. So we will be focusing on blob 1 because we are going to store our state file, which is unstructured data, kind of a unstructured data that we will store here. So now once we have successfully created our Azure storage account, let's move ahead and let's create a blob container in our storage account that we have just created to store our state backend file for storing our state backend file for Azure for Terraform because we definitely need to keep safe the snapshot of our infrastructure somewhere in the cloud so that even if we lost, we would be able to see what were the changes were made in my infrastructure. Let's move ahead and let's create one blob account. In my case, I don't have any blob containers, but let's go ahead and create it inside our storage account. Again, if you want to learn about it, if you want to know how we can create it, you can always navigate to this documentation and you can always search for a storage account and you can always search for a zero storage account container, this one, and you will be able to see the documentation of it. In my case, I already have created my resource group, my storage account, so I just need to mention Azure RM container. In this case, it has only three mandatory field, that is the name of the resource group of course, then the storage account ID because it's going to provision in the storage account ID. Now you don't need to explicitly mention location, resource group or account here because it's going to store in the same location because this particular resource, this container is going to create inside your storage account itself. So let's go ahead and create it. So for creating a resource group of my resource block, so I will move resource, then I will mention Azure RM underscore storage container, and then let's give the container name as state backend, or let's give the name as tf state because it will be like Terraform state file, right? Now let's give the mandatory field the first one with the name of course, and the name also I would like to give it as tf state. The next mandatory field is the storage account name. So let's see whether it has the mandatory field as name or ID. So the storage account name is optional, but the storage account ID. So okay. So we need to specify either one of these, a storage account name or a storage account ID. So let's go ahead and let's use storage account name here itself. So storage account name, and then we can provide azurerm a storage account stg devops dot name. All right. And the next mandatory field that it is mandatory, which is container access type, and in our case it should be private. And I will save it. Now once we have done it, so I can again try to create Terraform apply, and it will ask for the confirmation. So let's wait for it, and let's deploy our blob also. For now, until it's creating, we can see that my blob is empty, means I don't have any blob here. So it's giving a warning like you should not use storage account name, you should use Terraform storage account ID because now it will be deprecated. But our apply was successful and it has created one resource. If I will go in here and if I will refresh my page, so you can see my tf state file is there. If I will go here and if I will see, there are no stuff in here. It's completely empty. Okay. Now don't worry about this authentication method, which is access key. We have successfully authenticated to Azure. So whatever you will write from there, it will be written in this container. Now we have our Terraform state file in here, which is the snapshot of our infrastructure. It is kind of non-structured data, means it's like of your general file. It's not a file share. It's not a table-like data, means structured data. It's not like a queue messaging services. It's just like a unstructured data that you can store in your blob. So how you can do this? So for setting up your Azure backend, you can always navigate to terraform.io, and you can search for Azure RM backend. So if you will go inside here, so you can see backend type of Azure backend RM. Now I will come to this page, and if I will navigate a bit bottom, so I will be able to see EntraID with Azure CLI because we have authenticated using Azure CLI, and we will be able to see this one. Now for creating a state backend, I will use another directory. I will create a new folder here and call it as Azure 2. I will go inside here and I will open terminal in here. Now I have opened my terminal. I can close this window, and once it's created, I can create some basic file like terraform.tf then main.tf, then versions.tf, variables.tf, outputs.tf, right? And I will go to my earlier project in here itself, and I will copy all these things from my versions.tf file. All right. Now, once if I have copied it, what I can do, I can go in here and whatever the code I have copied here, I can copy here. So I can go in here and I can paste it inside my Terraform block. So now once it's done, in here I will type resource group name. Now these things I will take it from my Azure itself. So let's go ahead and let's take all these things. The resource group name is RG DevOps prod. The storage account name is STG DevOps 23. The container name is DevOps TF state itself, so I'm good with it. The key, the key would be, let's also give it as TF state, and I will save it. Now I'm going to open the terminal window in here itself, and I will initialize my directory here. I will save it. I will open my terminal and I will type Terraform init. Now it has successfully initialized my directory. If I will go to my Google Chrome and if I will refresh the page, so I have this directory. I can go inside here. I can go to my storage account. I can go to my blob services, my blob, and I can go to my tf state file. And you can see now I have my tf state of block type. And currently, if I will see the details of it, so if I will go to the edit page, so you can see currently it's empty. Now what I will do, if I will go here and if I will try to deploy one more resource, let's take the resource example from my earlier one. So let's go in here, let's go to main and let's deploy one very basic resource, that is a resource group here itself. And let's take the details as, let's give the name as storage 23 and let's give the location as central India, because in my case in this structure I haven't specified any variables, so I'm taking the defaults. So once if I will save it and once if I will type terraform apply here, so it should restore the current snapshot of my infrastructure on my state backend. So now you can see that it's getting my state log, my state of my infrastructure, and it will store inside my backend. So I will type yes, and looks like it was created. So if I will go in here and if I will refresh my page, there are nothing here because it's obviously didn't create it. But if I will go to the dot Terraform, now the TF state is being stored here. If I will go to my Google Chrome and if I will refresh my page, now you can see it has written all these things that were created inside my terraform.tf state file to my Azure directly. This time I just wrote terraform apply and it write the configuration. So now I'm sure that you now know how you can store your state to the backend in case of Azure, because it's a very important whenever you are going to give an interview about Terraform, they will definitely ask you about how you can store your state backend to any cloud provider like Azure. Okay, so let's move ahead. So we have created our blob container in our Azure storage account, and we have also stored our TF state file in that blob container for our infrastructure snapshot purpose. Now let's move ahead and let's create something called Azure Log Analytics Workspace. If I will give you an overview about it, this is just a workspace that will store metrics and all the logs, all the performance metrics data for your resources in Azure. So you can connect any resource to this log analytics workspace and you can utilize its log collecting information for your purpose. So let's move ahead and let's try to create it. For creating a log analytics workspace, I can always navigate to my documentation section and I can search for Azure Log Analytics Workspace. Now you can see that there are two options in here. First one is resources and another one is data resource. Now which one you should use? So if you are going to create that resource, then you need to select this one. But suppose if you want to use from that resource, as I said, workspace is like a collection of features of collecting logs or seeing the performance metrics. So if you want to use your workspace to gather the details, then you need to check for the data sources so that you can use it. But if you are going to create your log analytics workspace, you can always navigate to this documentation section. So here it is giving the example of it. So I will move ahead and I will try to create it. I will go in here. I already am on my main.tf file. So no need to worry if you want to copy paste the code. That's completely fine because from beginner to experts, they also copy the code. It's not mandatory that you need to remember all these mandatory fields. That's completely okay. So I will go ahead and I will manually type it and illustrate you all the things one by one. So of course I need to provide resource block type, right? And then Azure RM underscore log analytics underscore workspace, right? Then let's give the workspace name here. In my case, let's give it the name as main because I won't be creating another workspace and I am getting a red cross because it's needed some mandatory field. So that's fine. Now let's provide the name. So the name, let's take it as tf hyphen workspace. Then I need to provide a location. Now the location would be Azure So we have already created the resource group, so we can take its location. So I will take the resource and then I can take its location. The next one is resource group name. Now the resource group name I can take by referencing from my other resource, azurerm resource group.rgdevops.name. The next mandatory field that is need is SQ. So the SQ for now, let's see what is the standard output that it has. So it has per GB 2018. So I'm good with it, and I will also copy retention in days. So basically retention will set for what days amount of time you want to keep save of your logs or metrics. For now, I am good with it and this is looking fine to me. So I will save it and I will go ahead and I will clear my terminal here and I will apply Terraform apply. Now it's going to take some time, of course. So I will wait for it. It will try to authenticate in the background. Then it will check the permission and it will create the resources. So I will wait for it. So I need to provide our confirmation. I will type yes and let's move ahead. Now I will come back. I will fast forward this video because creating a workspace almost take almost 2 to 3 minutes. So I will fast forward or come when this is completes. And looks like our resource was created. So how I can verify that? I can go to my Azure portal. I can go to my this one and I can go to the home, then my subscription, of course, or I can directly search for the resource group here. I can search for the resource group and I have deployed in STG23 resource group. So I can go within it and you can see I have my log analytics workspace called TF workspace running. So we are on the home page of our TF workspace. There are various and bunch of options supported for this. If you want to set it up, you can always navigate to this documentation here which will tell you what other option does it have and what are the mandatory field. So you can always navigate here for learning about it more. For now, we have created our workspace. So let's move ahead. Now, after creating a Lognatrix workspace, let's create a local runner. Now, what is a local runner? Till now, you were deploying the infrastructure. Suppose if you are writing for your prod environment, so first you are trying to write all the command and all the configuration in your file, your different configuration file, and then you were trying to copy paste it for the other environment. Then you are going to run Terraform init and then Terraform plan or Terraform apply, right? Now, don't you think there should be a way of running all these things, running all our workflow via our script? So yes, we can write bash script with all these configuration and running sequential steps. And once you are done, if you want to run it for the other environment, just change bunch of lines in your script and you just run those script again. That's it. So let's go ahead and let's try to streamline the automation of resource creation in Terraform using local runner. So I will go ahead and I'll in the VS Code, I will create one file. I will call the file as tfprod.sh. Now I am in the tfprod.sh file. So the first line, so this is a bash script. If you are not aware of the syntaxing or how it should proceed, so you can always navigate to my bash scripting course in which I have talked about bash scripting from beginner to advanced level. I will try to provide the link of my course in this description of this course. So the very first line I would be using is cbang line. So pin and then bash. Now there are sequence of steps that you need to mention as a local runner. First one is you need to set up your subscription ID because as you are using Azure, so that's needed for sure. The second thing that you need to set up is set up the backend because you are going to use backend, right? For storing your TF state actual infrastructure of your actual snapshot of your infrastructure in your storage account. So that's good. Now you also need to set the environment or application name if you want to change it for different environment. Setting up environment or app. Okay. So these are the three sequence steps. And after it, we need to run our Terraform. So Terraform apply. All right. So let's go through these steps one by one and let's try to complete it. So first one is setting up our subscription, and you are already aware of it, how we can set up our subscription. So I can set it up using environment variables. So I will use export, then ARM underscore subscription ID, subscription underscore ID, and then I need to provide the ID here. For getting the subscription ID, I can always navigate to my Azure portal, then my subscription, and then in here itself, I will have my ID. So I can copy it and I can paste it in my VS Code. So now the setting up my subscription is done. Now let's set up our environment or app. So in here, what I will do, as I don't have any variables call here, so let's go ahead and call the variable. For example, I will use variable, let's give it as app underscore name. Okay. And the type I would be referring as string. Similarly, the other thing would be, let's give it as environment underscore name and type would be string. So I'm not going to use it. So I'm not going to use these things here because I haven't mentioned in my main.tf file. You can see as I haven't deployed any application yet. But suppose if you are working on different environment and you want that resource group name for different environment should be different one, so you can use this kind of thing. All right. Now if I will go to the default tf var file, so I can always use app name, and let's give it as devops hyphen prod, and then I can specify env name and I can specify devops hyphen prod. Okay. And in your test environment it should be named as test, right? And for dev environment it should be dev, so that's okay. Now in here, as we do not want our default Terraform var file to keep this value, so how I can do it? I can export this value here as I have mentioned earlier. For exporting our Terraform variable, we have tf underscore var key, and then the case sensitive your variable. So in my case, it's app underscore name. I will give it as whatever I have given in there. So I will copy it from here and I will paste it. Similarly, for my tf underscore var underscore env underscore name, and it would be same. Now let's set up the backend. For now, let's save it. If I will go to the versions and if you will go to the backend, so in here we have set up backend, then resource group name, then our container storage account name, then container name and the key, right? If you will go and so we have just copied it from the documentation, and you can see that it can be also passed via hyphen backend config equal to this, right? In the init command means while initializing our Terraform modules and all these things, we can pass this. So let's go ahead and let's use Terraform init. For providing multi-line commands in the single line, we can use backslash so that it will go to the next line. And in here, I will use backend hyphen config equal to, I will go in here and I will copy these things here. So I will quickly copy these things here, and I will copy backend config 4 times because there are 4 mandatory field, and I will copy these things. For example, I would be needing container name. So I have completed my code. So in here, I am initializing my modules and my plugins using Terraform init command, and then I am setting up backend hyphen config equal to whatever I have provided here. So in my case, it was resource group, storage account name, container name, and key. So let's quickly go ahead and copy these things. So it will be RG DevOps prod. Now the container name and the key name is same because we have given the same name of our blob also, right? And that's it. So we have initialized our Terraform also with using this backend config, which is used to configure the backend. Now we can delete it from our versions file. So instead of deleting, I will comment them. For commenting them, I can use multi-line comment here. All right, and I can save this. So now in our local runner step, we have initialize our this one also. Now the final step is to Terraform apply. So for applying our Terraform, we have command called Terraform apply. But what if you want to pass Terraform plan also? Because it might take some time. So for doing that, how you can configure it? So you can pass your arguments here using scripts. So I will provide dollar and then a star. That means when you will run this script and after this script, whatever keyword you will provide while running the script as argument, it will be passed here. So I will run the script and if I will type apply, so it will be passed here in the Terraform apply command. For now, I am good with it. As a first step for running our bash script, the very first step is to set the permission for executable because if I will long list the files here, so you can see that our script file does not have any executable permission. So let's set the executable permission for it. Chmod plus x equal to tfprod.sh. So now if I will list my things, so now you can see change this color to green and now it's a executable. Although we have provided the executable permission to all the user group and ourselves also, but that's okay. Now I will try to run the script. So I will type tf and I will hit tab. So I will type backslash and then tf and it will detect my script. Now in here you need to type whether you want to type plan or whether you want to type your apply. So for now I will just type plan because I'm not going to deploy it as it has already deployed it. So I'm good with the plan and to see the differences and I will hit enter. Okay, so looks like we have deleted the overall block here. So let's go ahead and let's write this in the new command backend Azure RM and that's it. Okay. Now I will try to run this command and now you can see the Terraform has successfully initialized and now it will try to check all these things in my this script itself and it will give you the error whether if there are any. For now, yes, I haven't used this environment variable or these variables in my value, but you can see that it has successfully run and we have deployed this infrastructure earlier. Means we set up our backend config and we try to store our state file in the storage account. So using that, we have tried to apply the same thing using our local runner script and it has giving no changes because they were same. As it's giving no changes, that means we have successfully deployed or tried to build our local runner. Okay, so that's it for this lecture. Let me know if you are not able to understand any of this stuff here. I will try to help you. For now, let's move ahead. So local runners are very helpful stuff whenever you are trying to deploy multi-stage deployments and also if you don't want to copy and paste all the things here and there. Now let's go ahead and let's try to create a very important resource in Azure that is called Azure Key Vault. Azure Key Vault, as the name suggests, it provides functionality to store key, secrets, and credentials for your safety measures. Now you can use these key vault to authorize or to provide access control to your Azure resources also. So let's go ahead, let's try to create it and let's also try to integrate it with your workspace that we will try to modify it afterwards. So I am in here and I will not try to do all these things in here itself. So what I can do, I can go back from here and I can create a directory called Azure 3. Now I can move to that Azure 3, cd, then Azure 3, and then I can open my VS Code from here itself. So now it will open Azure 3 in here. I will again go ahead and try to create all these basics file in here for me. Main.tf, variables.tf, versions.tf, and let's take outputs.tf, but we don't need it, but that's okay. I will try to open my earlier project in here and I will try to copy paste these things in my new to avoid time wasting. So I will go ahead and I will quickly copy these things here and I will go to my project file, then open recent, then Azure 3. I will go to versions and I will paste these things. So this looks fine to me. I can close this backend and I will use the same backend here. All right. And then the provider is good, feature is good, and subscription I want to use the same one. Okay. Now the key I want to use and I will change it here. Let's try to use this as TF state 3 or let's use a TF state 23 and I will save it. Now let's also copy the variables or let's try to use it. So variable and let's use the variable name as app underscore name and the type would be string. Similarly, I will use another variable that is called env underscore name and that would be also type of string. Alright, I will also create one terraform.tf vars file that is a default value file and I will give the name app name. Let's give app name as DevOps channel 23 and let's give environment name as prod. Now for main.tf file, what I will do, I will take it from our first RG. So let me take that. I will go to our very first project. I will go to main.tf and I will just copy my resource group. Okay. So I will go here and I will click on open recent 3 and I will paste it. All right. Now, okay, so actually we are forgetting primary regions also. So let's go ahead and define it in the variable block, variable and primary underscore region. The type would be string itself. We need to define it in terraform.tf var file. Let's primary region and we will define as central India. So whatever location you are near to, you can define your location of your Azure. So that's okay. So for now, I am just defining or I'm just creating a very basic that is a resource group and the resource group name would be DevOps channel 23-prod. Instead of this long name, let's give only DevOps 23. Okay. And I will save it. Now keep in mind, if you do not use your resources, always try to keep deleting them if you are not going to use them because they will bill you. Okay. So for now, I am good with it. I can open one terminal in my VS Code itself. And then let's try to use Terraform in it. So it will initialize the backend and it will get modules and plugins that is stored for my 4.5.4.0. So that's okay. Let's wait for it to get initialized and looks like it's done. Let's try to use Terraform apply now and I will wait for it to get completed. I will provide confirmation as yes and my resource group was created. So I am good now. Now I can move ahead. I can go to my main.tf file and I can start creating my Azure Key Vault. Again, for creating Key Vault, I can always navigate to my docs and search for Azure Key Vault and you can go to the resources section and you can use these things. All right. For now, I am not going to use all these bunch of stuff here. I will just try to use very basic settings. So let's go ahead and let's try to create it. So the first name would be the block, what you are going to create. Then it would be Azure RM underscore key underscore vault. The name I would like to create would be main. And then let's start giving the needed parameter. So the first one would be the name, of course. And let's give the name. So this name should be the globally unique. So I will give the same name as KV and let's give this same name. If it will have any error in while creating the resources, it will give us. Okay. Now the second thing would be the location and the location I would like to give the same like as Azure RMRG DevOps and then location. The third thing is the resource group name because you will deploy it there. Then dot name. The fourth parameter is tenant ID. So the tenant ID we can we can get the tenant ID by going to this one, and we can use Azure Active Directory or Microsoft Intra ID, and it will give you the tenant ID. Okay. Now once tenant ID is done, you need to provide SKU name. So in my case, I will just go with the standard, and that's it. Okay. So now I am good with it. Before applying this configuration, I would also like to talk about another way of mentioning tenant ID. Suppose tenant ID is of course very confidential. You should not expose this. By the time you will be seeing this lecture, I would have been deleting or recreating my tenant. But suppose if you are using same tenant across your environment, so you should not expose this number to anyone. So for minimizing and for not using this tenant ID, you have some another way, and you use data sources as a context for your current account to get this information. So I will use data as a block, data block. Then the data block I would be give as Azure RM on those underscore client config, and then the name would be current, means my current user. Okay, and that's it. So this block of code will do the work. Whatever context or information that is associated with your account, it will be passed using this. Also make sure you specify these things, these data sources on the top where you want to use it. Now we are good with it. Now I don't need to provide this tenant ID. Okay. So now instead of passing tenant ID, I can use data dot azure client config dot current as it's already suggested. And then I need to use tenant ID. Okay. So it will pass tenant ID in here itself. Now I am good with it. I can, if I will go to my Azure portal and if I will go to Key Vault, so you can see I might not have any other Key Vault here, right? Now let's go ahead and let's try to use Terraform apply. As we already initialize our modules and plugins, so we do not need to run Terraform init again. So let's directly apply Terraform apply and let's deploy our Key Vault. I will come back once it's done. So looks like it's done. I need to provide confirmation and it will deploy my key vault. I will come back once it's completed. Okay, so looks like it took almost 3 minutes and it's giving that it was created. So I will go ahead and I will try to refresh it. And you can see that our key vault is ready with the same name as we have specified in here, our where.application name hyphen our environment name. Again, if you want to use your local runner to create, you can definitely go ahead, use your environment to create key vault according to your environment. Okay, so now we have created our key vault also. Now let's move ahead and let's create Azure role-based access control. Basically, role-based access control is like a feature of Azure that you can use to grant access to a specific user or group of user to a specific service or group of services. You can either provide them access to your resource group or specific resources, or whether even on Azure or even on management group level. So let's go ahead and let's create Azure RBAC. For creating the Azure RBAC, you have three mandatory fields. First, you need to specify principal ID. So it will tell you who has access to what. Then you will need to define role definition, and then you need to define scope on which thing it's going to apply. Okay, so let's go ahead and let's try to create a Azure RM role assignment. So I will try to use resource and then I will use Azure RM underscore role assignment, and then I will give the assignment name as TF user. Okay, now again, if you want to learn about this, if you want to explore various options about it, you can always navigate here and you can search for Azure role assignment, and in the resources you can always go ahead and use this. Okay, now there is again data sources which you can use to take reference from the created RBACs. Okay, so I will go to my VS Code and I will start writing my code. The first thing you need to define is scope. The scope I would like to provide my access resources to. If I will go to my Azure portal and if I will go to my access control means to check what is our back here. And if I will check view access to these resources means my RBAC role. So currently I only have this Sarvottam means my user account as the owner account, but not sure what are these two accounts. I will try to delete them or afterwards. I think it might be from my service principal that I created earlier, so that's okay. So currently I have three roles. Okay. So now let's go ahead and let's use scope. So the scope would be my key vault. So I will provide Azure key vault dot main, then I will take it as ID, its ID. Okay. Now the next thing I need to define is role, then definition name. Okay. Now the role definition name would be I would like to provide key vault administrator. Now keep in mind that this role should exist. If you want to learn more about these roles, so you can always navigate to Azure and search for Azure Key Vault roles. And you can go in here, and in here you can see that these built-in roles for Key Vault. So I want to provide the administrator role for this context of my account. So I might have mistyped it, but to make sure, I will just retype it again. And then the last thing is principal ID. That is mandatory. So the principal ID, you need to again specify what is the context of your account. So I will again provide data.azurerm client config.current. All right. And then dot my object ID. Okay. Now, once it's done, what I will do, I will again go and type Terraform apply and it will take these things. So I will need to provide yes as a confirmation and it will try to create this role assignment in the backend. By the time it's creating this role assignment, you can always navigate and go to this one. As you seen that you need to provide these things here, but suppose if you want to create a RBAC for VM, so how you can do that? So in the scope it would be changed like Azure RM underscore virtual underscore machine. No need to worry about this. We will create resources related to networks and compute means VM in the next chapter. Then you need to specify what Azure RM underscore virtual underscore machine dot what is the ID in Terraform you have provided and then its ID or the name. Then the role definition name. For role definition name, you can always go and search for virtual machine role or on which role you want to give the access. The virtual machine roles in Azure and you can search for all the built-in role here. Okay. So you can go here and you can paste it and the principal ID would be same. So that's how you can create any RBAC in Azure using Terraform. Also looks like it was created. I can go to my Google Chrome and I can go to my this one and I can refresh it. Now once I refresh it, you can see I was assigned. So this is my account. It didn't create this account TF user. It was just the ID or name in my Terraform. But the name or the account information that would be used, it's a current. Okay, means my account on which when I passed easy login. Okay, so my account was also added with Key Vault Administrator. That's not good because I already am assigned with owner, so I should have a Key Vault Administrator, of course, so I can delete it. But just for illustration purpose, I have showed it to you. So that's how you can create Azure RBAC using Terraform. Now let's move ahead and let's create something called Azure Monitor Diagnostic that you can use to bind your Azure resources to enable logs and diagnostics. So this setting you need to done from your Key Vault itself. So let's do it. So if I will go to the monitoring section and if I will go to diagnostic settings, so you can see that here are no any diagnostic settings. Now what are these things? What it does? So if you want to configure the collection of following data like audit logs, your Azure policy evaluation details means which policies is being denied or which policy is being not followed, or even if you want to collect all metrics, so you can use these diagnostic settings. For configuring this diagnostic setting, I can again go to my this spot, my configuration file in main.tf, and I can start writing this code. Now, before doing this, by default, our RBAC or our key vault is taking access policy as a default authentication, which is a legacy. But Azure always, or even other developer always recommends RBAC, rule-based access control, for provisioning or to authenticating to your key vault because it's more secure than the access policy. But the by default authentication method is access policy itself. So even if I haven't specified any authentication method here, it would be authenticating via access policy. So let's go ahead and let's use one line to use RBAC authorization. So if I will use enable RBAC authorization, so I need to provide here true. Alright. So looks like it's telling enable RBAC optional bool. So it's good. It's giving us our recommendation and it's giving the warning. So for now, I'm good with it. That's okay. Now, once if I will try Terraform apply, so let's wait for it. Let's see what it says. So this argument is deprecated, this enable RBAC, because now I think it would be removed in 5.0, but that's okay. I will provide yes so that it will set our authentication methods to RBAC for sure. Now we will wait for it to get deployed and we will come back. So looks like there was only one setting that it's needed to change. So it didn't go and deployed or redeployed this infrastructure. It just tried to modify it. So you can see that in here it's telling modifying. It didn't try to delete it and then try to create it. Okay. So Terraform is also smart enough to see if there is a setting that needs to be enabled here, so it will not waste your time in going to delete or to recreate it. Now we are set it up using RBAC. Let's try to set up our diagnostic setting. If you want to again go for the documentation, you can go ahead and you can search for Azure Monitor Diagnostic Setting. Okay, so now you can see there are data sources also. We would be using this one because we want to create this data resource. Correct. So what I can do, I can copy these things to save some time and I can go ahead and I can paste it in my main.tf. Now, yes, I need to enable metric for all metrics. Then yes, audit event is good. Now let's give the name. The name I would like to give my Terraform diagnostic as tf diag, and the name also let's give it as tf hyphen diag. All right. Now the target resource ID would be your key vault. What is a key vault? So the key vault we have provided as main, I think. So yes, it's main. So let's go ahead and change it to key vault dot main dot id. All right. Now we do not need to provide a storage account ID. Instead, we are going to store it in log analytics workspace. So we are going to attach our this diagnostic data to our log analytics workspace. So let's try to provide these things. If you want to see that information, so I can go ahead and press Control F, and if I will search for log analytics workspace here, so it is giving the option that it's optional, but you can provide the ID of log analytics workspace where the diagnostic data should be sent. Means it will attach our analytics workspace ID to this diagnostic data. So let's go ahead and let's specify log analytics workspace ID, and then I need to provide the context of it. For providing the context of it, I need to provide a data source for my analytics workspace. Whenever I was covering analytics workspace, I told you that there was two types of analytics workspace that was showing in the guide. So Azure log. So if I will go in here, you can see I have the resources section that we already created and we have data sources also. As I said, the data sources is useful whenever you are trying to fetch the details. So you need to use them. So I need to copy this block of code, only this block of code, and I need to paste it in here. Okay. Now we need to provide what is the log analytics workspace and what is the resource group name. So I can go here and I can go here and I can go to this log analytics workspace. The workspace name is TF workspace, TF workspace, and then the resource group name, and the resource group name is I think STG23. All right. Now we are good to provide its reference to our Azure Log Monitor diagnostic setting. So I can provide data.azurerm analytics workspace example dot its ID. So here I need to provide ID. All right. Now we are done. We are finally done with it. Now we can try to use Terraform apply again. And if I will go in here and if I will go to my key vaults, if I will go to diagnostic settings, you can see I don't have anything in here. So whatever diagnostic setting that will be created here, all the data being stored inside it is now connected to our log analytics workspace instead of storage account. If you want to attach it to storage account, that's also easy. You just need to remove it and just type storage account ID and you need to provide the data source here. Okay. So I'm good with it and I will type Terraform apply. Let's see what it says. So you might be wondering why I'm not getting error at the first place. So first I used to run these command or practice these things in my test environment earlier. And then I used to show you for the illustration purpose for my demos. Okay. So looks like it's doing something in the background. I will type yes. So look like it was successfully created. I can go to my Google Chrome and if I will refresh this page, now you can see I have my diagnostic here. Okay, I can always edit its setting and change what I need to collect here. All right. So yes, you have made it. We have tried to create our some basic resources in our Azure itself, and we have started our Azure journey with Terraform. So well done. Now let's move into the next chapter and let's try to create some very exciting resources like network, VNet, your virtual machine, and let's try to deploy it on our Azure itself. Till then, keep practicing and keep enjoying while learning. Take care, everyone.
Hey everyone, and welcome back. In this chapter, we are going to start our very exciting topic for creating resources on Azure that is called Azure Computing, which includes your VM also and then networking using our Terraform configuration file. So let's move ahead and let's create very first our VNet in Azure. VNet stands for Virtual Network that you are going to create in Azure. If you have worked on cloud technologies, so you might have already aware of this term VNet. So let's head over to our VM. For creating VNet, I would be creating another project here again. So I will navigate back and then I will create a directory called Azure 4 and then I will navigate to Azure 4 and then I will open my VS Code in there. Okay, so I have my VS Code. I will create some basic file. So main.tf, then versions.tf, variables.tf, although I don't need it because I won't be using this too much. And then also take terraform.tf vars file, that is our default variable file. Okay, in main.tf and in the versions of tf, I will try to copy and paste these things from my previous lab. So let's do that. So I will go to main.tf and I will only copy my resource group in here inside my main.tf. All right. Now I need to copy my app name, environment name as variable and also primary region, and also I need to paste them in terraform.tf var. So let's quickly go through it. So I will copy variables.tf and I will paste them in here. Then I will again copy tf var file. I will paste them in terraform.tfr and I will save this one. I will save this one. I will save this one and we are forgetting our versions.tf that we need to copy. So let's take versions.tf file
And for now, let's let's copy all these things. All right. So now we have copied our basics thing, and for we don't need backend of Azure right now, so we can close this and I can save it. For main.tf, I think we already are having this resource group, so we need to change it. For app name and environment name, let's give it as we are going to use it for our production for our Azure. So let me give that app name as tf DevOps, and let's keep the environment as prod itself. In main.tf, I will keep the things as it is, and the resource group that it will deploy is called rg-tf DevOps-prod. We can open one terminal. So now we need to run Terraform init so that we would be able to initialize our module and plugin inside our current directory. So now it's done. Now we can run Terraform apply to apply our configuration. Okay, so as expected, it is giving that these things are going to deploy. So we are good with it. I can type yes. As it's deploying our resource group, that's okay, let it get created. For creating a VNet, I can always navigate to my documentation here. I can search for virtual network on the documentation and I will land to this very page in the Azure virtual network inside my resource page. Of course, you would be able to see the same on the data sources, but you don't need data sources for now. Now, if you will go to the bottom, you will be able to see an example here. In the example, it is saying that you can also embed the subnet here. What's the subnet? Subnet is like dividing your group of IPs from that main IP. A subnet or subnetwork is basically a smaller or logical section of your main VNet that you have created. Basically, it helps us to divide a big network into multiple smaller networks that you can use to isolate environment within your infrastructure. If you want to learn more about subnets, so you can navigate to Wikipedia and we can search for classless inter-domain routing. That is a method to allocate IP addresses within your subnets itself. Here it is giving a very good example of it. Suppose if you are defining a network that is called abc.0 and then backslash 22. So now how it will be done? As it's each of them are of 88 bits, so the last octet is completely empty that it can use to create subnet for it. So total possibles are 2 to the power 8. Here also we are taking only 6 bits because we are taking 22 bits for the use. So means first one will be 8 bits, then it will be the 8 bits, and then it will be 6 bits. So total we are taking 22 bits for our use. Now there are 10 bits that are empty, 8 from here and 2 from here. Now we can use that one for our subnet to use. Okay, for example, we can ask to use 24 from this one and it will change and it will get fixed. For example, it will now have A, B, C. Now what it will do, it will occupy all the C space also, and then I will have only 0. The last octet will be empty for my subnets. Okay, so here is also given one example. If I have 10.10.1.32 and if I am using 27 bits, so it will take only 27 bits. After it, 1, 2, 3, 4, 5, total 2 to the power 5 IPs are possible. All right. Suppose if I have a network of 10.0.0.0 and I am defining my VNet as this one. All right. Now, how these bits are storing? So these bits are storing in zeroth and ones place, right? So first one is oneth place, right? Then second one is twoth place, then fourth place, then eighth place, and then 16th place, and so on. So this one is 10th place, but we are telling that hey, this one is fixed till 22 means my bits will be fixed like so how I can achieve 10 from it all will be 0 zeros So I will explain it in the next page. All will be 0, 0, 0, 0, right? Then at 8th place it will be 1, then 0. Then at 2th place it will be 1, then 0. Okay, now it's called 10. Now this place is fixed for me. My IP will not use any of these bits in my octet. Now the next bits are also fixed because I have asked to use only 22. So I will provide 0, 0, 0, 0, then 0, 0, 0, 0. Alright. Now in here I have used 16 bits. Now I need to use only 6 bits. So in here I will also use 0, 0, 0, 0 and then 0, 0. Now here from now on these two bits are empty and now these two bits are also empty. So these 8 bits I will provide hyphen here. Okay. Now these 8 bit and these 2 bits are free for my IP. So this is called a VNet CIDR block that we are going to use. Now suppose if we want to create subnet from it. So how we can do that? What we can do? We can further divide these things into further category. For example, I can tell to divide my subnet in something called 10.0.1.0 and then 24. Now how I am achieving this? In here I have said that use 24 bits, so 8, 12 and 24, but I am fixing this ones place here, means this one. So let me first close this one. Okay, in here what I am doing here, the next subnet I am dividing here and I am telling that hey, go ahead and use this one. So as it's a one place, this one will be there and it's blank, it's empty for my to use. The next subnet that I can divide from here is 10.0.2.0 then slash 24. Now how I will create this? So I will create this from my this block of code. So I will copy the same and I will paste it in here. So now this one will be 1 and this one will be 0. Okay, and this one will be actually not blank, this will be 0. Now I'm asking 24 bits, right? That means from remaining I can use my 8 bits because total for IPv4 you have 32 bits, right? So now these 24 bits is fixed for my use. Now these 8 bits are used to create the IP. Now how many IP total that it can create? So total it can create 2 to the power 8, right? Means 256 IPs. So in each subnet for this example I will get 256 IPs. But as we are creating these things on Azure, so Azure also require its own IP address for their own use like broadcast IP or local routing IP. So they will use approx 5 IP for their own use. And for this case, we will get 251 IP for our use. So we will see that. Okay. So I'm hoping you are clear with the concept of VNet and subnets. I was able to make you understand. All right. Next one would be 10.0.3.0, right? Because I have 2 bits available. Now from 2 bits, what I can create 00, I can create 01, I can create 10, and I can create 11. So I can create 0, 1, 2, 3. So I can use 0, 1, 2, 3. Okay. So I will be using the same example that I have illustrated here. So let's go ahead and I will close this without saving and we are good with the understanding. Now I will not go ahead and I will create the subnet within the same block of code. I always prefer to create standalone resources for better illustration purpose. Okay, so I will go ahead and create my VNet. Again, I will give the block of resource. Then I will give Azure RM underscore virtual underscore network. All right. Now the network that I would like to give is, let's give it as TF as we are using Terraform and then VNet, right? Now the first name of anything, the first parameter of any resource would be the name of course. And for my case, let's give name as vnet, and then I will try to copy paste this same stuff in here. All right. The next thing is would be the resource group, in which resource group you want to deploy. So RG Azure RM RG DevOps and then dot. Now the third thing is the location, and the location I can reference it from my resource group, or I can use where dot primary region. Okay. Now the fourth thing that you need to specify is called address space, in which you will specify your IP address range using CIDR block. Okay, so I will provide it using 10.0.0.0 and I will use 22. Okay, now this IP that you are going to use, it will definitely depend on your use cases. So as I am using it for illustration purpose, I can take this very small. So now we are good with it. I don't need to specify DNS server. And as I said, I will be creating separate resources for my subnet. So that's completely okay. I will save it and I will try to apply Terraform apply here. So let's wait. Let's see whether we got any error or not, or if we are missing any important parameter. Okay, so looks like everything was went fine, and I can type yes to create my network here. I can go here and I can search for VNet say here, and currently I can see there are no virtual network, right? So let's wait for it to get created. The network that it would be creating is called VNet, then my app name hyphen environment name, and the ID that was assigned under my Terraform is called TF-VNet. All right, look like it was created. So I can go ahead and I can refresh it. So you can see I have my this IP in here, and in here, if I will go in there, so now you can see this IP was assigned to me and I have 0 subnets. Okay. So for using this virtual network for your any kind of resources, you would be needing to creating subnets. We have created our VNet. Let's try to create subnet so that we can and isolate our some group of IPs from our main VNet so that we can use it for our own purpose. So let's go ahead and let's create subnet. For creating a subnet, I can use another block here. So I will call resource, then Azure RM underscore subnet. And let's give subnet name as TF subnet. And I will give the name of my subnet as I would be creating two subnets. So let's give the subnet name as TF subnet 1. And I will copy paste the same for my TF subnet 2. Of course, it's need a resource group name. So I will copy these same things in here and then the name. Then it's need a virtual network name because it will go to deploy in the same virtual network name. So I will provide the reference of my this virtual network, right? And then I will provide name. Then it would be need a address prefix. All right. Now in here it was address space and in here it's a address prefix. So keep in mind. So I will give string and you are already aware we have seen the example of it. So it will be 10.0.0.0 and then 24. The next two can could be 10.0.1.0.24. The next could be 10.0.2.0.24. All right. So I copy this. I can copy paste the same and let me give the name here also. Let me change it and I can copy paste the same and I can change the name of it to 2 and this one to be also 2 and this one will be changed to 1. Okay, this looks fine to me and now I can go ahead and I can try to apply it. Still I have only 0 subnet. If I will refresh the page, I can also go to settings and I can go to address spaces or subnets. It will give you the list of subnets. Okay, currently I don't have any subnets. So let's go ahead, let's wait for it and I will provide confirmation as yes. Now it's creating my two subnets. So first it created my subnet 2 and then it created subnet 1. I can navigate to my Google Chrome, and if I will refresh the subnets page in this VNet, so I would be able to see that I have two subnets. And as I said, it has 251 IP address instead of 256. Alright, I can always navigate to these subnets and I can change the settings of it, but for now you don't need to worry about these things. Alright, of course we went with the default setting so that's why these settings are set to default. But we don't need to worry about this. This looks fine to me. Now, there is a very special function that is called CIDR subnet that you can use to pass as a function instead of address prefix. So these functions are very important. Suppose if you want to change a IP or change its bit in your code, and this code contains thousands of lines. So, do you prefer to go to each of these lines and look for IP and then change it manually at everywhere? So that's not preferred way, right? So let's go ahead and let's use CIDR subnet function to pass as a address prefixes instead of these. So for creating it, I will first create a base address inside my variable. So I will use variable and then base underscore address, and then the type would be string itself. I will save it. In terraform.tfvar file, I will call my base address and I will assign it to 10.0.0.0/22. So that means I have defined my base address and now I don't need to mention in my virtual network. Now in here we can specify this and then my var dos base address and I can pass it in here. Now once it's done, instead of passing my address prefix in here, I can first close this and I can obviously pass PIDR subnet as a function. Then I need to provide my functions here. Now this needs, of course, your base address. So I will provide var.base address. Then how many bits you want to use? So I want to use 2 bits in here. And what is the first bit number? So I will be using 0. Similarly, for my this one, I will be using the same case. And instead of passing 0, I will be passing 1. Means take 2 bits from my address space. So in my base address space, it was taking 22 base address. In my subnet one, I was taking 24. So I am telling that, hey, go ahead and use 2 bits in there. And what is the number that you are going to take? So for first subnet, I'm going to take 0 and the another one, I'm going to take 1. So if I will save it, and if I will try to apply Terraform apply, so you would be able to see that there is no change because it was indeed a same version of whatever we have written earlier. Okay, so let's wait for it to get apply, and looks like there was no change and also there was no error. So that means we can use our CIDR subnet also. So these are very handy if you don't want to use or mention IP address again and again in your code. Now what you need to do, you can just go to terraform.tfr file and you just need to change bits here. For example, if you want to limit your IPs in here, so you can mention 1 in here and it will limit it. Okay, so that is the use of CIDR subnets. Again, if you want to check the address prefix of your subnet, so you can always navigate to Terraform console. So Terraform console gives you a way to interact to your variable or values inside one console itself. Okay, so you can see that there is a greater than icon here. That means you are inside the Terraform console. Now, if you want to see the values of it, you can always navigate and let's use Terra Azure RM underscore subnet, right? Then I'll provide TF subnet 1, then dot address underscore prefixes. So you can see that I have 10.0.0.0 24. If you want to see 10, the value of 2, so you can see that value assigned to is 10.0.1.024. So the Terraform console is also a great way if you don't want to deploy your infrastructure and just have a check on quick things. You can always navigate inside the Terraform console. I will press exit for exiting from console and we are on our terminal. Now, what if you try to change these subnets or the values of your subnets? For example, if I will go in here and let's try to change my VNet main to 39. Okay, so as you expect, what it should do? It should first try to delete our infrastructure and it should try to recreate it again, right? So that is our way. So if I will type Terraform apply, so it should give us the plan, means for destroying our resource and then try to apply it again. So now you can see it's saying 3 to change here. All right, and there is no error. It's just giving that it is going to change it to 3. So let me give it and pass it yes. Let's see what it says. Now we got one error. It was telling modifying. It was not going to delete it and recreate it. It tried to modify it. But what happened here? So the virtual network and the subnet, they are implicit and they are interlinked to each other. Basically, the subnet resides inside the VNet, and the subnets are totally dependent on VNet. If we are going to change inside the VNet, and if it's going to take some time, and Terraform does not know that these resources are linked to each other. So, what it's trying to do is trying to modify these things parallelly, and once it reaches to this block, it said that hey, my resource of my VNet is still modifying, but you are again on this subnet block, and it's trying to modify this also. So that's why you should always mention your subnets inside the VNet block so that it will treat it as a one resource. Or what you can do, we can first comment out our these things like this one, right? Our all subnets. Then what I can do, I can try Terraform apply, and I of course I need to change it to 0 again, else I will get the error, right? Now I can type Terraform apply. So what it will do, it will try to delete my subnets, right? Because I have commented it. So it will try to delete the subnet for the same address prefix, right? And I will have only my VNet here. So you can see my subnet will be deleted due to destroy. It's not deleting my VNet. It's only going to destroy my VNets. So I will provide yes, and it will destroy my subnet with this address space. Okay, so let's wait for it to destroy. Now once our subnets are destroyed, I can also validate in here. So what I have only one resource as per Terraform also and as per Azure also with this configuration. So now what I can do, I can definitely change it to 39, right? And at the same time, I can also uncomment this so that what it will do, it will first try to modify this one, and then at the same time, it will try to again use the resources this one. So I will comment this one and I will also remove this one. I will save it and then I will try to apply Terraform apply. So now let's see the plan. So now we can see that it's going to create our VNet. It will try to one to change, means it will change our VNet and then it will try to add two things that is called our subnets. So I'll provide yes as a confirmation and we will wait so that our address space will be changed of my VNet to 10.39.0.0. And what about our subnets? So our subnet will be changed to 10.39.0.024, then 10.39.1.024. All right. So looks like it was done. One our VNet was changed and my two VNets were added. So if I will go in here and if I will go to my subnets, so now you can see, okay, so looks like I need to refresh it. So now you can see I have my address space changed. So this is very important question in your interviews itself. If there are two resources that are linked to each other, you cannot directly modify both of them parallelly because Terraform does not know that these resources are linked to each other. So how you should achieve it? First comment one of the resource, then try to modify the other one and then try to uncomment it with the updated version. Another way is suppose if there is a way to embed your second resource inside the first resource here. So in our case, in our VNet and subnet, yes, we do have a way here, right? For example, we can embed our subnet inside our VNet also. So that you can also see. Okay, but I just go by creating these things by purpose so that I would be able to show you how these things work if the resources are linked to each other. All right, now let's move ahead. And let's create network security group in Azure. Basically, network security group is a way and it's kind of a resource in Azure itself. It will allow you to filter traffic based on the routing method or based on the port or based on the source and destination IP or range. So let's go ahead. Let's try to create network security group because it's also a very needed resource in case if you want to keep your resources very secure. For creating our network security group, we can also navigate to our Google Chrome and you can always use the documentation if you want because I am also going with the default setting. But suppose if your company have bunch of stuff to configure it or other argument to configure it, you can always navigate to documentation section. So I will go in here and I will create a network security group. So as your RM underscore network underscore security group, then I will give the name as tf-nsg, or let's remove hyphen and let's give tf-nsg. The first would be the name. What would be the name that you would like to give? So I will give nsg, then hyphen, and let's give the same name as our naming convention of my app and environment. The next thing you would like to give is location, and the location I would reference it from my variable. The next would be your resource group name, and the resource group would name would be the RG DevOps. Then next come your security rule. So security rule, and I'll have the objects in place because I need various parameter to specify here. So for our case, I would be using our SSH to open to connect to my VM, my Linux VM that I will create in the upcoming lecture. So let's see the demo of it. So let's give the name of that security group. Let's give the name as just SSH. I need to provide priority and the priority for now, let's take it as 100. The priority is just like prioritizing your which rule should be on the top. If you will specify 101 of any rule, so first this one will be calculated with the higher priority. If any security rule have lower priority, so they will be higher. Okay, so lower the number and higher will be the priority. If you will specify the same port and if you will try to disable it, but suppose if its priority is 99, so what it will do, actually the number ranges from 100 to 4096. So of course this is a topmost priority. Okay, so hope you understand the work of priority. Now let's go ahead and let's specify direction. And direction I would want is inbound. Now what is the access protocol? So it would be like TCP. Okay, so let's take source port range. The source port range I would like to give it as any. Similarly for destination port range, and in the destination port range, I would like to give 22 because I want to connect from any of my VM from inside the port to 22 on my VM, that is called SSH port. Now there is two more things that you need to specify, that is called source address prefix, and in here you need to specify your IP from where you want to connect, and the destination address prefix I would like to give it as any. Now what is the source address prefix that you should provide here? So for that you can always navigate here and you can always check for, so what's my IP, and then I can go in here, and what I can do, I can copy this IP to my this block, so that only this IP will be allowed to communicate to any of these address prefix for port 22. Means only my machine or my machines in this network would be able to connect to this machine at port range 22. None of the source would be able to connect other than this. Now what if you reboot your VM, right? I am working on my VM and this IP was assigned to me, this public IP, and please do not try to connect with it. By the time you would be showing this, it might have changed. Okay, so suppose if it's going to change because it's not static, so how you will reference it? So do you want to go and again check on the Google of what is your IP? Definitely no. So for this, what I can do, I can use a data source here. I can use a data block here, and the data block I would like to use is called HTTP. Okay, with from as HashiCorp itself, and let's give the name as IP. Okay, now the URL that I want to connect here, it would be HTTPS, then if if config dot me, and then IP. Okay, now if you want to visit this IP, you can also visit this. The body it will give in your link would be your IP. So I can go in here and I can click in here. So you can see the body has returned the public IP address for my VM, right? So I can go in here and I can save it. Now how I can take the reference from it? So I can take the reference from it in here as, so in here I can use chomp so that it will try to remove any extra spaces. So it will try to filter them out. It will just take the main body of it. And then I will take the data source here called data.http.ip, but it will navigate to the link. I need its body. Now I will save it, and if I will try to apply it, Terraform apply. So currently if I will go in here, and if I will go in here, network security groups. So I don't have any network security group. Let's go ahead and let's try Terraform apply. Let's see if we have any error. Okay, so looks like we got any error. Okay, so looks like we need to provide this provider in our Terraform versions file. So let's go ahead and let's use this. So I can go to my documentation and look for HTTP provider. So let's see that. I can go in here and I can go to providers, search for HTTP, and here is the HashiCorp official HTTP. I have clicked on it. I can go in here and I can click on use provider, and inside my block I can use this one inside my required provider block. So I can go in here and inside here I can provide one more block. Now I need to again run Terraform init because I haven't initialized my HTTP module. So look like it was done. Now let me try to apply Terraform apply. So the first thing that it did, it tried to connect to HTTP and try to fetch the data. So actually it's trying to fetch the data, and we are forgetting one more thing, that is rule access, and it should be one of the allow or deny. And we are also forgetting protocol. Okay, so I think we have mistaken it. We need to take access and protocol. So let's take protocol, and the protocol would be TCP, right? and the access method here it would be allowed, right? Again, if you want to verify these things, we can go here and we can check for network security group, Azure RM network security group in here, and in here all these things are here, access and TCP or all these things. So we are good with it. Now we can go ahead and we can try to apply it again. So by the time it's applying, there is one more thing that I would like to discuss. So how you will apply this network security group? This network security group is applied on two things. So in here I will apply yes for now. So this network security group is applied to two things. First one is network interface card, your virtual network interface card in your cloud. And the second thing is on the subnet, so that whatever resources you will be deploying in the subnet, this NIC will be applied to that subnet. I will also show you on Azure our resource was deployed. So I can go in here and I can refresh the page. I have my network security group in place. If I will go, you can see I have my inbound security rule with 22 on the very top. If I will go to settings and if I will go to the subnets, and so you are able to see there are only two things that you can attach it to. The first one is network interface card that we will create it. So basically all VM will definitely have one network interface card similar like your main laptop or main workstation. So VM also needs network interface card for networking purpose. So we'll try to create it. It will be either associated with the network interface card or either you can apply this network security group to any subnets. I can always click on it and apply it to subnets, but I will do it using Terraform method. Okay, so for now we are good with it. Let's move ahead. After creating network security group, let's go ahead and let's try to create public IP also, because we want to create one VM that should have these things. If it has a private IP, so you should create your environment, means you need to purchase one DNS, then you need to attach to it, and then you should be able to connect to your private IP using inside the created VM. But we don't want that. We will create a public IP, then we will attach to the network interface card of our VM so that we can connect to our created VM from our Ubuntu VM itself. For creating a public IP, I would be creating another folder. So I will go back and then I will create a folder called Azure 5. Then I will navigate to Azure 5. Then I will open my VS Code inside here. I will create the basics file main.tf, versions.tf, and let's also give terraform.tf vars file, and let's give variables.tf. Now let's try to copy these things for my from my earlier chapter. So I will go my main.tf and I will try to copy my resource. Then I can save it. I know I'm getting this error because we haven't defined anything in versions. So let's go and take all these things from variables first, not versions. It will be variables and I don't need base address space here. I am good with app or environment name. Then I can copy paste the same thing from my terraform.tf vars file. And again, I don't need base address. I can copy this and I can paste it in here. I can save it. Then I can go to versions.tf file and I can copy all these things and I can remove my HTTP block. Alright, now done. As it's already have this resource group in place, so I think it might not have tried to create this one because it's already done, right? So let's go ahead and let's try to open terminal here, and let's first initialize our module because this is a different directory, and let's apply terraform apply. Let's cancel this and let's change the name here because we haven't changed the name. So I will go in here and let's save it to dev. I will save it and let's try to use Terraform apply again. I will try yes and it will deploy my resource. By the time it is deploying my resource, I can go ahead and write the code for my public IP address. For deploying the public IP address, I need to specify a resource block and then I can specify azurerm underscore public IP. Then in here, I can specify tf pip that stands for public IP address. I can specify name and I would also give the same name like tf pip. Then I need to provide a resource group name. The resource group name I would be giving rgdevops dot name. Then the another thing is location and I would give a var dot primary region. And the next thing is allocation method. So you need to either give a static or dynamic. The static took more money, so I will go with dynamic method. Okay, and I will save it. Now I will go ahead and I will try to apply it. As public IP is also a individual resource, so if I will go to public IP addresses, so you would be able to see that there is no public IP address. So I will go in here and I will try to apply it again. I need to provide the confirmation here. Okay, so looks like we are getting error and we should specify a static in here. So because the default standard SQ, we are specifying SQ as a standard. So let's go ahead and let's change the SQ as basic. Okay, so now I will check and if I will try to apply it again, I will provide yes as a confirmation and looks like it was done. Our public IP was created. I can refresh my page and still there is no IP and you can see I have my IP in here with the SQS basic. Earlier we didn't type it so it was taking the default SQS standard one. So in my case I can close Azure 4 and you can see my public IP is there and the current IP that was assigned to my public IP is, so if I will refresh the page, so I think it will get assigned in a bit. Okay, so looks like I need to associate it so that we would be able to see its IP. So no need to worry about this, that's fine. But we have created our public IP address using Terraform also. Okay, so now let's move ahead. We are very near to create our VM and associate these resources to our VM. After creating public IP, let's go ahead and let's create network interface card for our upcoming creating VM. Okay, so in upcoming lecture, we will be creating an Linux VM. Any VM definitely need one network interface card. So let's create network interface card and we will try to attach this same network interface card to our created VM. Again, for taking help for your network interface card, you can go to your Azure and you can go to the documentation. So I will provide a block of resource, then Azure RM underscore network underscore network interface, and the name I would like to give as TFNIC. All right. The name I would like to give it as, let's give it TF, or let's start with NIC-TF. Then the location would be where dot primary region. Then it needs a resource group name and the resource group name would be this one dot name. Then in here, you need to specify one block that is called IP configuration. All right. Now, within this IP configuration, you need to specify on which subnet you want to attach this resource group to, which security group you want it to attach, because this NIC basically will take IP from that subnet IP range. Okay. So first we will need to give the configuration name. So I will give it as pip, that's fine. Then I need to specify the subnet ID. Now, how you will specify the subnet ID? So you can see we haven't created subnet in this one, right? We created subnet in Azure 4 structure. So how you will take? So for that, you can take a data source from here. So if you will go in here and if you will take subnet and if you will go to the data sources, you would be able to see Azure underscore rm underscore subnet, right? So you can take this data source and you can use it to reference. So let's go ahead and take a data source Azure rm underscore subnet. Okay, and let's give the subnet name as tf subnet 1. Then I need to specify Then I need to specify a name of it. So name, let's give it the same name, EF, then subnet 1. Then I need to specify virtual network name. And what was the virtual network name? The virtual network name we would like to give it from here. I will search for virtual network. I can go to this virtual network. I can copy this virtual network and I can paste it in my code. Then I need to use my resource group name. The resource group name I would like to give, in which resource group it resides in, and I provide the reference. Now, how I can use this data source? So I can go in the subnet name and I can use Azure RM. Then I can specify data dot Azure subnet dot tf subnet name, tf subnet 1. Then I need to specify its ID. Alright, so we have referenced our subnet ID, but if you have created subnet in the same main.tf file, so that's okay. You can directly specify and mention using Azure RM underscore subnet underscore Azure RM underscore subnet and then your subnet name dot ID. But in my case, as I haven't specified, so I have taken a data source. Alright, now after creating subnet ID, you need to specify private IP address allocation. And in my case, I want to take it as dynamic. The another mandatory field that you would need to specify is called public IP address ID. Now, the public IP address would be as you have specified the public IP in the same block, so I can take reference from it and then the ID. Okay. Now I have saved it. If I will go here and check for network interfaces, my network interfaces thing. So I have completely blank here, right? So let's go ahead and let's try to apply it again. Terraform apply. And it's giving all these things that we are going to deploy one NIC here and all these things are going to add. I will provide confirmation as yes. So let's wait for it to get created and let's get it created in the background. Alright, so my network interface was created. If I will navigate to my Azure portal and if I will go to network, so now you can see my network interface card is there, right? And it was created. So with it, let's move ahead and let's create a SSH key that will be helpful to connect to my Linux VM from my host. Okay, so let's go ahead and let's try to create it. For creating SSH key, you would need to specify resource and then in here I will need to specify TLS underscore private key and you can see I need to specify TLS provider also so that we will later add soon. In here I would give the name as TF hyphen TLS. Then the algorithm I would like to use is RSA because this is the algorithm that is used to assign private key or public key. And then RSA bits that I want to use is 4096. So that should be fine. Now I need to search for TLS private key provider on the Terraform itself. So I will go here. I can search for this one. So I need to go to this Terraform this one and I need to click on use provider and I need to copy this piece of code. I can go to VS Code and in the versions one I need to add that. I can save it and I need to first try to apply Terraform init. Looks like it was an initialize. Now I can mention Terraform apply. Hope I have saved this. So it's good. I can hit enter now and it should create my private and public key pair inside my Terraform itself so that I can use it later as an SSH key to authenticate to my VMs. Okay, so looks like it was done and public key open SSH. All things will be known after apply and these things are of course sensitive. So it's telling its sensitive value. You cannot see that. I will type yes. I will also show you how you can see these public and private IP using Terraform console. So our SSH keys were created. Now how you can access that? So for that I will navigate to Terraform console so that I can communicate with it. I am inside my Terraform console. Let's try to check these things. So I will use TLS underscore private underscore key. Then I will access this using ef-tls because that's the name. So you would be able to see all these details about it, all the public and private key. If you want to see the private key or public key, you can use dot to access and go inside it, and then you can use public underscore key dot underscore open ssh. So this is my public key pair that will be used to authenticate. Okay, so I will exit it and we have created our NIC, we have created our network security group, we have created our VNet, we have created our subnet, we have created our SSH key pair. Now let's go ahead and let's create our very first virtual machine and we will be creating a Linux virtual machine. Again, if you want to learn about and create virtual machine, you can always navigate to the docs by searching virtual machine and you would be able to see various type of resources if you want to deploy virtual machine. For example, Azure RM Linux virtual machine. And also there is a simple Azure RM virtual machine and there is also Azure RM Windows virtual machine. So my suggestion would be here to not use Azure RM virtual machine because it is going to deprecate soon. So if you want to create a Linux virtual machine, you can click on this one. If you want to create a Windows virtual machine, you can click on this one. In my case, I will be creating a Linux virtual machine. So I can go ahead, I can read these things in here. All right. Now, one thing before deploying our VM, one thing we've missed, and that is to associate our network security group to our subnet. For example, I will be taking subnet and I will be attaching my subnet 1 to my virtual machine. But that subnet will not have any kind of filtering of my SSH port because I need SSH port to be open for my VM so that I can access it from my main Linux VM. But once if I will apply it to my IP from the first subnet itself, so it will not get applied. For applying rules on subnet, I need to associate it with my network security group. For associating your network security group, you need to create a resource from Terraform itself. So I will go to the very same page and I will search for network security group association. All right. So I am on this page. Now here we need a subnet ID and we need a network security group ID. In my case, I already have a data source for my subnet ID. I can show you here. So if I will go in here, so you can see I have a data source of subnet, my subnet 1, and I will deploy the VM in subnet 1 itself. But I don't have a data source for my network security group because it was deployed in Azure 4 Lab, right? So let's go ahead and let's first take the data source of my network security group itself. So if I will go inside in here itself, Azure network security group in the data sources, you would be able to see this one. Okay, so I will copy this. Now I can go in here and I can paste it. Let's give the name as tf-nsg1 and it's a main NSG, so I don't need to specify NSG1. Now, what is the NSG name that I have given? So I can go to my Azure and I have given this name. Now, what is the resource group name? So the resource group name is here is, so if I will type dot, so RG DevOps, then dot name. Okay, I will save it. Now I have a data source for my subnet and network security group. So I am okay with it. And in here you can see I am still getting option to associate it. Now once it's done, I can copy this code. I can go to my group association again, and then again I can copy this code in here. I will go to the very bottom so that all these things will be sequentially. And instead of Azure RM subnet, I will be providing a data source of data source data.azurerm underscore subnet dot tfsubnet dot id. Similarly, for network security group, I would be taking data source. So data Azure RM network security group dot tfnsg, that is my name, and then its ID. All right. So I will save it and let's try to apply it. Terraform apply. So it's getting all these things in the background and looks like it's got some issue. And it's telling that this network security group was not found because I think we have copied a space also. So yes, we have copied a space also and it's a case sensitive. So let's go ahead and let's try to apply it again. And it's again telling that this NSG was not found. So let's see what's the issue now. So, okay, now in here it is in different resource group, but I am specifying wrong resource group. So I need to also replace my resource group in here and currently it's wrong resource group. So I need to close this and I need to take the correct resource group in which my network security group is there. So it's in different one, TF DevOps prod. So let's go ahead and let's try to replace it. I will save it and let's go ahead and let's try to apply Terraform apply again. And looks like this time it was successful and it's telling that we are going to deploy this resource and these things are going to attach to it. I will provide confirmation as yes and it will start triggering the event. So let's wait for it and looks like it was done. Now if I will navigate to my Azure and if I will refresh this page, and if I will go to this network security group subnets, so you can see that my TF subnet one is now associated. So I have created this network security group to allow SSH port. Now I have associated my subnet one to this rule so that I will be creating my VM inside this subnet one and it will automatically allow this rule, this SSH open rule to my VM. Okay, so now finally I am ready for deploying my Linux virtual machine. For creating a Linux virtual machine, I need to copy this block of code and I need to paste it inside my main.tf. I know our main.tf is getting used time by time and we don't need to copy all these things on the top because this is for subnet, network interface, virtual network and resource group name that we already have created. Okay. Now in case of name, virtual machine name inside my Terraform, I will give tfvm1. Then the name of the VM, I will also give it as tfvm1. Now what is the resource group name? So let's give it as dot rgdevops dot name. Now, what's the location? So location I would give at where.primary region. For the size, you should not use F2 because it's not supported. So I will specify standard D2 underscore V2. All right. And I will leave the admin username as default. In case of NIC, I need to attach my VM to the NIC itself. So let's see what is the NIC name here. If and it's telling IDs because you can attach one or more NIC to your VM. Okay, so you can see here is a list of string and you can specify a comma in here. So once if I will give dot, so you can see I have TF NIC and I need to specify its ID. All right. Now here we have admin SSH key and it's taking from a file, a local file, right? From my VM. But in our case, how we have defined it? We have defined in our Terraform itself using our TLS private key, right? We have created using this one. So let's provide the reference in here. for providing a reference, so I will use tls underscore private key dot tf tls, and then I will provide dot, and then I will provide public key open SSH because it's need a public IP in here. For OS disk, caching is good, read write, and for storage account type, I need to use LRS, that's fine. For source image, it's canonical and I need 2204 LTS and the version is latest. Now, these looks fine to me. I can also add comment in here so that I can distinguish my resource. So, code for creating Linux VM, and I can save it. Now I can again go ahead and I can now apply Terraform apply, and it will start creating my VM in the background. And here I need to provide yes, it's giving that these things are going to add. I will provide yes as a confirmation and it will start creating my Linux virtual machine in the background. Let's wait for it to get deployed. Okay, so looks like it took only 50 seconds and our VM was created. For verifying, I will again navigate to my Azure portal. I will refresh the page, and in here I can, as is a virtual machine is an individual resource, so I don't need to go inside my resource group or subscription. I can directly search for virtual machine, and in here you go. So I have tfvm1 as a individual resource, and all these things you can verify that it has a public IP that was associated, then it's in subnet 1 and we have applied our network security group to the subnet 1, and it's with site G2V2, and actually is supported you in your free plan if you have applied for free tier using Azure, and the OS flavor and OS versions are here. All right, so we have configured our VM. Let's move ahead. Now let's connect to our VM. We have deployed our SSH key on our Terraform platform. So if we want to see the public key or private key, we can always navigate inside Terraform console and then we can try to access SSH keys. But how these SSH key will come to my VM, my main VM from where I am operating Terraform, so that I will be able to copy or paste my public or private key here and there, and then I can access my VM. For that, I can create further resources. So here I will give the comment creating local file for manipulating SSH keys. All right. So our idea here, our target is here to take SSH key from my Terraform and to store it on my home. Okay. Or at any directory. So for that, I need to create a resource, and the resource I would like to create is local underscore file. Okay, and I need to insert my local provider inside my this block. So let's go ahead and let's search for local provider here itself. So I will go to Terraform registry, I will go to the home page and I will search for local. So I am in here, I can click on this one, I can click on use provider, I can copy this bunch of code and I can paste it inside my this block. Now before using it, I need to of course use Terraform in it so that it will initialize my this local provider. Okay, so it was done. Now I can go ahead and finally use my local file. So the name of this would be, let's give it as tf, then a hyphen. First I will create for a private and then for a public also. So tf private. Okay, now it needs something. So first it will need content, means from where you are trying to access it. So I will specify tls underscore private key, then dot tftls means my tls, and then first I need to take it private key dot pem, right? Then I need to specify a file name in here, and I will use path expand because I want to expand it to which directory. I want to expand it to my home directory, and what is the absolute path of ssh, so it would be home then dot ssh, and then any folder name or file name that you want to give. So I will give tfvm1. All right, I can save it. And here you need to also specify file permission because it's a private key. And for file permission, I need to give 0600. This should be enough for me. The same code, I will copy it because I need to get the public key also. Only private key alone does not work. And in here with the name, I will give public. Then here instead of private key PIM, it will be public key open SSH, right? And for the naming convention, I will give the name as .pub. Okay. And I don't need to specify file permission. This is a public key, so that's okay. Now we have specified. Now let me go ahead and let's try to apply it. Also, if I will open my terminal in here and if I will go to .ssh folder and if I will list here, so I have bunch of file, right? But I don't have any file with the name of this tfvm1 tfvm1.pub because I'm going to take from my Terraform platform and I'm going to paste it inside my main laptop. If you want, you can always directly try to create SSH key using SSH hyphen keygen. So it will create a key on directly on your main laptop. But as this is a Terraform course, so I went first and created SSH keys on the Terraform itself. So let's go ahead and let's apply Terraform apply. And two things to add here, public and private key. I'll provide yes as a confirmation. And you can see this local file will be creating here. And looks like it was created. And I think it's loading here. And it was created. If I will go to my terminal and if I will list the files again, so I would have tfvm1.pub, my public key and private key on my local workstation. I can create one file called output.tf so that I will be able to export the output of public IP because I don't want to go inside my VM, right? I don't want to go inside here and take the public IP. So instead, we will be using output. So that's what is the output for, right? So let's give output. Then let's give the name as public IP underscore address. And the value I would like to assign it to here is azurerm underscore public IP dot tf dot pip dot IP address. Okay. And I will save it and let's try to apply it again. And all these things were already created. So it's just checking and refreshing the state. You can see it will give us our public IP. Yes, although we had this thing on our Azure, we can take it from Azure, but I wanted to just use public IP address because in some production environment, you will not have access to Azure. Now I have my public IP. Let's go ahead and let's try to create our Linux VM for the first time. For creating, you need to use SSH, then hyphen I. Then what is the password or the public key that you are going to use? So it will be SSH. And then what is the name? So I think it was TFVM1. Now, what is the admin user? So what is the username? So it was admin user. Then at the rate, you need to specify your IP. So it was 98.70.101.76. All right, now I will hit enter. And if it's correct, if it's working, you need to specify yes or no for fingerprint for the first time. Okay, so looks like we got connection to host this. This is port 22 connection timeout. Let's go ahead and let's check what went wrong. So the SSH key is this one, TFVM1, and this looks fine to me. If I will go to Google Chrome and in here I can navigate to my NSG. I can go to this one. So here it's telling the source is this one and the destination is this one. So are we allowed to access from this one? Let's go ahead and let's check what's our IP in here. What's my IP address? So it's 103.50.150 and our source was changed in here, right? So that's why we are not able to access it. So for now, let's go ahead. Let's copy this. Let's click on SSH and let's change our source IP address because this source one was set in Azure 4 Lab. That's why we got this issue. So now we have updated our public IP address according to this one. Now let's go to VS Code and let's try again with this command. And looks like this time it got created and authentication cannot be established. That's okay. The first time we need to specify yes. And it we are inside the VM. You can see now the terminal has changed to admin user at the rate tfvm1. If I will specify who am I, so you can see I am admin user, right? So that's how you can connect to your VM. You can also specify pwd, so you can see that you are inside home admin user. Now I will exit from the VM and I am on my main VM from where I am operating Terraform. So that was the issue that earlier it was not able to make the connection because my main laptop public IP was changed and I need to change this source. All right. Now hope you were also able to connect to your VM for the first time. Let's move ahead. Sometimes organization does not recommend to open public IP or to expose to public world. They prefer a very secure way to connect to your resources. If you are coming on Azure, the most secure way is to create a bastion host for creating to your Azure VM. Using bash session, you don't need to create any network security group, open port for SSH or RDP, and then you need to associate your network security group to either NIC or subnet. The bash session needs its own subnet. Basically, it will require a range of subnet assigned to it for its own purpose, and then you are ready to use it. Now, if I will go to my VM and if I will go to Azure, bash session on Azure. So it's a fully managed platform as a service that you provision to securely connect to virtual machine via its private IP address so that you don't need to allow RDP or SSH into your environment. And how it works under the hood. So the architecture is given here. It uses a TLS port for 443 here. It's also available for our Central India. Now, there is one recommendation from Azure if you want to have scaling in place for Azure Bash Session. In our case, we don't need scaling, but we will go with the Azure recommendation method. There are two requirements for creating a Azure Bash Session. The first one, you need to give the subnet name the same as Azure Bash Session subnet. The second recommendation from Azure is you need to specify the range of IPs within 26 or more CIDR block. All right. So earlier you might have remember I have created two subnet, for example 10.39.0.0 and then 24. Then I had another one 10.39.39.1.0/24. Now the Azure recommends 26 value for the CIDR for Azure Bash Session. Now the next available subnet that I can create is 10.39.2.0, 2.0 or 10.39.3.0/24. So these are available for me. Okay. Now I need to create subnet from this one and I need to specify 26 here. So how I can achieve that? So suppose it's a 10.0.0.0. So in here it's taking 26 address space. So it would be like 10.39 dot I am taking 2 then dot. Then here these two bits will be used for this purpose of dividing these things and then all these bits will be 0000 and then 00, right? So if I am specifying hyphen 26 here, So those two things that will be here, it will be possible way to create subnet from it. For example, in here it could be 00. So our range will start from 10.39.2.0/26, right? Then till what end we can also specify 01, right? So here it will be 00, it could be 01, could be 10, or it could be 11, right? So it will range from 00 to 01, or 01 to 10, 10 to 11. Now what will be the ranges for it? It will be like 0 to, here it's a 1. That means 1, 2 place, 4th, 8th, 16th, 32, 64. So it will be like 63. Then at our next place, it will range from 64 to 128. Then at next, it will be range from 128 to 192 or similar. Then at next, it will range from 192 to 228 or 226, right? Now I will be taking this range for my example. All right. So I will get the IP range. I can create a subnet for my bash session from 10.39.2.0 to 10.39.2.63/26, right? Now, obviously, it will again use 5 IP. The Azure will use 5 IP for their own purpose, so that's okay. So this will be our plan for creating subnets for our bash session. So instead of creating my subnet inside my Azure 4, I will be creating the subnet for here itself. So let's give comment creating subnet for Azure Bastion. All right. Now I will get the resource, and the resource group would be Azure RM underscore subnet. And let's give the name of subnet in Terraform as EF subnet 3, right? Now here I would give the name. As I said, name would be restricted and it will be strictly called as Azure Bastion then subnet. So this name should be strictly this one, as this will not be treated as bash session subnet. If I will go to my Azure, if I will go to home, and if I will go to virtual network, I will have only one virtual network, which is this one. And if I will go to subnets, so I have only two subnet. And if you will go to bash session, I don't have any bash session in here, right? So if you want to create bash session, first you need to specify which VM you want to create, and it will create a bash session from Azure itself. For now, I will create it from my Terraform. So we have a specified name. The next thing you need to specify is resource group name. The resource group name should be the same like in which this virtual machine was provisioned. So it was created in another project. So make sure you don't take this resource group, right? Because it will not be able to find it. Then the next one will be your virtual network name, and you should specify the virtual network name. And in my case, it's this one. And then I need to specify address prefixes. And the address prefix here, I will provide a CIDR subnet function. And here, what you need to use, I need to specify a base address in here. So let's go ahead and let's create a variable of type base underscore address. Then its type would be string itself. Then I will go to terraform.tfr file, and I need to take base underscore address, and I need to specify 10.39.0.0/22, right? Because this is my main network. This is not subnet of like 24, right? Then CIDR subnet, and I will take it as var dot base address. So it will, so what will be passed? So this thing will be passed 10.39.0.0, and then after it we need to specify two things. how many blocks that you are going to take. So after 22, I need to take 26, right? So I will specify 4. And then what is the next net number you want to specify? So I'm going to specify 2 because my subnet was used from 10.39.0.0, 10.39.1.0. So these subnet were used. I had 10.39.2.0 empty and 10.39.3 empty. So I'm taking third subnet and I'm using 4 bits from there. So it would automatically replace this value to 10.39.2.0/26. Alright, so looks like we are good with it. I will save it and let's go ahead and let's try to apply Terraform apply and let's see what happens. And it's telling that we are going to create a Azure Bash Session subnet and all the default thing that we haven't specified here, it will be set to default. So I will provide yes as a confirmation and let's go ahead and let's see is provisioning of bash session. Okay, so looks like we are getting some issue and it's taking the invalid IP range and it's overlaps with an existing subnet in our virtual network. All right, so let's go ahead and let's change it to something else and let's try to give directly as 10.39.2.0 then 26. Okay, I will save it. Now I will go ahead and I will try to apply it. Let's see, this time it should not overlap it. And I will type yes as a confirmation. And this time it was succeeded. Looks like we were giving wrong parameters in our subnets. And it was created and we don't need to specify this. We will close this later. Now, if I will go to my Google Chrome and I can close this window. If I will go in here, I can refresh this page. I am inside my virtual network. If I will go to subnets, so now you can see I have subnet 1, subnet 2, and I have Azure Bash Session subnet. And make sure that you should not give the wrong spelling here because it will not detect as Bash Session subnet. Also, this subnet was associated with my network security group, so you can see here. It was total from 0 to 64, but Azure took 5 of them from my IP address. Now I have only 59 and Azure used 5 of them. Alright, so we have created our bash session, we have configured it for ready to deployment. Now let's go ahead and let's create our bash session host so that we can connect to our VM directly from Bastion. So instead of taking this to here, I will go at the very bottom. I will paste this and now I will write create bash session resource and let's give it the resource name and the resource name would be Azure RM underscore bash session host. Now this bash session host would require a PIP public IP address to be attached to it. So first we need to create one public IP also. So let's create one public IP first. So resource then Azure RM underscore public IP because our previous public IP was attached to that subnet to our network interface card and one IP cannot be attached to another one. And let's give it as PIP bash session. In here I will specify a name and name would be the same like in here. So PIP then bastion. Then I need to specify a location. Location would be where dot primary region. Then I need to specify a resource group name and I will give Azure RM underscore resource group rgdevops dot name. Then I need to use allocation method and I want to use dynamic because static would cost me more and the SQ type that I would like to take as basic. Okay, so I have defined my IP address. Now I can define my bash session host. For defining the name in Terraform, I can take tf bash session and the name also I can give it as tf then bash session because I will only create one bash session. So tf hyphen bash session should be fine. Now I need to take the location and location would be where dot primary region. Then I need to specify a resource group name and the resource group name would be Azure RM underscore resource group name dot rgdevops dot name. Now in here we need to specify IP configuration. Okay. Inside the IP configuration, you need to specify its config. So let's give the name and let's give the name as config. That's fine. Then you need to specify two things, which is subnet ID and the subnet ID I would like to give is Azure RM underscore subnet, then TF subnet 3 because that was used for creating my bash session host and I will give its ID. The next thing you need to specify its public IP address ID. And in my case, it's pip bash session that was just created on the top and then dot ID. All right, I am good with my bash session host. It would be created soon. I can go ahead, I can try Terraform apply in here. If you want to verify and check for bash session, so you can always navigate to bash session. So it will give you the list of all the bash session available in your Azure. I can go ahead and apply Terraform apply. Now creating a bash session will take more time, approx 5 to 10 minutes. So I will come back once it's completed. Okay, so looks like we are using a basic IP address SQ for our public IP. So provision on basic SQ is not possible. So we need to give it as standard and let's also give it as static. Okay, now let's go ahead and let's try to provision it. And as I said, it's going to take approx 5 to 10 minutes. So we will wait for it until the provisioning is succeeded. And looked like it approx took 10 minutes to create my Azure bash session. I can go to my Azure and I can go to this bash session thing and you can see my TF bash session is in place. All right. Now how I can use it, we will see this on our VM. If I will go on our VM and if I will go in here and if I will try to click on connect via bash session, so I will give my bash session and it will use it as a TF bash session. Now how I can authenticate it, I have different method here. So let's move ahead. Also as the bash session is set up, I don't need my association for my network security group, right? And also I don't need to specify data source of network security group. If I want, I can also delete my network security group in place. So I can go in here and I can go to this network security group and I can also first let's apply Terraform apply so that it will delete the association and all the data sources that it took earlier. And then from the previous lab, from where we try to create NIC, we will try to comment that and then we will try to apply it so that it will delete the resources. You can see it will now try to deassociate it. I'll provide yes for confirmation and those things will be destroyed. All right, because we don't need network security group. Now let's move ahead. After creating our bash session host, we are just a few steps left for connecting our VM using bash session. Now we have our SSH key stored on our main or local environment, right, on which our Terraform is running. But you are using a Azure based platform to authenticate to your VM or to connect to your Azure resources. So wouldn't be it be better if you will use Azure Key Vault to store SSH keys, then get those SSH keys directly from Azure Key Vault to authenticate it more secure way instead of getting those SSH key from the local environment. So let's set it up. If I will go to my Azure portal and if I will go to my VM, so if I will click on connect, I have two options, connect or connect via bash session. Connect will give you option for creating using SSH or RDP. As I have created option for bash session host, I have created it. So it will select that. Now in the authentication type, there are various way. So either you should have been created a VM password that you can do it via going to here in the reset password section. So you can go to reset password, just select the password and log in with the reset password or username. The second option is if you have stored the password in your Azure Key Vault. The third option is using SSH private key from local file. I have my private key in my local environment, so I can select that. I can give the username as my admin user, right? And then I can select my environment, and then I can select my folder, but I don't want that. I'm using secure way of connecting to SSH or my VM, then why should I rely on local file? So let's go ahead and let's try to copy my private or public key pair to my Azure Key Vault. And where these will be stored? These will be stored in my Key Vault. I will be using this Key Vault. This will be stored inside this object inside our secrets, right? So let's go ahead and let's try to deploy it. Now you might have remembered that we already have our Key Vault set up in our earlier lab. So first we need to take a data source for it. So let's go ahead and let's take, I will make a comment for it, data source for Key Vault. Then I will take data, then Azure RM underscore data, then Azure RM underscore Key Vault, right? Then I will give the name as ef hyphen kv. Okay, it means Key Vault. Then I need to specify two things. First one would be the name, and the name I would take from here. Now the second thing it would be need its resource group name. In other resource group name, it could be the same name. So I will go to overview page and I will copy this resource group because in my lab, in this lab, it could be different resource group. And now I have done with my data source for my Key Vault. All right. Now let's go ahead and let's add a resource to Key Vault secrets. Okay, so I'll provide a resource name and here I will take Azure RM underscore key underscore vault underscore secret. Okay, now if you want to learn about various parameter supported for it, again you can go to your Azure and here you can search for key vault. So here this one will be using here. Okay, so this thing we will be using. So I need name, then value, and then key vault ID. So let's go ahead and let's try it. So first one would be the name. What should be the name that you want to give it to this secret one? First, let's give the name of it. So I will give tf vm1 hyphen private. Okay, and I will give the same name inside here itself, tf vm1 hyphen private. Now, what would be the value? So the value I would take it from my reference from my TLS private key itself and then dot private key pem file. Okay. Now, what would be the key vault ID? The key vault ID you would take it from data source. So Azure key vault dot tfcav dot id. So we are done with the private. Now we need to add public key also in the Azure Key Vault, else it will not allow to authenticate it because SSH need both private and public key pair. So I will give it as public. If I will go in here and if I will go to my Key Vault and if I will go to secrets, you can see that I don't have any secret set. I will go to public and I will also give it name as public. And instead of this one, I need to specify dot open SSH, public key open SSH, and the key vault ID should be same. Now go ahead and let's try to apply Terraform apply. So what it's doing is taking these private and public key pair, these private and public key pair from Terraform and is trying to upload it to my Azure Key Vault secrets. I can also provide data from my local file. So now you can see there are two things to add. which will be added to my secrets field inside my key vault. I will provide yes as confirmation, and it will take some time to create the resources like secrets in our key vault. Let's wait for it to get created. And looks like it was quick. It just took 5 seconds. I can go to my Google Chrome, and if I will refresh this one, so you can see my private and public key are here. Now we have stored our SSH key in our Azure Key Vault, and also we have set up our bash session host. So let's move ahead. Let's try to create our VM using bash session. I will go to home. I will go to my VM. I will click on this connect and then connect via bash session. In the authentication type, I will click on SSH private key from Azure Key Vault. Then I need to specify a username in here. And what's the username you have specified while creating your VM? It is admin user. Then I need to select the key vault. So this is the key vault that I have only. And let's select the secret. Now what secret you should select? So I need to select TFVM1 private, right? And I need to click on open in new browser tab. That's okay. I can click on connect, and looks like pop-up blocker is disabled. I can click on always allow and I can click on done. I will again click on connect. Now it should create a bash session host. You can see that this pop-up is there and I can click on allow. Now you can see I am inside my VM and these things are running fine, right? So that's how you can connect to your bash session host in here, right? And you can see the terminal is also changed to admin user at the rate tfvm1. For now, I can close this window. So here we were able to connect to our VM using bash session. But here again, we are using an external thing which is called SSH key pair to connect to our VM. Sometimes they are not manageable, sometimes they become tedious to manage and to store here and there because they need a public key or private key pair. So in here, let's understand Microsoft IntraID. We will set up IntraID. We will try to assign one managed identity to our resource in case our VM. Then I will assign a role assignment and then we will provide access to my role assignment to my VM. So first we will try to check this using Azure way, and then after it we will try to do all these things using Terraform way. So I am on my VM for connecting and enabling of authentication using Microsoft Entra ID. So it is new name. Earlier the name was Azure Active Directory. So this is basically identity as a service provided by Azure so that you can manage your identity using Entra ID using Azure. Okay. For using AD based login for your VM, you need to first go to identity in the setting page. You can always search for here in the security. In security, you will find identity. Then you will find two things here. First one is system assigned and second thing is user assigned. User assigned is global unique to your whole subscription. You can use this same assigned identity to all the resources in your subscription. The system assigned is by default assigned identity to your this resource only. Once this resource will be deleted, so this identity will be also deleted. For demo purpose, I am good with it and I can click on yes, go ahead and enable system assigned identity. For now, no need to worry. We will do all these things using Terraform way also. For now, I am just doing using Azure how we can see it. Now we have done this. Now once it's done, I need to go to extension plus application section and I need to attach one extension here. These extensions are not fixed. These extension varies from OS or type of virtual machine you are going to create. In my case, I need Azure AD based SSH login and I am supposing that this name would be also changed in the future. They might change to Entra ID based SSH login. I will click on this one and I will click on next. Before selecting this extension, you need to make sure that your identity, system managed identity or user managed identity is selected. Okay, else it will give you the error while deploying this extension. This extension, VM extension basically are a way to add and customize these things in your resource. I can click on next and let it get. If I will click on view automation template, so these are things in here, and for now I need to copy this properties field so that I can use it whenever I will be doing all these things in the Terraform way. So I will go in here or I can use a comment line. Okay, so I have commented it so that I can use it later when we will be performing all these things using Terraform way. Okay, so we are done with it. Now what I can do, I can click on create. So there are three steps here. First, we added a managed identity. You can go ahead with user based identity. I went with system based identity. Then I need to add extension so that I can add a feature for enable Azure Active Directory SSH login method. Now let's wait for it to get deployed, and till the time it's getting deployed, I can go to my VM, I can go to access control, then I can go to role assignment. I can click on this role assignment. I can click on add role assignment, and in here, as it's a VM base, so I can take it as machine virtual machine administrator login. Okay, I'm selecting this role. Also, my extension was succeeded, so that's fine. So here I can select for user group or principal, and else I can select for managed identity. For now, I am good with user group or service principal. I can select members and I can select myself here. I can click on select, that's fine, and I can click on next, or I can click on review plus assign. Now, as I already have owner permission, but that's okay. I am doing this for illustration purpose. So role assignment was also done. My identity system managed identity was also provisioned, and also this extension plus application, if I will go in here, so I have my active Azure Active Directory SSH login also provisioned successfully. All right. Now, if I will go and try to connect it, so connect via bash session. Then in the drop down, I am getting option for Microsoft Entra ID. Earlier, I was not getting it. If I will click on connect, so it will directly authenticate my main account that was provided as a role assignment. Now, if I will see that my main account was authenticated here and the VM name is you can see here. Now I can type who am I? So it's my main account. For now, I can exit it or log off. Okay, I can click on close. So this was the Azure way. Let's go ahead. Okay, so we have seen how we can use Microsoft Entra ID to authenticate to our VM, to connect to your VM, right? Now let's go ahead and let's see all these things using Terraform way. We will do all these things using Terraform. Before moving with the Terraform, I will delete all these things that I have done here. First, I will go ahead and uninstall this extension. Then I will go to this identity. Then I will turn it off. Then I will go to access management. Then I will go to access management, access control, then click on role assignment. And I will select my account and I will click on delete. So all these things that I've done using Azure way, it was cleared. Now let's go ahead and let's try to do all these things using Terraform way. So first of all, we need to add a system managed identity to our VM. Now how you will do that? So once we were creating our VM, so you can see we have bunch of small blocks in here. And as this is a property inside VM itself, so you can see it's a property inside the VM itself and all the disk and all these things we have already mentioned. And this comes under the VM itself with the name of identity. So we can specify in here itself. So let's mention identity and here mention type as system assigned. You can also mention user assigned or both. I have saved it. Now the identity type for my VM will be set to system assigned. So for identity purpose, I am good. Now let's move ahead and let's create extension for my VM. If I will go to documentation, so I can search for Azure RM virtual machine. So if I will go to the resources, you will be able to see Azure RM virtual machine extension. So this resource I will be using here. I can just copy this bunch of code in here and I can paste it to save some time. I don't need tags and also it does not need any settings in here. Okay, so let's give the extension name as tfvm1-ext and also let's give the same name for my extension name. All right. Now what's the virtual machine ID? So the ID would be dot tfvm1 dot id. Now who is the publisher? So in here the publisher is microsoft.azure.active directory. So I just need to copy Active Directory and I need to replace it in here. Now the handler version in 1.0 and instead of type as custom script, it would be EADSSH login for Linux. So it would not take from custom script. It will connect to Azure in the backend and it will look for this keyword as an extension. Also, we need to specify this version. So auto upgrade minor version. So let's type that because this is a JSON format and we are writing in HashiCorp language. So I will type auto upgrade minor version and I will set it to true. All right, so looks like we are done. Now let's go ahead and let's also try to create our rule config. So I will give the comment as adding extension in VM, right? Now let's add rule assignments. Okay, so first, for adding a rule assignment, we need to get current context information for our account, and you are already aware of it. We already did this. So we will use a data source of Azure RM underscore client config, and then the name would be current. And I will leave this block as it is. So I have got my current config. Now I need to add one block of Azure RM underscore rule assignment and you are already aware of it, we have also covered it. So let's give it as tf1 rule. Okay, so the first thing it needs is scope. Now what is the scope? The scope, it would take as your rm linux virtual machine tfvm1 and then its id because it will apply to its id. Then the next one is role definition name and here I will take it as Azure virtual machine. So you need to make sure that it should be exact same, else it would get an error. So all the spelling or letter also should be very specific. So virtual machine administrator login. Okay, I will make sure that my spelling is correct. And then at last, you need to specify principal ID, means on which account you are going to apply these things to. So I will use data source. So data as your client config current, then dot object ID. All right. So I am good with it. Now what I have done, first I have try to add identity in my virtual machine block of type system assigned. Now after this, I have added extension and how I got this code. I got these things from my Azure ARM templates whenever I was going to deploy our extension manually from Azure. Then I have deployed one configuration that will take the context for my current account and then I have my rule assignment in here. If I will go in here and if I will refresh this page, so if I'll go ahead and click on connect via bash session, So you would be able to see I don't have enter ID because I haven't enabled it. Also the identity looks disabled, right? And the extension plus application also I don't have any extension. So let's go ahead and let's try to apply it. I will save it and let's go ahead and let's apply Terraform apply. So there are two things to add, right? And one to change. The one to change is like your identity type because it's going to change your VM. It will not go to destroy it and create it again. And the two things that it is going to create is one is role assignment and then one is virtual machine extension. So I will type yes and I will hit enter. So all these things were created successfully. Now if I will go to my Google Chrome and if I will refresh this page, so my virtual machine extension was there, it succeeded. If I will go to identity, so you can see my system managed identity was also enabled. And if I will go to access control and role assignment in here, so you can see my current account was also given virtual machine administrator login. So I can again go to this page. I can go to connect via bash session, and I will again see the option of Microsoft Enter ID. I can click on connect. It will launch in the new browser. And again, I am logged in using my account. So if you will type who am I, so it's my main account. Okay, PWD, so it's my this one. So if I will type LSP underscore release hyphen A, so it will give you the details about your architecture. So it's my 12.22.4 LTS JAMI version. All right. So yeah, that was for this chapter. And in this chapter, we have tried to cover all the aspect related to virtual machine and network. So I would here recommend you to please go ahead and try to create Windows virtual machine on your own. If you want, you can always take help from this documentation. If you found any difficulty, please let me know. I would be happy to answer you. That's it for this chapter. Let's meet in the next chapter with Azure IAM, also known as EntraID automation. Till then, take care everyone. Hey everyone, and welcome to chapter on Azure Entra ID, also known as Azure Active Directory. In this chapter, we will talk about the identity as a service provided by Azure. Earlier, it had name with Azure AD. So if you are seeing anywhere name Azure AD, so there is not much to think about. It's just Entra ID and its legacy name. In this chapter, we will try to connect to our Active Directory, that is in our default directory on our Azure, and then we will try to create user, create group, and assign multiple user to the group. Also, after that, we will clean up all the resources that we have created so far, because after this chapter, we are going to use a very special feature in Terraform which is called Easy API Provider. So I will move to my VM on which I have Terraform working. Till now, we were assigning a role assignment to the user. First, we were creating a role assignment, then we were assigning users to that role. But it's not recommended way. Organization always recommends to create groups for the specific role and then assign the roles to the groups itself. Now, there is one more thing. So if you are going to deploy resources in Azure, so it use Azure RM provider. In case of Azure Active Directory deployment, it uses Azure AD provider. So we will be using that one itself. So I will go to my Chrome and in here I will go to the Terraform registry. Then I will click on browse providers. And if I will go to the bottom, so you can see I have Azure Active Directory. This Active Directory is for on-prem environment, but this is for Azure. So instead of using Azure RM, you would be using Azure AD as a provider or while mentioning the resources whenever you are manipulating users, groups, and assignments. Okay. So in here, before moving forward, I will click on use provider or else I can go to the documentation. So here are all the details like Azure provider can be used to configure infrastructure in Azure Active Directory using Microsoft Graph API. In the backend, it will be using Microsoft Graph API to manipulate your data. And it's also telling that in October 2023, Azure Active Directory was renamed to Microsoft Entra ID. but here it's still Azure Active Directory, so they might think to change in the future of name from Azure Active Directory to Microsoft Entra ID. We have mentioned tenant ID earlier and we have mentioned subscription, so that's fine. We don't need to mention it. We can skip it. But yeah, we do need to mention Azure AD as a provider. So I will copy this and I will go to VS Code and I will paste it. Now here you can see we have discussed about it. So this will always look for the latest patched update and it will try to fetch that which is near 3.1.0. Alternatively, you are getting bunch of options to configure it, but for now you can skip it. In case of tenant ID, we can also mention this in the tenant ID provider because tenant ID is specifically assigned to your Entra ID. So if I will go for Microsoft Entra ID, so you can see I have this one as tenant ID. I can copy this one first. I can go here and in the provider, I can mention this. For tenant ID, I will go to Azure and I will copy the tenant ID and I can replace it. However, it will work without tenant ID because it has already detected whenever we typed AZ login and it asks for confirming the subscription ID and tenant. So we already configured it. But if you still want, you can do that. That's okay. We will be in the safe hands. Okay. Now once done, we need to type Terraform in it so that it will detect a new providers and plugins and it will initialize it. So looks like it was done and we are ready to move ahead with Azure Active Directory or also called Microsoft Entra ID. Moving forward, I will be using Entra ID as a name. I am hoping till now you are clear with the term Entra ID and how Terraform is working in the background to authenticate and to get details of Entra ID resources or its component in the background. Now let's go ahead and let's create a demo user in your Entra ID. For creating a demo user, definitely I will be using a demo Gmail or mail account. But in your case, if you are working on an organization, so you will have your own domain, so you can mention that instead of mentioning the demo email ID. For creating a user, I will go to my documentation and in here, if I will go to the user section in here, and basically all these things or all these domains in the Entra ID are isolated to each other and all are in separate resource type. I will click on Azure AD and in here you will be able to see that you definitely need these permissions in order to perform these operations. In my case, so I am using it and I am the owner of my subscription, so definitely I will have all these permissions. Make sure that you should have either a as user administrator or global administrator role assigned to you. If you're talking about API permission, then you should have these permission in order to create user or modify user. So I will go ahead and I will copy this and in here I will create a new file. Let's give it as entra.tf and I will paste the code. For Azure AD user, I will give it as user1. Okay, and in here I will not give this, I will give this William J at the rate devopschannel.com, right? The display name would be John William, and for the mail nickname, let's give William J, and the password is fine because we are not going to use it. So I can save it, and if I will go to my Microsoft Entra ID, if I will go to manage and if I will go to the user section, so you can see I have only one user and I'm just a member of this group, but yes, of course I own this. And you can see that this is my default directory for my account, but of course you can have access to multiple directory with your Azure account. Okay, now I will go ahead and I will save it and I will click on Terraform apply. Whatever resources we created earlier, they will not get changed. They will be like as it is. Now this thing will get applied. So let's go ahead and let's trigger this. The public IB would be changed, of course, because we are going to do this. And now in here, we can see that it's going to be created one user, and whatever things that I have specified, these are mentioning, but all the default one will be either set to default or they will be set to disabled. For looking for required parameter or mandatory parameter, you can go to this documentation and you can see all these required parameter or optional parameter here. All right. For example, if I will go to the bottom, we will be able to see that password, even password is optional because we can change it afterwards. But the user principal name is the required field because this is a unique ID of your user, that is principal name, inside your entire Entra ID. So I will provide confirmation as yes, and I will move ahead. Okay, so in here, where we are, as expected, we are getting error because devopschannel.com is not a valid domain and it's getting rejected for creating this user in my domain because this is my default directory. And if I will see the user principal name, I haven't purchased it. So Microsoft has assigned a random domain with my account, and you can also see that it has appended ext means external to my account because it's not a domain account. If it will have a domain account that would be created, so it will not extend this ext as a suffix in your UPN. So instead of creating azurerad, let's go and let's see the invitation here. So in here, I can go to invitation and resources section and I can go to Azure AD invitation. I can go to this section and I have various options to invite the user to my account or to my subscription. These things are mandatory field or required field that you will be seeing here. For me, I will be just going and looking for this basic thing. So I will copy this. I will go in here and I will try to paste this. I will click on invite one and I will give my another account for the invitation. Okay, and I will save it. Now, if I will go and apply Terraform apply, I will go and provide yes as a confirmation. You can see my user type was set to guest. So I can invite my guest user, of course, to my accounts and looks like it was created. Now, how I can verify this? I can go to my this account and I can log into my Gmail because this thing will be sent to my account itself. If I will go to Azure and if I will refresh this thing, so you can see that Sarvottam Singh 23 was invited as a guest, right? And I was also assigned with one external mail. All right, now you can go ahead and assign roles to this user for temporary purpose. This user will receive a B2B invitation on his mail and he needs to click on accept invitation and then he would be able to access this. If you want, you can also reset the password from here and he should be able to access your Azure portal. So for temporary purpose, if you want to play with it, you can go ahead and assign your own personal account as a guest user and you can play with it. As we don't have any purchase domain, so we were not able to create our new user in our Entra ID. But yes, we did invite a guest user with our own personal account. Now let's move ahead. After creating a demo user in EntraID, and of course we were not able to create one on user because we didn't have our own domain, but yes, we did invite a guest user. Now let's move ahead and let's create a EntraID group in our Active Directory. Earlier, we were getting our account context information using Azure RM client config. But in case if you want to play with Azure AD, so you have the same command and you need to mention data source. So here it would be data, then Azure AD underscore client config. Okay, so looks like we are missing something. So I will mention data, then Azure AD underscore client config, and the name would be just like earlier one, it's current. So this time, instead of getting context information for your resources, this time it will get the context information related to your intra IT. And again, you should be sure that you have sufficient privilege to perform all this operation on your Active Directory. Now, once we have got the context, so I can take this as an empty block, that's fine. So I can create a group and I can mention resource, then Azure AD underscore, and let's give the group name as access, remote access users. All right. Here you need to specify three parameters. First one will be your display name. So remote access users. Then the next would be owners, and who is the owner here? In case of owner, I would assign it to my account. Data.azure client config.current, and then the object ID. And the next thing we need to check, if you want to enable security, so I will assign it to true. Okay, and I will save it. If I will go to Azure, and if I will go to default directory, if I will go to groups, so I will not have any groups here. So you can see I don't have any groups. If I will go to all groups, so I don't have any groups. I will try to create group here. I will type Terraform apply and I will apply these. I will provide confirmation as yes. And after 24 seconds, it was created. If I will go to Google Chrome and if I will refresh the page, so now you can see I have remote access user group created here. That's how you can create the user and that's how you can create the group. Now let's move ahead and let's assign user to our existing group. Now before moving forward, what I can do in the Azure RM role assignment of TF1 role, instead of getting context for my own account, I will give the context of my group because I don't want to assign it for my account, right? So let's give it as Azure AD group of remote access user and then object ID. And once if I will save it, and once if I will, so till now, if I will go to the VM itself, so if I will go to VM and I will turn it on, and if I will go to the connect via bash session, so you can see I have my Microsoft Entra ID enabled because currently it is authenticated via my own account. My own account has access to this. So here I have assigned, instead of my account, I have assigned the access to this Active Directory group that I have created. Now let's go ahead and let's hit Terraform apply, and I will provide yes as a confirmation. So in here it is trying to first delete the TF1 role because this is the main component and it will not try to modify the existing one. So it will try to destroy it and then it will try to recreate this role assignment for us. And it was done. If I will go to Google Chrome and if I will go to overview page and if I will again go to connect via bash session, so for my account, the Microsoft Entra ID is now gone. I cannot select that. Now only my group has access. This remote access group has access to this TF1 role in which the VM is configured. So what we can do next? We can try to assign our own account to this group. So let's go to Entra ID and let's try to create resource for adding your own account to this newly created group. For creating a new group, you have Azure AD underscore group member resource, and I will give the name in Terraform as add member one because I might have multiple members that I can add here. And in here, it just need two parameter. First one is group object ID. So I need to provide my group object ID, which will take the reference from here. So as your AD remote access user and then its object ID. And then the next thing is the member object ID. So in here, you need to provide the context of your own account. So current dot object ID, right? So if I will save it and if I will try to run Terraform apply again, so this is the resource for adding my own account. You can see it's taking the reference of my account and it will try to add it inside the remote access group. So instead of assigning my own account to the role assignment, I am assigning my account to the group, and then I am assigning access of remote access to my this group. So I will provide yes as a confirmation. And it was just a addition process of my account in this group, if I will go in here and if I will go to overview page, if I will refresh this page and if I will go to connect via bash session, you can see now intra ID is back because my account was added to remote access user group. If I will go to home and if I will go to Microsoft Intra ID, then group, then all groups, remote access users, and if I will go to check these members, so you can see that my account was added to this group here, right? So I'm hoping you are clear with it. Now let's go ahead and let's move ahead. After assigning our own account to the groups, and of course you can assign existing user to your group. But what if you want to get context of existing user? Till now we were using our own account, right? Using and we were getting context via Azure AD underscore client config. But what if you have another user that is already inside your AD and you want to get context of it? So for that, you have a data source for it. So in here, I will remove these things from here, right? I will remove these things from here because I will be using another data source. And here I will be using Azure AD underscore user. And let's give the username as user1. For taking reference of any user, I just need their user principal name. Now, what is this user principal name? UPN. So this is the required field even you are trying to create a new user. So for getting a UPN ID, you need to go to this user account and you will be able to see this very long email ID. But if you are using a corporate account, definitely it will be very small. In my case, it is a default directory and it was used to sign up to Azure. Microsoft tried to assign a demo ID using external as a suffix so that it can distinguish in whole Microsoft domain. So I can copy this and I can go in here and I can paste it. Okay. Now, once if I have got this thing, as I don't have Azure AD client config, so what I can do in here, I can type data, then dot Azure AD user dot user1, and then its object ID. All right. If I will save it and if I will go ahead and if I will type Terraform apply, okay, so looks like we are getting this thing changed. Okay, now looks like we are assigning this to different thing and this Azure AD client config was not defined. But yeah, let's keep this thing as it is. Means I will keep the data Azure AD client config and current. So I will keep this thing intact. Okay, because I should be owner of it. So yeah, I'm good with it. But in here, I have changed the membership, right? So alternatively and at ultimately it's going to assign my account also, but the way has changed. We are taking the data source using UPN instead of client config. Suppose if the user is not logged in and if you still want to get context of his account, so you can use always UPN. So let's go ahead and let's try Terraform apply, and it's detected that there were no changes in your infrastructure because ultimately it is assigning to my account itself, right? So that's how you can get context of any user inside your enter id using this block, using this data source. And of course if you want to get context of your own account, means from which you are logged in, so you can get using this one. Okay. Now with it, let's move ahead and let's see the next topic. The next thing is if you want to perform a bulk operation. What if you want to assign multiple user to a single group? Let's see that in case of Azure. So if I will go to my group members, so I can see I have user, but of course you can perform bulk operation in importing the member. You can upload one Excel file and then you can provide the required blocks as a column and row, and then you can upload it. Whenever you will upload it, it will detect the UPN number and it will assign those users to the group. But don't you think there should be way on Terraform itself for assigning multiple user? So yes, there is a way for creating that. For achieving this, I will be creating another input variable of list of string. So let's give variable and then give it as remote access users. I'm giving the same name. Let's give remote users because in my Terraform I have already given remote access user to another resource, right? And the type I would like to give it as list of string. Okay. Now in terraform.tf var, your default var, you need to specify remote user and you need to specify their value. Now in here, it should be user principal name. So if I will go in here and if I will go to my account, so again in here for getting context of any account, you need to specify user UPN name here, right? So I will go in here and I can comma this and I can again paste another value here, right? So this is my one account, but suppose I have another account. If I will go to my default Active Directory, if I will go to the users, in my case, I have another guest user as access, so I can copy this one. I can go in here and I can type comma and then I can add one more user in here. Okay, so looks like I have done that. Now how I can pass this in my entra.tf file. So in here, I will change this one and first I will be using account variable because this is the list of strings. So first I need to take the indexes of all the elements, means how many total index or the length of my string is, and then I need to pass it inside the next block so that it will iterate through that. So I will use length function to take the length of my var dot remote user. So what is the count that will be passed here? So it will be passed to 2. I will save it. Now, what is the user principal name? The user principal name in here will be passed as var dot remote var dot remote user and then count dot index. Okay, so that's how you can pass multiple user principal name using this one. Now, if we are done, we also need to add all these user to our own group, right? To the group that we have created, that is remote access group, right? So let's go ahead and let's iterate through that. So in here also, I will copy paste the same thing because I need to take count so that I can iterate through the indexes. So group object ID would be same because we haven't changed anything in the group object ID, but yes, we would need to change the member object ID. For getting the member object ID, I will take data dot azurerad underscore user dot users. So this one. Then I will take each of the index of this block, means it will take first one, then it will take the details and it will pass to it, then it will take two. And for each of them, we want to pass object ID, right? I will save it. And actually, I don't need to provide this codes in here. I should be good. And let's go ahead and let's hit Terraform apply. And looks like it is giving these things that first it will try to apply Terraform Azure AD add member 1 and it was moved to Azure AD add member 0 and 1. So two indexes were passed here. Inside here, two attributes were unchanged because this is why my existing user. For him, the member object ID would be same. Now for this user, for my personal account, the guest account, these two things will be added. So I'll provide yes as a confirmation and let's go ahead and let's add this user. If I will go to default Active Directory, if I will go to the groups, and if I will go to all groups, remote access user, if I will go to members, so now you can see I have my both account added to here. If I will go in here, so you can see that it was changed. So at one time, I have added multiple user in here, right? With it, we have covered how you can create new user, how you can invite a guest user, how you can create group, how you can add one user to your group, how you can get context of any user in your intra ID, and how you can add multiple user to your group. We have configured multiple things in our AD chapter. Let's move ahead. With it, let's go ahead and let's perform Terraform destroy. Although we haven't used this command so far, but it would be very helpful for running this command right now because we have deployed multiple resources, and if we are talking about VM and bash session, so this will cost us more. So let's go ahead, let's perform Terraform destroy to clean up our resources in our infrastructure. It will delete all these things and it will clean up our infra. So in here, you can see that in my main.tf and intra.tf, whatever the resources that was provisioned, it will try to delete all these things. Okay. But yes, I have other Azure 4, Azure 3, and Azure 2 lab. So if I want to delete resources created in that labs, so I need to perform Terraform destroy while moving and navigating to those labs. Okay. So for this lab, we have tried to create public IP that is also billable, that also cost us. Then we have NIC, we have tried to deploy NIC, then we have tried to deploy our main Linux virtual machine, which will also be costing. So let's go ahead and let's apply Terraform destroy finally. So it's first trying to delete and check the status of all these things. If any of these things will be changed or deleted in your from your Azure, and if you haven't done from Terraform, so you might get any warning or error even itself. So first you need to use Terraform apply and then Terraform destroy. So we are getting these things and you can see that public IP will be deleted and all these public key that was stored in Azure Key Vault, it will be also get deleted. This local file will be also triggered and this will be also deleted inside my VM itself, right? Then the virtual machine extension and the virtual machine, all those will be deleted. So I am good with this. I'll provide yes as a confirmation and I will delete these things. Sometimes while deleting the resources, you might got error. That might be because suppose if two of the resources are attached to each other, so Terraform does not know that this resource resides in one main resource. For example, the Terraform does not know that Azure subnet reside in Azure VNet. In parallel, it's tried to delete both Azure VNet and Azure subnet. But suppose if it has tried to delete Azure VNet first and after it is going to check for Azure subnet, so you might get an error that hey, it's not found. Most probably it will be like warning because the VNet itself was deleted. Of course, if you will go to if you will go to Azure portal and if you want to delete the resources from here, so you can delete this. From here also it's pretty easy because you already know that our resources are bundled in something called resource group, right? So you can click on any of the resource group and whatever the resources deployed within this resource, it will be deleted. So you can go to any resource group and you can click on delete resource group. So whatever the resources that reside inside it, they will be also get deleted. But in my case, I will be performing all these things from my Terraform itself. Once Azure 5 Terraform destroy will be completed, I will navigate to Azure 4 and I will delete these things. And I will run Terraform destroy in that lab also to completely clean up my resources because if any of the resources, for example, even a public IP will be left, it will cost me unnecessarily. So make sure you definitely perform Terraform destroy if you don't need the resources and if you don't want to get built by Azure without using the resources. And Azure Bash session took much time to create it. It will also take much time to delete it. Okay, so I will delete the resources and I will clean up my Azure environment. So that's it for this chapter on Azure Active Directory or EntraID, in which we have covered how you can create user and manage users and group. Now let's move ahead and let's meet in the next chapter. Till then, take care everyone.
Hey everyone, and welcome back to chapter 9. In this chapter, we will talk about a very special provided via Microsoft itself to Terraform, which is called Azure API. Unlike our other provider like Azure RM or Azure AD, so actually they were created by Terraform or HashiCorp developer itself via collab of Azure developer. But this easy API is completely developed by Azure itself, and in Terraform platform it will be showing as a partner. They are not developed by HashiCorp. Now, what its behavior, how it works. For Azure RM, we were defining individual resource, and for each resource, Azure RM had its own name. In Easy API, we have a block name of same type that is called Azure API underscore resource. And then in this kind of resource, you will deploy every resource inside it. In here, inside the Easy API underscore resource block, you will just change the type of the resource that you are going to deploy. Basically, you will change its schema version that is currently in production or currently in working right now. And then you will define a body block. In the body block, you will define what are the different properties that they contains. The properties definitely depend on what kind of resource you are using. So let's head over and let's learn about Azure API. I will go to my Terraform registry and inside here, so if I will go to provider and if I will go to Azure, so here I am on Azure RM template, right? And it's by HashiCorp. And if I will go to documentation, so in here you can see for each of the resource, we have different type of blocks. For example, if you want to deploy container, you can go to this kind of a specific resource, which is called Azure RM Container Registry, right? And you just need to define its properties. That's it, right? Now the easy API for some developer it might be tedious, but some developer prefer it very easier than the Azure RM, but it's totally depend on how you use it. If you are from Azure background, you definitely must have heard about Azure RM templates, also known as ARM templates. So they also work similar like that. They use a schema and then you need to define properties in the JSON format. In here, we will define it in HashiCorp configuration language. For each of the resource in Azure RM provider, we have different type of resource, right? So now, if I will go to providers and let's head over to our Azure Azure API. So I will search for AZ API and it should load it in a bit. And you can see the very first we are seeing at it as a partner Azure API. So let's go ahead and let's click on it. So now you can see that this is a partner and it was developed by Azure itself, means Azure developer helped to write this code and all the source code are on GitHub. So you can click on this link and you will be able to redirect where all the source code are stored. If we want to use this provider, definitely we can go ahead and we can write this in our code. We will do that soon. Now, if you will go to the documentation section, so you can see we don't have much resources here. They are just the schemas here that you need to define. So they are not for our use. But if you will go to the resources section, you will be able to see that there are only bunch of resource, only four. What we are looking for is called Easy API resource. In this category, if I will go at the bottom, you can see that here it's taking Azure RM underscore resource group for its use, and here it is trying to create Azure API resource of type container registry in here itself. So if I will illustrate you on the overhead,
So this is an example of creating a container registry. In here, all the resource that you will create for AzAPI, so it will start for AzAPI underscore resource itself. You can distinguish inside your Terraform environment with the name that is highlighted here. Then you have type that you definitely need to define, similar like your Azure ARM template, and this will be whatever category you are in. For example, for VMs, it will be Microsoft.compute. For network, it will be Microsoft.network, right? For a container registry, it's Microsoft.container registry. Then what kind of resource it is, and then what is the API version or what is the deployment version that you need to define. So this thing changes by time to time. I will also tell you. So in here, it's only giving the example of, I think, container registry, and also it might have some more example here. Okay, so looks like it does not have. It's only have example of container registry, right? But what if you want to have some example and if you want to check what is the different type of properties and parameters that it has supported. So for that we will come soon. Then at next you need to define the name. What is the name of that resource in Azure? So this is the name or ID that it will be assigned in the Terraform itself. This will be in your Azure. Now here it this is the new one, unlike your Azure RM. So it's a parent ID. Now this parent ID will tell you where you are going to keep it. According to the Azure hierarchy, any resource would be inside your resource group. So in most of the cases, it will be go inside the resource group. Now there is one question I would like to ask. Suppose if you want to define a resource group, so what should be the parent ID? Can you guess? So if you have guessed it, so that's correct. If you haven't, then this also okay. So for resource group, the parent ID would be the reference of our subscription ID. Okay, because that is according to the Azure. Then as usual, you need to define its location and all the other properties that supported by that particular resource. Okay, so this was the very example of Easy API. Now how you will find the documentation about all these things? So for that you can go to this link, learn.microsoft.com, then English US Azure templates. Then if you will come in here, it will give you example of all the resources that are in Azure with the help of three things. Either if you want to deploy a new deployment language by Azure that is called Bicep, or if you want to deploy using ARM templates, so you can deploy it, or even in the Terraform. Now whenever you will click on Terraform, this is your easy API provider. Whatever you will select, this will be your easy API provider. Okay, so in here, suppose if I want to search about virtual machine, so I will search for virtual and then machine. So it will show you various type of virtual machine inside this particular component. So you don't need to think about this. You are looking for the template itself, not lab services. You are looking for the main compute resource. So if I will go to virtual machine compute, so you can see the current deployment version that is being used is 2025-0401. For checking about its all the required properties and parameters, you can click on this link and it will take you here. If I will click on Terraform, so you can switch between all these things if you want to learn about Bicep. So Bicep is very easy language and it's on by Azure itself. Then ARM templates, which uses a JSON format for deploying your infrastructure, and basically you can export a ARM template at the very end page of your deployment of your Azure. Then at the end we have Azure API. Now this is the parameter and you don't need to copy all these things because in this one most of them will be the optional parameter, right? So first let's go ahead and first let's set up our provider here. So let's set up our AzAPI provider and let's go ahead with creating some most famous resources like resource group, your networks, your VMs. Okay, we will not be able to create all the resources again with the help of AzAPI because AzAPI needs its own course for its deployment. okay, because it support bunch of options, and also it is kind of extend an advanced version of Azure RM. Okay, so let's head over to our VS Code and let's navigate back cd dot dot. Then I will create, if I will list the files, so I have Azure till Azure 5. Let's go ahead and create a directory called Azure 6. Okay, and I will navigate to Azure 6 and I will open my VS Code in here. And my VS Code was open. I can close the another window, and in here I will create my basics file like earlier. So main.tf, then versions.tf, then variables.tf, then terraform.tf vars. Okay, in here of course we don't need to specify variables or terraform.tf vars because we can use it directly inside main.tf. But in case of taking reference of our variables, I'm taking this because we should not forget the best practices when it comes to the production environment. Okay, and your resource group might have a name consisting of your environment or application name, so you can also create a variable for your environment name or application name, and then you can reference it using a string inside your resource group name or even any resource name. But for now I will take only one variable name, that is called primary underscore region. Okay, and then the type would be string. All right, now I will give the default value of primary string, primary region as Central India because this is very near to me and I can save it. In the versions.tf, I will copy paste the code of my providers here. So I can copy this one. So I can go ahead in here and I can paste the code, and that's it. So now in here I can go and terminal and click on new terminal, and I can initialize Terraform init so that my Azure API provider will be initialized and it will get its modules and plugins in the background, so that whenever I will be typing its resources, whenever if I will go and type its resources, it will give me automatic pop-up of whatever option it has supported. All right, now let's move ahead. I'm hoping now you are clear with AzAPI provider, how it works in the background, how it uses to create resources for Azure. So let's go ahead and let's create some of the basic resource because AzAPI needs its own course if you want to deploy all the resources in Azure. So at the very first, let's go ahead and let's create a resource group on Azure using AzAPI. For creating a resource group, I will go to main.tf, and of course if you want to take help for it, I can go to this page, but in here you can see the example that it's showing. It is showing for container registry, but I don't want that. But this block would be definitely safe. Okay. So in here I will go here and I will search for resource group. So in here it's a resource groups. Inside the resources section, I will click on it and you can see that it's reside in Microsoft.resources and this one. And the current version that it's being using it's 2025-041. But at your time, whenever you will be seeing this recording, so it might have definitely increased. Okay, so make sure to check this URL so that you don't get into any kind of trouble, or suppose if in the updated version if any of the properties is not required, so you might get a warning or error. So make sure to check the documentation. So I'm hoping you have seen how you can see the official docs. For creating resource of any type in Azure API, we have Easy API resource itself. It will be not changed whether you are defining virtual machine or resource group. And the name inside my Terraform environment, I will give it a TFRG. All right. Now the first thing is the name that it will be deployed inside Azure. So let's give it as TF-RG. Then I need to provide its type. Now the type would be Microsoft.resources. Okay, I can copy this from the official docs, right? So that I don't misspell it. Once done, you need to define the location, and the location would be where.primary region. Then at next, you need to define additionally, other than your Azure RM, you need to define parent ID. And as I said in my earlier lecture, that parent ID would be reference to your subscription. So in here, we don't have any reference to our subscriptions. So for that, we need to create again a data source for our own account. Here, let's take the data source data, then easy API client config. Of course, you can take Azure RM, that's completely fine, but let's rely on easy API itself. And the name would be, you already know, it would be current. Okay, so we have got the context of our account information. Now we would be able to fetch the information of our subscription so that we can pass to parent ID, because the resource group, for the resource group, the parent ID would be the subscription ID. All right. So let's mention this. So here I need to provide subscriptions. So make sure you don't misspell it. Then forward slash. Then I need to specify the string concatenation here, and I will specify data dot Azure client config dot current, and then dot my subscription ID. Okay, I need to check what it is. Okay, so looks like this one. So this look fine to me. If I will go to my Azure, and if I will go to subscription, and if I will go to the resource groups, so you can see I don't have any resource group, right? So let's go ahead, let's save it, and let's try to deploy it. So we'll type Terraform. We have already typed Terraform in it, so that's okay. If you want to first verify it, you can definitely type Terraform plan, but here I would directly go with Terraform apply. And looks like it's given us the confirmation that it's got all these things, and my subscription ID was replaced with my actual subscription ID. Okay, so if you don't want to provide this config, you can go to Azure and take the subscription ID and replace here. That will be also fine. I want to, yes, deploy it, so I'll provide confirmation as yes. And it was very fast. You might have also noticed that it was very fast than your Azure RM. Azure RM almost took 8 to 10 seconds, I think, right? So if I will go to Azure and if I will refresh, so I should have my tf-rg resource group in place, right? Now let's move ahead. After deploying our very first resource with Azure API, we are confirmed that our Easy API is fully set up, and also we are following the right documentation. So let's move ahead and let's create public IP with Easy API provider. I will be using the same lab so that afterwards I can type Terraform destroy to destroy my resources. Now for deploying my AzAPI, for deploying public IP, I will deploy AzAPI, and then I will give the name as tf-pip. All right. Now the first thing is the name, and let's give the name also tf-pip. Then next would be the location, and location I will give it as where.primary region, or else I can also give the reference to my this easy API resource, then location. Okay. Also, the best practice would be to mention type in the very first line itself. What should be the type? So it's a public IP, so definitely it would be in Microsoft network. But still, if you want to verify it, you can always go to the documentation and search for public IP addresses, and in here you can go to public IP addresses, and in the network I can go inside here, and you can see I am inside my Terraform section, and this is the current API version that it's been using. So I can copy this. Okay. Now we have defined type, name, location. What should be the next? So yes, you are right. The next should be parent ID. Now where it should go? It should go. inside my resource group, correct? Because this is the resource and all the resources are stored in resource group. All the resource group are stored in subscription. All the subscription are stored in management group. All the management group are stored in tenant root group. Okay. So this is the hierarchy of Azure. For specifying parent ID, I will take AzAPI underscore resource TFRG and then its ID. Okay. Then at next, the next thing comes. So from here, the things will be changed from Azure RM. Here we need to specify body. Now inside body, you need to define properties. Okay. So also you can verify this in here. If I'll go to body, so this might not have any required parameter and all these could be the optional. But similar like in Azure RM, the two mandatory properties in Azure RM would be the same used in here itself. So here I will specify public IP allocation method, and this would be, let's take it as dynamic, and also let's specify public IP address version, and let's take it as IPv4 stack, right? Then after properties block, we need to specify what its SKU, and the SKU I would like to use would be basic. I will save it and I'll verify whether these things are correct. So public IP allocation method, this looks fine, and a public IP address version. Let's also go ahead and let's check. Okay, so public IP address version and public IP allocation method. This looks fine to me, and at the end it will be SQ. Yes, so we are good. And zone would be also if you want to deploy in different availability zone. So this looks fine to me. I will save it. I will go in here and I will search for public IP inside my Azure public IP addresses, and in here we don't have any. Let's go ahead and let's try Terraform apply and let's deploy our public IP. Let's see if we get any error. So yes, we are getting one error and looks like properties.public IP allocation method is not expected here. Okay, and looks like I misspelled it. It would be public. Now let's go ahead and let's try Terraform apply again. And this time the validation was successful, and let's type yes as a confirmation, and it was done. So now you can see it is a similar like structure using your Azure ARM, and it's taking very less time as compared to Azure RM provider. If I will go to Google Chrome and if I will go to public IP and if I will refresh my page, you can see my tf-pip is here and it is of IPv4 stack and the SKU is basic. Okay, so we have defined our public IP address also. Let's move ahead and let's create virtual network and subnet with the help of AzAPI. Now, as usual, I'll provide the resource and resource type would be AzAPI underscore resource itself. Let's give the name as tfvnet, right? Now let's give the type, and the type would be, let's give it as Microsoft.network, and I will copy the same thing in here. Again, if you want to look for the documentation, you can definitely go ahead. So it would be Microsoft.network, and here it would be virtual networks. Also, if you want to verify about it, you can go to here and search for virtual network, and you should not look for Azure Stack or any other else. You can go to changelog and then network and then click on Microsoft Network Virtual Networks. And in here you can see that we are using correct and it would be V small and N capital. Okay, virtual networks and 2025 3 1. So let's go ahead, and looks like we are mentioning yes, we are forgetting S, and it's correct. Now, what is the virtual network required? So first one would be the name, and the name would be, let's give it as tf-vnet, same like your Terraform resource name. Then it's need a resource, and I will provide where dot primary region. Then it's need a parent ID. Parent ID would be the same like your resource group because it will go to deploy inside the same resource group. So I will paste it. After this, yes, it needs some extra parameter like what are the address spaces, prefix. So it need a body. Then in the body, you need to specify its properties. Inside properties, you need to define address space, address space. Inside the address space, you will define address prefixes, prefix, and it could be more than one. So you can define it's in list of arrays. So I will define 10.0.0.0/22, the same which we defined earlier. Okay, it would be prefixes. I will save it. So looks like I'm good. I will apply Terraform apply, and let's see. If I will go to my Azure, and if I will go to home, and I can go to my subscription, and inside here I can go to my resource groups. If I will go to my resource group, so I have only public IP address, right? And at next, I think I'm good. I will define yes as a confirmation, and let's wait for it to deploy our virtual network. And you can see that it was very fast. It just took 7 seconds. It is very fast than Azure RM. And I will go to Azure, and if I will refresh my resource group, so I will have my TF-VNet virtual network deployed here. So I am good with it. Now let's move ahead and let's create a subnet also. So again, I will define resource, and then I will define AzAPI resource. Then in here, I will define tf-subnet 1. In here, I will define type, and the type would be the same like this one. But in here, it would be go inside one more subdomain that is called subnets. Okay, and all other things would be same. Let's give the name, and the name I would give it as tf-subnet 1, the same like my Terraform name that I have assigned. Then we don't need to specify location because it will deploy in the same VNet in the same location. Then yes, this subnet needs to go inside any resource group, so it need a parent ID for sure. So let's go ahead, let's copy this, and once it's done, I need to specify body and properties. Inside these properties, I will specify address prefixes, and I will define, let's take it as 10.0.0.1.0/24. Okay, I will save it, and I will apply Terraform apply again, and it has detected. I will provide yes as a confirmation. Okay, so in here, the parent ID would not be the resource group. It would be your virtual network because subnet is not going to directly go inside your resource group. It is going inside your virtual network. So let's provide easy API, and then it would be tfvnet.id. Okay, so let's go ahead and let's apply it again. It went well. We were assigning parent ID to resource group, but subnet is always going to deploy inside the virtual network. So we needed to define parent ID as a virtual net, not resource group. So let's provide confirmation as yes. Till the time is creating, we can also verify. I can go to the VNet, then I can go to the subnets, and looks like it has already deployed. And yes, it's deployed, and it just took only 6 seconds. So you can see how much it is faster as compared to Azure RM, because in the background it is connecting to Microsoft API directly using Microsoft graph API. Let's move ahead. So now we have our VNet, we have our subnet, we have our public IP. Let's go ahead. Let's first create a network interface card and then let's create virtual machine. For creating a network interface, I can go to the documentation so that I don't misspell its type. I can search for network interface and I'm looking for network interfaces inside my network subsection. Make sure you don't look anywhere else. I can go to this page and here is the example of it. Again, it is having bunch of options, but you don't need to worry about that. So I will just copy this type because I need this one. I don't want to write this lengthy string. And let's go ahead and let's define. So resource, then AzAPI resource. Let's assign the name as tf-nic. Now in here, the first line I would write to is type, right? And it also comes under network. Then I will assign a name. Name would be same like my Terraform name, tfnic. Then in here, it would be the location. Location would be where. Location would be where dot primary region. Then it will take a parent ID because of course it is going to deploy inside the resource group. So I will take tfrg dot id. And then definitely it has bunch of parameters. So I will provide body, then curly braces, and then properties. Then equal to, then curly braces. Now inside here, I need to provide IP configurations. Why I'm specifying IP configuration? Because I might have one or more configuration attached to this NIC. So that's fine. Curly braces because I might have one or more IP configuration. The first one would be the name I would like to give, and let's give the name as public. Okay. Then at next I need to provide the properties block because it also contains properties. Inside properties block I will have private. So I will take private IP allocation method, and in here I will take this and I will take this as dynamic. Then at next I need to specify public IP address, and it would be the reference of my PIP that I have created. That would be AzAPI resource dot tf-pip dot id. Okay. And then also I need to attach my subnet in here. So I need to provide subnet and I will provide the ID of my subnet. That would be AzAPI resource dot tf hyphen subnet 1 dot id. Okay. So I have attached my public IP and then subnet. I will also verify these options in here. So public IP address, and I don't need extended location, but yes, I need an ID, so that's okay. And I don't need properties or DDoS, so that's fine. I can go ahead and then I need to specify a subnet block and then I need to specify its ID. So I have specified subnets. That's incorrect. It would be subnet. Okay. Here it is public IP addresses. So in here, let's go on the top and it's not addresses, it's just address. So let's go ahead and close addresses. I will save it and let's go ahead and let's see whether if we are able to deploy it or not. If I will go in here and if I will go to my resource group, if I will refresh, so I have only three resources as of now. First one is public IP, second one is VNet and the subnet inside it, and this VNet. Okay, so let's go ahead and let's apply Terraform apply. And at the first time itself, we didn't get any error. Let's go ahead and let's hit Terraform apply. Yes, and let's deploy our NIC. And you can see that within 3 seconds itself, it created NIC. So if I will go inside here and if I will refresh the page, so you can see I have my NIC in place within just 3 seconds. Now I am ready to move ahead with Azure VM, especially Linux VM. And in our case, as we haven't set up key vault or private key or public key for my SSH, because of course you can do it with easy API. So I will be using passwords here instead of SSH key. Okay. For creating a VM and for taking help for whatever the properties and parameters that it has supported, I will search for virtual and machines, and I'm looking for a type of compute, this one. So I can click on this one and I am at here. I can click on this page and again I am at here. So here I can go ahead and copy this block here and I can paste it. Of course, I am forgetting a curly brace. Easy API resource, and let's give the name as tfvm1, and the name I would like to give it as tfvm1. The parent ID would be your reference to your resource group because virtual machine is a resource and it will go inside the resource group. So I will define it as easy API rg dot id. Then it needs a location also, and the location would be where dot primary region. So we have defined some bunch of blocks. Now after it, if you will go to the docs, you can see that it has tags also, of course, if you want to mention tag, but it has bunch of various option within the properties itself, of course. So let's go ahead and let's define those block. So first I will define body, and within the body I will define properties. Within the properties I need a hardware profile, then I need a storage profile, then I need a network profile here, and then I need a OS profile. So these are the four profile that you need. In the hardware profile, there are bunch of options, but we don't need to worry about that. We just need to specify the mandatory parameter. In our case, we can just specify VM size. And as earlier, I will specify standard underscore D2 underscore V2. And I'm done with my hardware profile. We will come to storage profile later on because we need to specify image reference and OS disk here. Let's first complete the network profile. In the network profile, we need to assign network interfaces. And why it's faces? Because we can attach one or more interface to our VM. Then I will specify this and then a list of string if you want. And then I can specify codes, and inside here I need to specify ID. And what should be your ID? So it would be easy API resource, then dot, then tf hyphen nic dot id. Okay. So I am done with my network profile also. So hardware profile was done, network profile was done. Now let's first complete OS profile. So OS profile is like your for your credential work or for your mandatory parameters. So let's give so admin user name, and let's give it as admin user. Of course, we haven't created network security group for authenticating or for accessing the VM, but that's okay. Our main agenda here is to create VM and to see whether we are able to create it using AzAPI or not. But of course, if you want to access your VM, you can go ahead. You can even create a key vault there. You can create a network security group. You can attach to your NIC or within your subnet itself, and you can try to access your VM. Then I need to specify admin password, and I'm using a string password here, but of course you can provide the reference of the password from your key vault. So let's give p at the rate password at the rate 123. Okay, then I need to specify computer and then the name, and I will give the computer name as tf-vm1. Then, if it's a Linux, it needs an additional parameter called Linux configuration. And in here, you need to specify disable password authentication. And it should be false because we don't want to disable it. We want to access it via password itself. So my OS profile was also complete. Now we are left with the storage profile, and in the storage profile you need to specify two blocks. First one is OS disk and the second one is image reference. Alright, now in the image reference, as earlier, we first need to define publisher, and the publisher is canonical for Ubuntu 2204 canonical. Then the offer 001 001 hyphen com hyphen Ubuntu hyphen server hyphen Jammy. Then I need to specify SQ and let's use 2204 hyphen LTS. Then the version and I will be using latest version. Now we are only left with OS disk and similar like the option that we have created from our Azure RM, it needs same parameters. So first one is create option and it should create from the image. Then I need to specify caching and it would be read, write, and then I need to specify manage disk because OS disk is a managed disk in Azure. Then storage account type and the storage account type for now I will take a standard underscore LRS. Okay, so I have saved it. So in the body block we have defined properties and in the properties we defined four profile, hardware profile, hardware profile that needs my VM size, then storage profile that needs my OS disk and image reference. The image reference will define what is the image that you are taking and the OS disk from where you want to take this, what is the caching and what is the managed disk or what is its type. Then next to profile coming, other one is network profile in which we need to attach our network interfaces. And then at next it's a OS profile in which you define the upper layer of your OS, which is your admin password, computer name, and whether if you want to disable password authentication in case of Linux. So I am good with it. I'm not sure if it is going to run successfully, but let's go ahead and let's hit Terraform apply. Let's see. Okay, and we got some error and looks like it's saying that OS profile computer. Okay, so we have specified wrong name. It would be computer name. I will save it and let's go ahead and let's hit Terraform apply. So all the needed it just took as a reference. I'll provide yes as a confirmation and it will start creating platform image not found. Looks like we are giving something wrong here. Okay, so in here we are missing one more zero here. It would be 000 then 1. It's not 001. So let's go ahead and let's hit Terraform apply again and let's see whether we got or encounter any issue. And it's again trying to refresh all this data very quickly. And this time also we got confirmation. Let's try to create yes. And it took approx 51 seconds to create my VM. Let's verify this. I will go to my resource group in here. I will refresh the page and you can see my tf-vm1 is in here. So if you want, go ahead, open RDP port, connect it with your ID and password, add NSG to it, and create more resources with AzAPI. Okay, so for now, I am done with my AzAPI illustration. Again, for creating bunch of resources, AzAPI needs its own course. So let me know if you want that. I will also try to create that because you can see it's directly connecting to Microsoft Graph API in the background and it's trying to create as soon as it can as compared to Azure RM. For now, I am done with it and I don't want to get build unnecessarily, so I will type Terraform destroy so that whatever the resources I have created in Azure 6 Lab, it will try to destroy it. Okay, so I will delete it. I'll provide confirmation as yes and I will delete it. Okay, so always make sure you delete the resources because it will cost you unnecessarily. With it, we are end at the discussion of easy API, and I'm hoping you have also enjoyed it same like as I enjoyed while performing these labs. Okay, so that's it for this chapter. Now we have covered all the topics related to Terraform for Azure. Let's go ahead, let's meet in the next chapter and let's discuss where should we go next after this. Okay? Hey everyone and welcome to this very end chapter on the course of Terraform. Even we have completed bunch of topics related to Terraform for Azure, the learning does not stop here. Let's learn about what are the topics or what are the domain that you should focus next in terms of Terraform and if you want to explore more in advanced form. First one is Terraform Cloud or Terraform Enterprise, in which you should learn about more on workspace and state management, how you can create multiple workspaces to move in between the isolate environments, how you can have a remote execution on your infrastructure. You can also integrate Terraform with the Ansible. Also, you can have your own variable set and the policy using Terraform Enterprise. Also, you can learn about Terraform runs and version control workflow and Sentinel policy as code. The next thing you should consider, or the next option you can consider, is Terraform module. We have covered this, but you can go in more advanced pattern like writing your own custom module, how you can create your input and output variable and bundle in within your modules, how you can have module versioning enable for your own module, how you can publish module on Terraform registry itself or even on your GitHub profile, and all the best practices like your folder structure and the drive principle follows in the software development lifecycle. The next option you should consider about Azure landing zones with Terraform. So in here you can deploy spoke hub networks, management groups, blueprints, even policy assignment. You can create it with the Terraform so that all these things in your infrastructure can be automated. Then next option you have Terragrund. You might have heard about it definitely. Basically, this is a overlay of your Terraform itself and fixes code duplication and multi-environment structure like stage, prod, or dev. And also, it's provide a standard for your remote state backends. Next one is very important, the use of Terraform. You can integrate your Terraform with GitHub Action or Azure DevOps practice. You can integrate in your GitHub Action for Terraform plan and deploy. Then you can store your state backend in the Azure storage or even if you are considering about AWS S3 bucket. You can also use it using your OIDC authentication means OpenID Connect. It uses OAuth 2.0 for its working in the background. You can also have Azure DevOps pipelines integrated with your Terraform tasks, and also you can automate your PR checks like format FMT or validate or plan. If you are aware of AKS, Azure Kubernetes Services, then you can also integrate your AKS with your Terraform. So you can automate deploying AKS cluster. You can automate deploying node pools, auto scaling, and identity integration also. You can have your own Azure CNI stack or Kubernetes setup in your cluster with the help of Terraform. Terraform does not stop here. It can help in policy and compliance also. Here you can set up Sentinel policies using Terraform Cloud, and also it will prevent creating public IP or open ports or non-compliant VMs in your infrastructure if you will create your custom policies. Also, you can integrate your existing Azure policy with the Terraform so that it can restrict or allow creating of infrastructure in the backend. Next one is remote state management, which is advanced. So in here you can have a look on state locking, what it is, how it works. You can also set up your remote backend. If you are talking about Azure, then you can use Azure Blob, the same like we did. If you are talking about AWS, then you can store them in the AWS S3 bucket for your state backend, remote backend. You can also learn how you can import and move block for your state management, how you can refactor resource safely, and how you can handle drift. So all these comes under Terraform state management. So if you want to explore more about it, you can definitely go ahead. In Terraform interviews, the remote state backend and Terraform with GitHub action plays a very important part. And also you can have a look on custom Terraform provider. Till now we were only using the published Terraform provider like Azure, AWS, or Azure AD or AzAPI. But these are, but the custom Terraform provider topic is custom and advanced, but become very superpower, in which you will learn how providers actually work, what is CRUD operations, how Terraform plugin framework work, and how you can build your own mini provider and publish them even on Terraform registry, so that other developer or other team member in your team can use it. So these are the topics that you can consider after covering your Terraform for Azure. Also, before moving forward, I would like to talk that ensure that you make sure that you clean up your resources in Azure, especially bash session, because in 3 days, if we are talking about rupees, so in 3 days it will cost you around 700 to 800 rupees. Okay, so make sure you definitely clean up those resources, and I don't want you to get billed unnecessarily. Okay, so with it, we are end to our this very exciting course, and I am hoping you also enjoyed the same way I enjoyed while creating it. So thank you everyone for joining it with me. Let's meet in the next series of chapters soon. Till then, take care. Make sure to subscribe and like my content. Please feel free to provide any suggestion for me. Thank you.